Welcome to this lecture, and in this lecture we are going to be learn about the syntax of this Java programming language. The syntax of the Java programming language is a set of rules defining how a Java program is written and interpreted. The syntax is mostly derived from C and C++ language. Unlike C++ in Java, there are no global functions or variables, but there are the data members which are also regarded as a global variables. Now we can see how to write our hello world program on Java Eclipse IDE. So first of all, we will first create a program that's print the hello world in our editor or a IDE. Create a new file and save it as a name of hello world.java program. So now here you can see create a hello world application. So I just click on that. Here I just create a new file and then I just click on the class. It's need a class, right? Hello.java. And then here I just give it the source of the folder. And so before creating the class in Java, we just need to create the project. So here I just write Java project and the name of the project is our Java course. And I just finish this project here. So you can see our project file is created here. Now I just click on the file, new, and then class. Now here I just write hello.java. So you can see our source file is already added here, which is a Java course and source. So I just click on finish. Our first step is completed here. Now, here we can declare our class in our main method. Our main method is public static void main and string, and then we pass the arguments. So here I just write public and then I just write static void and then main method. This will be executed when the program is running. This method will have the same method declaring every Java program. So here I just pass a string. So S is a capital here and then arguments. Our this program is this line of codes mean our second step is complete here. Then we just open our function body. Now there is a no arguments with this bracket and here we just go to the third step of our first Java program. In our third step, we can write the line of code that will print the hello world. Here we just need to know system dot out dot print and print is line. So this is our print line here and then here I just write hello world. So I just close with semicolon. It look at the component of this line. System tell us the system to do something and out tell the system that we are going to do some output stuff. Now we come to the print line. Print line stand for print line. We are telling the system to print a line in the output and the parenthesis around this hello world means that method system.out.println take in a parameter, which in this case is the string hello world. Note that there are some rules in Java that we have to add here. You must always add a semicolon at the end of every line, like this one. This is a semicolon. Java is a case sensitive language. You must write method names like variables name and the class name in the correct case or you will get an error. Like here you can see I just gave the example like system. System S is in capital here. So I just write a small s so it will give us the red line here. Means you can write the capital S with the system. So this is mean that Java is a case sensitive language. So you can must write the variable's name and the class's name in the correct case. Block of code is specific to a certain method or a loop are encased between curly brackets. Now we just go to the fourth step where we can put it all together. Mean put this Java files or put this Java all work all together. Your final hello world program should look like this one. It's public class hello and then public static void main, which is a string and the arguments. And then we just go to the system.out.println, which will print the hello world program. Now save our file and open it to the IDE. So here I just click on the run. Here you can see the output in our console, which is hello and world. Now we can print our hello world program with one another method, which is the input and the output method. We will now exceed our hello world programs to take input from the user. In our hello world program, we print out a string for the user to see, but the interactive part of the program is when the user gets to enter the input into the program. We will now extend our program to prompt the user for his or her name and then greet the user by his or her name. Now we just create one another class. This is our new example, so that's why I just create the class. So hello.to and Java. So I just opened one another new class. So here we just work with our scanner class. In Java, we have some built-in libraries that we have access to, but we have to import them. One of these libraries in Java is java.util, which contain the scanner objects that we need to get user input. In order to import a scanner class, we add the following lines or to beginning of our code. First of all, here I just import Java and then Java is util. This is the library of java.util, but we just need to know our scanner class. So this is java.util.scanner. This tells us our program that we want to use the scanner object which exists in the package, which is java.util. If we want to have access to every object in the java.util package, we simply write import like this one, import java.util. This will access to the every object in the java.util package. Inside our main method, initiate a new instance of the scanner object. Java is an object-oriented programming language, so it represent concept using the objects. The scanner object is an example of our objects that has fields and methods. In order to use the scanner class, we have to create a new scanner object that we can populate the fields of and use the method. So here in the main body, I just write scanner and scanner is the user. So user, we just take the user input and then, so it's an input and then I just write scanner and which is equal to new and then scanner. Now here I just write system dot in and then close this code here. So our user input scanner is the name of the scanner object that we just initiated. Note that the name is written in camel case. This is a convention of naming variable in Java. We use the new operator to create the new instance of the object. So in this instance, we create a new instance to the scanner object by writing the new scanner, which is system.in. And the system scanner objects take in the parameters that tell the object what to scan. In this case, we put in system.in as a parameter, which is system.in. So system.in tell the program to scan the input from the system, which is the input that the user will type into the program. So now we just go to the fourth step of this program, which is prompt the user of an input. So we have to prompt the user for an input so that the user know when to type something into the console. This can be accomplished with a system.out.print. So now here we just write, sorry, I just write system dot out, and then here I just write print. So what we print here, so I just write what is your name. So I just close this code here, and then now after that we just ask the scanner object to take in the next line that the user type in a store that in a variable. Now here I just write string and then user, which is input, and name, which is equal to user input, and then here I just write scanner dot next and line. In Java, the convention of using an object method is object name dot method name. So this is our object name and this is our method name, and then we just pass the parameter. In user input scanner dot next line, we are calling our scanner object by the name we just gave it, and then we are calling it, which is method next line, which does not take any parameters. Note that we are storing the next line in another object. The string object we have named our string object, which is user input and name. Now we just go to the next step, which is the print out a greeting to the user. Now that we have the user name stored, we can print out a greeting to the user. Remember the system.out print line, which is hello world, that we wrote in the main class. All of the code that we just wrote should go about that line. Now we can modify that line to say system.out.println, which is hello plus user input name plus. So now here I just write system, and then here I just write out. So it's a system.out, and then I just write print line, and print line here is hello, and then we just concatenate plus user and input name. Then I just write plus and then place not sign and close this code here. Now, the way we chant up hello, the username and not sign by writing the hello plus user input name is a string concatenation. What happened here is that we have three string like hello and then user input and not sign. String in Java are immutable, which means that they cannot be changed. So when we concatenating these three strings, we are initially create a new string that contains the greetings. Then we take this new string and feed it a parameter to system.out.println. So now our this program, which is Java util library, is completed here. So now we just simply add main method, which is public, and then it's in static, and void main, and this is a string, and then I just write arguments. Okay, so I just write the parameters here and then copy this all program and paste it here. So I just remove this one, and now it's in time to execute our this program. So I just click on this run file, so run hello 2. So when I just click on this run hello 2, so I just it's need a what is your name. So I just write my name is Fayaz. So it will print us hello and Fayaz because we just concatenate here, which is hello plus user input name. So our user input name is our this input. What we gave the input, which is the Fayaz, and then it's print us hello and Fayaz and then not sign. So thanks for watching this lecture. See you in next lecture. Thank you.
Welcome to this lecture. And in this lecture, we are going to be discussed about the variables and its type in the Java. A variable is a container that holds the values that are used in the Java program. Every variable must be declared to use a data type. For example, a variable could be declared to use one of the 8 parameter data types like byte, short, int, long, float, double, character, or boolean. Each variable in Java has a specific type which determines the size and the layout of the variable's memory. The range of the values that can be stored within that memory and the set of operations that can be applied to the variable. You must declare all variables before they can be used. These are some types of the variable like static variable, instance variable, method local, and method parameters, block variables. So now we just come to the example of this variable. So here in the program body, I just write static and then I just define the integer. So integer is static and static is variable here. So variable value is 1. Now I just write the integer and then here I just write instance variable. So this is our instance variable and the instance variable which is equal to the value of 2. Now I just write public and then void method name, and this is our method name, and here the parameters are int and method. Now here I just write parameters and then I just start my program body. Now here I just define one integer which is the method, and our method here is local. So local is a variable here and the value of this variable is 3. Now I just define my if statement. So here I just write if and the value is true. So here the int block variable. So this is our fourth type of variable, which is the block variable. Now you can see here, first of all, I just define the static variable, which is a value of 1. Then I just give the integer value to my instance variable. This is the second type of the variable. Then I just define the method name, which is the fourth type of variable. So here I just define the public void method name and then the parameters. And then I just define the method local variable and the fourth name number I just define the block variable. Now I define what is a static variable. These variables are declared at the top level. You can see these are declared at the top level. They begins their life when first class loaded into memory and ends with the class is unloaded. as it remains the memory till class exists. So these variables often called class variable. These variables are having highest scope, that is, they can be accessed from any method block in the class. When no explicit assignment made while declaration, they are initialized to default value depending on their types. Now we just see the definition of the instance variable. These are also declared as a top level variable. They begin their life when object or an instance of the class created and ends with the object is destroyed. So this variable R ends when the object is destroyed. Each copy of these variables belong to an object, same as a static ones. They initialize to the default value depending on their types. They are having less scope as compared. They are assist only within the instance method of blocks. Now we just see the example of this definition of this method local variables or a method parameters. Method local variables are declared anywhere inside the method. Their life is started point they declare and initialized and end with the method completes. These variables are not assigned any default value as case of static and instance variable. Therefore, they must be initialized with when declared or later but before assessing using in a expressions, otherwise compiler will complain. Now we just go to the another example of this Java variable. Now here I already create one another class with the name of the variable one. So here our this example, here we add the two numbers. So now I just write public static and void main. Now here I just write string and then arguments. Now the string is a capital here. So now here I just define the integer. So integer a is equal to 10. Then integer b which is equal to 10. Then I just write int c which is equal to a plus b. And then I just write system dot, so it's system dot out and then print line. So print line we just print c and close our code here. So I just save this code and execute our program. So run as a variable 2. So our answer on the terminal end is 20 here. Now we just go to the another example. So here I just click on default new and create a new class. So here I just write variable and variable is 2 dot java. So I just finish this one. So now in this example we just vending our variable. So here I just write public and then static void, and void is a main here. Now I just write string and then I just write arguments and then execute our block. That's static here. Now I just write int a is equal to 10 and then I just write float value. So float which is equal to a. Now I just write system dot out dot print line and then I just want to print which is a, and then I just write system and system dot out and then here I just write print line and then float value. Now I just execute this. So we have the two answers here. which is 1 with system.out.println, which is 10. And then we have the float value. What we give the answer is 10.1. Now we just go to the another example of this variable. So here I just create one another class, which is variable and variable 3 dot java. So here this example is for type casting. So now here I just write public and static void main and then a string and argument. Now I just write float and float f is equal to 10.5 f. And then so it's the float, and now I just write int a, which is equal to integer, and then I just write f. So int a is equal to f is a compiler time error. When we just compile this, so it is our compile time error. Now I just write system dot out, and then here I just write print line, which is f, and then I just write system dot out dot print line, and here I just write a. I just save this code and execute it. So we have the two answers here. First one is in float value, which is 10.5, and then the value is 10. Now we just go to the another example of this variable. So variable 4 dot java. Now here I just write public static void, and the void is main. And then here I just write a string and argument. So this example is variable overflow. So now here we just overflow our variable. So integer a, which is equal to 130. And then here I just write byte value. So byte b, which is equal to byte, and then I just overflow my value of a. Now here I just write system dot out dot print line, and which is a. Now I just write system dot out and then print line, which is b. So b is a variable of byte. Now we just execute it and see how it's overflow. So you can see on the terminal end the value of two variables are, one is 130 and one is minus 126. Now we just see the last example of our variable. So here I just write variable 5 dot java. Yes, I just create a new class, and this example is to adding the lower type in the variable. Now here I just write public and static void main, and then here I just write a string and then argument. Now I just write byte, and byte a is equal to 10. Then byte b, which is equal to 10. So here I just write byte, which is equal to c, so c, which is equal to byte, and then I just write a plus b. So byte c, which is equal to a plus b, is compiled that it is the compile time error, because a plus b, which is equal to 20, will be a integer. So now I just write system dot out dot print line, and here I just write C, and now I just execute this program. So we have the expected output, which is 20, because it is the compile time error, because a plus b will be the expected output is 20 because it is the integer. So these are the some example and the types of variables in the Java. Thanks for watching this lecture. See you in next lecture.
Welcome back to this lecture, guys. In this lecture is our second lecture on the variable. So I had already discussed a variable is a name which is associated with a value that can be changed. For example, when I write integer I which is equal to 10, here variable name is I, which is associated with the value of 10. Int is a data type that represents that this variable can hold integers value. We will cover the data types in the next tutorial. So in this lecture, we will discuss only about the variables. So first of all, how to declare a variable in Java. So first you can define the data type and then the variable and name. So then you can define the value of the it. Here the value is optional because in Java you can declare the variable first and then later assign the value to it. For example, here the number is a value variable and int is a data type. We will discuss the data type in the next lecture, so do not worry too much about it. Just understand that int data types allow this number variable to hold the integer value. So now we just go to the example of this variables. So here you can see we have the character which is a ch. So this is our variable and then we have the character value which is a. Integer which is our data type what we have like an int or a character, and then we have the variable name which is number and number which is equal to 10. So variables naming conventions in the Java. Variables naming cannot contain the white spaces. For example, int number is beer which is equal to 100 is an invalid because the variable name is spaced in it. So you can see int number and beer which is equal to 100. So it will give us the error here. Variable name can be with a special character such as dollar and underscore. So you can write variable dollar which is equal to 10. The variable name can be can begin with special characters. As per the Java coding standard, the variable name should begin a lowercase letter, for example, integer number, like this one. For lengthy variables name that has more than one value, do it like this integer and you can see a small number. It now we can see the in big number which is start the second word with the capital letter. Like here I just write big and then here I just write number. So it is start with the second word with the capital letter. Variables name are the case sensitive in Java. Remember that variables name are case sensitive. Like you can define the variable here big, and then when you create a class or you can create an object and you can recall your variable name. So I just write big, and then here I just write number. So it will give us the error because we have not valid name here. So it's a case sensitive language. Now we just go to the types of the variables. The types of the different variables in the Java. So there are three types of variables in the Java. First one is a local variable, then second one is a static or a class variable, and then the last one is an instance variable. So first we just discuss the static variable. A static variable is a common to all the instance or object. of the class because it is the class level variable. In other words, you can say that only a single copy of a static variable is created and shared among all the instances of the class. Memory allocated for such variables only happens when the class is loaded in the memory. Now we just see the syntax of these static variables. So here we have static, and the static is the name or a keyword here, and then here I just write the data type, then the variable and the variable name. So this is the simple syntax of this static variable. As I mentioned about, the static variables are shared among all the instances of the class. They are useful when we need to do memory management. In some cases, we want to have a common value of all the instances, like global variables. Then it is much better to declare them static, as this can save memory because only single copy is created for static variables. Now we just see the example of this static variable. So here I just remove this, and now I just write static, and static int is count, which is equal to 0. Now I just write public, and public is a void and increment. So now it is public void increment, and then I just write count plus plus. Now I just close with the semicolon here, and then here I just define public, static, and void main. So void main is a string, and a string here, and then I just write argument. Now I just write variable, and it's a variable here, and variable which is demo, and then here I just write object number 1. So I just create an object which is a value of 1, and then here I just write new, and use a keyword here, and then I just write variable demo. So here I just write capital V. So variable is demo here. Now I just write variable which is demo, and then object number 2 here, and which is equal to new and variable demo, and then close this code here. Now I just create an object to it. So here I just write obj1 dot, I just call my increment function here, and it's increment, and then I just write object 1, so it's object 2 dot increment, and then I just print the value system dot out dot print line, and which is object 1, which is the count, and its count is equal to concatenation of object 1 dot count. Now I just write an object here. Now I just write system dot out dot print line, and here I just write object 2, and object 2 is count here, count which is equal to plus object 2 dot count. So I just leave an error here because you can see we are just working with the static variables which work on the class. So we have the class name here is variable data type 2. So I just copy this one and replace with this one because we have the upper class with a variable and its data type 2 is our class name. But I write the variable demo here. So it will give us the error here. So that's why I'm just changing my this name. So remember that this is a Java programming language and it is a case sensitive language. Now we just see the output. So you can see we have the object 1 which is a count 2 and the object 2 is also a count 2 because in this example with both the objects are sharing a same copy of the static variable. That's why they display the same value of count. Now we just see the instance variable in the Java. Instance variable used by object to store their states. Variables which are defined without the static keyword and are outside any method declaration are object specific and are known as instance variable. They are called so because their values are instance specific and not shared amongst the instance. So now we just come to the example of this instance variable. So here I just write a string which is my instance. Okay, and instance is variable here which is equal to instance and variable. Now I just close this code here and then I just write public static void main and then string arguments and here I just write my code. So now so I just remove this curly bracket and now here I just write instance and now I just write the variable data type 3 which is my class name and then object which is equal to new variable data type 3 and close this code here. Now I just create one another object which is the object number 2. So this is the object here and then I just write new which is a variable data type 3 and then close this code here and then I just write object number 3 which is equal to new data type 3 and close this code here. Now I just write system.out.println and which is object number 1 which is my instance variable and then so it's need an extension so I just close this one and then I just write system.out.println and println is object number 2 dot my instance variable and then system.out.println and then I just write object 3 dot my instance variable. Now I just write object number 2 dot my instance variable which is equal to changed text. Okay, and then I just write system.out.println which is object dot my instance variable and then system.out.println which is object number 2 dot my instance variable. Then at the last I just write system.out.println and here print line, which is equal to object3 dot my instance variable. So you can also use the print for it. So now we just check the output for this example. So you can see first one is the instance variable, then the instance variable and the instance variable. Three times, then instance variable. So change the text here and then the instance variable. So we change the instance variable value using the object 2 in the following program. And when we display the variable using all three objects, only the object 2 value got changed. Other remains unchanged. This shows that they have their own copy of instance variable. So we have some rules for the instance variable. First one, they can be marked final. They can be marked transient. They cannot be marked abstract. And they cannot be marked synchronized. They cannot be marked strict FP. And they cannot be marked native. And at the last, they cannot be marked static. So now we just go to the local variable. These variables are declared inside the method of the class. Their scopes is limited to the method, which means that you cannot change their value and access them outside the method. Now we just see the example of this local variable. So here I just write public, and public is a string variable. So I just write my variable, which is equal to, I just write instance variable here. Now I just write public method, and here the public void my method. And then I just define the local variable. So string, which is my variable, which is equal to inside method, and then I just write system and system dot out dot print, and the print line is my variable. So this is our local variable. Now we just going to create an object. So here I just write public static void and main, and here I just write string and arguments. So now I just write, now we just create an object. So variable, so I just copy this class name. So variable data type 4, which is the obj, which is equal to new. So this is the class name, and then the object, which is equal to new, and the variable, sorry, class name. So we are calling the method that's changed the value for my variable. We are displaying my variable again after the method call to demonstrate that the local variable scope is limited to the method itself. Now you can see system dot out dot print line, and then here I just write calling method, and then here I just create object, and it's double quotation here, and then object dot my method, and then system dot out dot print line, which is object dot my variable. So I declare I have declared in this example the instance variable with the same name as a local variable. This is to demonstrate the scope of the local variable. So now just check the output of this example. So you can see calling a method inside the method. So first of all, I just call the method name inside the method. You can see here, and then it's print the instance variable. So you can see the calling method like this one. It's an object here, and then it's print the local variable, and then it's print the instance variable. So this is an example of the Java static instance variable and local variable. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about the data types in Java programming language. A data type in programming is a classification that specifies which type of value a variable has and what type of mathematical relation or a logical operation can be applied to it without causing an error. A string, for example, is a data type that is used to classify the text, and in integers is a data type used to classify the whole number in the string. So there are the two types of data type. First one is parameter data type, and the second one is non-parameter data type. Here you can see the data and the type. First one is parameter and the second one is non-parameter. In the parameter data types, we have the two more types, which are numeric and the boolean. And the numeric have two more data types, which are the characters and integer. When we turn to the integer, so we have the two more parts of the integer. One is a integer and another is a floating point. So in integer we have the byte, short, int, and long. And then in the float side we have the float and the double variable. So in our this course we work with the boolean, characters, byte, short, integer, long, float, and the double. If we go to the second type of the parameter, non-parameter data types. Non-parameter or reference data types are the more sophisticated members of the data types family. We have a string, an array, and more data types in our non-parameter data types. So now we just come to the example of these parameters and the non-parameters data type. So here you can see the data types and default value and the default size of it. So first one is a boolean data type. So boolean data types always is the value of the true or a false value, and it contains the 1 byte size. And the character, it's a default value of any of the character like name or any other string, and it's take the 2 byte. Now we just come to the byte. The value of the byte is 0 and the default size of it is 1 byte. Now we come to the short. Short is a default value of 0 and it is a default size of 2. Now we come to the integer. Integer is always 1, 2, 3, 4, 5 and up to so on. So it is default size of 4 byte. Then we come to the long value. The long default value is 0 length and the default size of it is 8 byte. Then we come to the float value, which we always give the answer in point, which is the default size of 8 byte. And at the last we just take the double and it is a default size of 8 byte. Now we come to the example of byte. This can hold the numbers between minus to plus. It is mostly used to save the memory. And when you are certain that the number would be in the limit specified by byte data types. Now we just see the example of this byte data type. So here I just write public, and public is a static void main. And then here I just write string and argument. Now here I just write byte, which is equal to num. So num is a variable here, and num which is equal to 1 to 3. And then I just write system dot out dot print line, which is num. So I just save this code and check the output for it. So you can see we have the answer in 1 to 3. So now we just go to the short value. So short is the greater than byte in term of size and less than integer. Its range is minus 32 and 768 to 32 767. So it is a default size of 2 byte. Now we just see the example of short. So short, which is num is equal to 45678. And now we just see the right example. So here I just write public and static void main, and then string and arguments. And now I just cancel this, and here I just write short and then number as a variable. So here number which is equal to 28569, and then I just write system dot out dot print line, which is number. So I just save this and execute it. So you can see 28569 is our short value. So the byte data type could not hold the value 150 or 28569 what I gave it here, but a short data type can because it has a vendor range. Now we just go to the long value. So I just create the long data type here, and now long when integer is not large enough to hold the value. So long have the wider range than integer data type. So it's ranging from -9223, 372, and up to so on. It's a longer value to 9223. So I just gave it the example, any example here. So it has a size of 8 byte and the default value of it is 0. So I just write public static void main, and then here I just write string, and string is an arguments here, and then I just write long, and long is a number which is minus 1 2 3 5 6 7 8 9 10, and this is a long number, and I just write L with that number. So here I just write system dot out dot print line, which is number. I just save this code and execute it. So you can see this value is printed here, which is a long value. So now we just come to the double. So double is a scientific for holding 15 decimal digits. So it has a size of 8 byte, and now we just see the example of this double. So public is static void, and then I just write the main here, and then I just write string, and the arguments. Now I just write double and then number which is equal to minus 4236598 dot 9, and I just write D here. So when we see the float value double, so it's a 15 decimal digits. It's contain the 15 decimal digits here. So now I just write system dot out dot print line, and the print line is number. So now I just save this code and execute it. So it is give us the value of the double data type. Now we just come to the float value. So scientifically, for holding 6 to 9 decimal numbers, means float scientifically hold 66 to 7 decimal numbers, and it's contain the 4 byte size. Now we just see the example of it. So public void main, so public static void main here, so public static void main, and then a string and arguments here, and then I just write float. Float is a number here, a number which is equal to 19.98 f. So I just write f for float. So system dot out dot print line, and then I just write number here. Now I just check the output for it. So it is 19.98. What is the value of the number here? Now booleans hold either the true value or a false value. Now I just see the example of the boolean. So here I just write public static void main, and then a string and arguments. Now here I just write boolean, which is b is equal to false. So it is false here, and I just close this with semicolon, and then I just write system out dot print, and the print is b, means the variable of the boolean. So you can see the value of this is false here. Now we just come to the character data types. So characters always hold the characters, means the name or any of other thing. So it has the size of 2 bytes. So now we just see the output for it. Public, static, and void main. And here I just write a string and then the arguments. Now I just write character ch, which is equal to z, and then I just write system dot out dot print line, which is ch. So I just remove this character and add my name, which is Fayaz, and here I just run this program. So you can see the expectations in the thread main java.lang.error, because I just gave the space here. You can see, and you can see character is a only one character like f. If I use the string here, you can see string, which is s is equal to Fayaz. Okay, so it will not give us the error because we have using the string here. So I am using character, so I just write only f here. So I just check the output. You can see it print f. So these are the some data types and its value in Java. Thanks for watching this lecture. See you in next. Welcome to this lecture. In this lecture, we are going to be discussed about the operators in Java programming language. Operators are special symbols that perform the specific operations on one, two, or three operands and then return a result. As we explore the operators of the Java programming language, it may be helpful for you to know ahead of the time which operators have the highest precedence. There are many types of operators in Java, which are unary operators, arithmetic operators, shift operator, relation operator, and bitwise operator, logical operator, ternary operator, and assignment operator. What are the bitwise operators in Java? The bitwise operators in Java define several bitwise operators which can be applied to integer types long, int, short, character, and byte. Binary and operator. Copy a bit to the result if it exists in the both operand. Binary or operator copies a bit if it exists in either operand. Means we have the two binary and operator and the binary or operator. Now we just see the example of the arithmetic operator. So we have the arithmetic operator. So it's operate plus, minus, multiplication, division, and the modulus. So suppose that we have the value a which is 10 and b which is equal to 10. So what will be the expected output? So we have the expected output of it is 20. So same like this minus, multiplication, division, and the modulus. Now we just see the example of this arithmetic operator. So here I just write public void, so public static void main and public static void main, which is a string, and the string here is argument. Now I just write integer, which is num1, and num1 is equal to 100. Then I just write integer num2, means number 2, which is equal to 20. So I just write system dot out dot print line, and the print line here is num1 plus num2. So our result is plus, and here I just write number 1 plus number 2, and I just close this code. So I just copy this code and then pasted 1, 2, 3. We have negative value here, so I just change it to the negative. Then I just write multiplication sign and the division sign, and change it here multiplication sign and division sign. So at the last I just write for the modulus. So here I just write modulus of and modulus of number 1 to number 2. Now we just check the output of it. So you can see okay, and then number 1 plus number 2, which is equal to 20, 120. Okay, and then number 1 minus number 2 is 280. So this is only 120, 80, and this is the 200 and 2000, and this is the value which is 5 and the 0 value. Now we go to the assignment operator. So that's why I just creating a class which is assignment operator dot java. So here in assignment operator we use is equal to, plus is equal to, minus is equal to, multiply is equal to divide and the modulus is equal to operator. So here we just see in the example, so public, static, and void main. So void main is a string here, and the string is the arguments, and here the arguments are, and then I just write the integer which is the number 1 and number 1 which is equal to 10 and int num2 which is equal to 20. Now I just write num2 equal to num1. So this is our assignment operator, and I just write system dot out dot print line, and which is equal to output. Okay, so output, and here I just write plus num2. So num is small here, and our close code is closed here. Now I just write, and I just copy this code and pasted 1 and 2 times, 3, 4 times. So here I just write plus is equal to, and then our system.out.println is plus is equal to. Now here I just write minus is equal to, and this is also the minus is equal to, and this is a concatenation of number 2. Now here I just write static for multiplication and the static for multiplication, and then I just write division and the division here. Now I just write for the modulus, so the percentage sign here and the percentage sign here. Now we just see the expected output. So you can see which is equal to the output 10. So this is a result of the positive, then the output 20, and then 10, which is the output of minus, and then the output of the static value, which is 100, output of division, which is 10, and the output of modulus, which is 0. Do you know about the auto increment and the auto decrement operators? So here I just use num plus plus and num minus minus. So num plus plus here is our auto increment operator, and num minus minus is our auto decrement operator. So how increment operator works? If we have the num value 1, so after the auto increment operator, our num value will be 2, and if our num1 value is 2, so after the auto decrement operator, our expected auto decrement value is 1. Or if we have the num value 1 which is equal to 1, so our after auto decrement the value will be the minus 1. Now we just see the example of this auto increment and auto decrement operator. So now we just see public and static void, so a string argument, and then start our code. Int number 1 which is equal to 100, and int number 2 which is equal to 200. So now I just define the auto increment operator here, and then the auto decrement operator here. Now here I just write system dot out dot print line, and the print line here is number 1 auto increment is, and then I just write plus sign and num1, and then system dot out dot print line, which is num2, and the decrement operator is, and here I just write plus num2. Now we just check the output. So our output is plus plus 4 means for increment it's 100 value, so it is 101. But for the decrement operator, 1 is less from 1 200, so it is 199. Now we just come to the logical operator. Logical operators are used with a binary variable. They are mainly used in conditional statements and the loops for evaluating a condition. Logical operators are AND, OR, and NOT. Now we just see the example of this logical operator. So it's a class, so I just write logical operator dot Java. So here I just write public and static void main. Okay, and then I just write string arguments, and then I just write boolean. The boolean is a b1 which is equal to true, and boolean b2 which is equal to false. Okay, now here I just write, so its the value is true. So now after this false value, I just write system dot out dot print line, and the print line which is equal to b1, and b1 is an AND operator here, and it's a b2. So I just write plus sign, and then b1 and b2. Okay, now I just copy this. So this is our AND operator, and this is our OR operator, and here I just remove this and write the OR operator, and now I just write NOT operator. So I just write the AND for that one, but here I just write NOT, and then and here I just write after this one. So now I just arrange this one. So yes, now here I just write NOT operators means NOT bracket b1 and AND operator for b2. So now we just check the output. So our output for b1 and b2 is false. You can see b and operator here means one is a true, so second one is also a true, so where value will be the true. If one is a false, so value will be the false here. And you can see OR operator, so OR value is true here. And NOT means b1 is not, b1 or b2 is not equal to, so its value is false here. So here it's a not, so its value is true here. So this is our logical operator. Now we just come to the compressions or a relation operator. So we have the six relational operator in Java, which is equal to, not equal to, greater than, and the less than, and the greater than equal to, and less than equal to. So is equal to returns true if the both left side and the right side are equal. Not equal to returns true if left side is not equal to right side of the operator. We just see the greater than, so greater than return true if left side is greater than right side, and less than return true if left side is less than right side, and greater than or equal to returns the true if left side is greater than or equal to right side, and less than or equal to returns true if left side is less than or equal to right side. Now I just see the example of this rational operator. So public is static void main and then string and argument. Now static here, small word. So now I just write integer, which is the number one which is equal to 10. And then I just write int num2 which is equal to 50. And then I just write use if statement. So if number one which is equal to means equal to operator is equal to num2. So here I just write system dot out dot print line, and the print line here is num1 and num2 are equal. Okay, now I just copy this if statement here, and then I just write for else. So here I just write else and remove this statement, and then here I just write num1 and num2 are not equal. So now I just copy this and paste it one time, two time, three time, four time, and five time. So we have first this statement. Now we just write this statement for not equal. So not equal to sign here. So here I just write num1 and the num2 are not equal. So here I just write it's not equal. And then I just write num2 are equal. Here I just remove and use the greater than sign. So after the greater than sign, so num1 is greater than num2. And then I just write num1 is not greater than num2. And then I just use the less than sign. So here I just write num1 is less than num2. And now I just write num1 is not less than num2. So after that, I just write greater than or equal to. So num1 is greater than or equal to num2. And then I just write num1 is not greater than or equal to num2. Now I just use this for less than or equal to. So num1 is less than or equal to num2, and then num1 is not less than or equal to num2. Now we just check the output for it. So here you can see first one is num1 and the num2 are not equal because 10 and 50 are not equal. So num1 and the num2 are not equal. So you can see num1 and num2 are not equal. So here I just write, so yes, it's not equal. So here it's a not sign, so that's why it's not equal here. Then num1 is not greater than num2. So its value is 10 and its value is 50, so it's not greater. So num1 is num less than num2. So its value is true here. So num1 is not greater than or equal to num2. So the value is true here. And at the last, num1 is less than or equal to num2. So the value is less than num2. The value is Now we just see the example of this bitwise operator. Java defines several bitwise operators, which can be applied to the integer types long, int, short, character, and the byte. We have the different types of bitwise operator. First one is AND bitwise, then OR bitwise, then XOR bitwise, then complement bitwise operator, then left shift and the right shift bitwise, then zero fill and right shift operator. Now we just see the example of these all. So here I just write public static void main and then string and arguments. Now I just write int number 1 which is equal to 11 and then int num2 which is equal to 22. Then I just write result and result which is equal to 0. Now I write result which is equal to num1 and I just use AND bitwise operator, so num2. Here I just write system out dot println and then num1 and num2 and plus result. So I just concatenate my result here. So I just copy this result and then I just paste it here. So here I just use OR bitwise operator. Yes, OR bitwise operator. And then I just write for XOR bitwise operator. So XOR bitwise operator. And here I just also write for operator and XOR bitwise operator. Now I just use for complement and this is also for complement and then for left shift. So this is for left shift and left shift. Then I use for right shift and I use this for right shift. And at the last, if you want to shift it zero fill right shift, you can use 1 2 3 time shift and 1 2 3 time shift. So now you can see we have an error because it is XOR operator and the shift left for 2 time, shift right for 2 time, and then shift left for 2 time. Now I just execute it and you can see num1 and the num2 value is 22, num1 and or num2 value is 31 here, num1 shift as a num2 22, sorry 29 here, and num1 is 11, and then num1 left shift is num2 is 24, num1 right shift is 2, and num1 is shifted means it's shifted 0, its value is 2. This is the bitwise operator in Java programming. Now we just see the example of the ternary operator. The ternary operators evaluates the Boolean expressions and assign the value based on the result. Like it's a syntax of variable num1. And then we just check the expressions here. And then we just write the values, and the values are if true. And then we just check the value if false. So this is a simple syntax of this ternary operator. Now we just check the example of it. So our this example is public static void main and then string and arguments. Now int num1 and num2. Okay, here I just write num1 which is equal to 25, and then so we have the no spaces here, so that's why. Yes. So now I just write num2. So num1 is not equal to 10. That's why the second value after the colon is assigned to the variable num2. Now I just assign the second value to the column variable num2. So num2 is equal to num1, and it's the second value which is 10, and then here I just write 100 and 200. Now I just write system dot out dot print line, and the print line here is num2 and concatenate num2. And now I just write num2 which is equal to num1, and num1 which is equal to 25 here, and then its expression, and then I just write question mark sign and 100 ratio to 100. So if the value is true and the value is false, remember that. So now I just write system dot out dot print line, and the print line here is num1, sorry, num2 here, and then I just write plus num2. So num1 is equal to 25. That's why the first value is assigned to the variable num2. Now we just check the output for this ternary operator. So you can see num1 value is 200. So the value is here is let's take a false value here, and then now let's take a positive value here, the true value here. So num1, num2 is 200, and then num2 is 100. So these are the operators in Java and the types of operators in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the control statement in Java. A control statement is a statement that determines whether other statements will be executed. An if statement decides whether to execute another statement or decides which of two statements to execute. A loop decides how many times to execute another statement. A program executes from top to bottom. Expect when we use control statements, we can control the order of execution of the program based on the logic and values. In Java, control statements can be divided into the following three categories. First one is a selection statement, then iteration statement, and at the last, jump statement. So, selection statement. Selection statement allow you to control the flow of the program, execution on the base of the outcome of an exception or state of a variables known as a runtime. Selection statement can be divided into the following categories. First one is if and if else statement. Second one is if else statements. Third one is if else if statement. And at the last, switch statement. So here we just discussed the if statement. The if statement in Java works exactly like in the most programming language. The first contains the statement that can be a block of an if statement only execute when the specified condition is true. If the condition is false and there is no else keyword, then the first contained statement will be skipped and execution continues with the rest of the program. The condition is an exception that returns a boolean value like true or a false. Now we just go to the example. So here I just import one library. So the library here is import java.util, and util is our scanner class. So I just import this library. Now I just write public static void main, and main is a string here. So I just write arguments and then the block of code. Here I just define the integer, which is age, and then scanner class, which is import, and import is device, so which is equal to new scanner, and then I just write system dot in. Now I just write system dot output dot print line, and the print line here is please enter age. So I just take the scanner class here because I am taking the user input. So now I just write age, which is equal to input, and input is device, and device is next integer. Then here I just define my if statement. So if my age is greater than 18, and now in the if statement I just write system dot out dot print and the print line, and here I just write above 18. If my age is above 18, so it will be print I am above 18. So please enter your age. So I am right 19. It is gives the answer you are above 18. Now I just go to the if else statement. I just click on this class if else statement. In if else statement, if the specified condition in the if statement is false, then the statement after the else keyword, that can be a block, will execute. Here I just write, so I import the library, import java util dot scanner, and now I just write public static void and main, and I just write string and argument. Now here I just write int age and scanner input device, which is equal to new scanner and system dot. Then I just write system dot out dot print, and the print line here is please enter your age. Now I just write age, which is equal to input and device dot next dot, so next int, and I just close this code here. Now I just write if age is greater than 18, greater than or equal to 18, so write system dot out dot print line, which is above 18, and If age is not above 18, so what will be the output? So we just go to the else statement. So else is system dot out dot print line, and print line is below 18. I just save this code and execute. Please enter your age. I just write my age is 11-year-old. So you can see it will give us the answer, which is you are below 18. Then I just write execute it, and I just write I am 19-year-old. So it will give me answer which is above 18. Now we just go to the if else if statement. Now I just click on else if statement. So this statement following the else keyword can be another if or if else statement. This statement look like if, and here is your condition, and then a statement, then else if, and the else if condition here, and the statement, and then else statement and the condition of the else statement, and then the statement. So whether the condition is true in this statement, the associated statement will be executed and the remaining condition will be bypassed. If none of the conditions are true, then the else block will be executed. Now I support library import java.util because I'm taking the user input here, so it's scanner class. Now I start public static void main, and I write string and arguments. Then input age and scanner, which is input and device, which is equal to new input device. Sorry, new input, and here I just write scanner and system dot in. Now I just write system dot out dot print and the print line here, and here I just write please enter age, and then I just write age which is equal to input and device dot next int. Now I use if statement. So if age is greater than or equal to 18, and use AND operator, and age which is less than or equal to 38. So system dot out dot print line, which is between 18 to 38. Then I write else statement. So else if is age is greater than 35 and age which is less than or equal to 60. So it's 38 and age is less than or equal to 60. So system dot out dot print line, and the print line here is between 38 to 60. And at the last, I write else statement. So else is system dot out dot print line and not matched. Now we just check the output for this code. So the output is, here I just add I am a 18-year old. So I am between 18 to 38. Then I just add I'm 30-year old. So the age between 18 to 38. Now I write 50. So I am between 38 to 60. And at the last I just write 99. So my age is not matched with the statement. Now we just go to the switch statement. The switch statement is a multi-way branch statement. This switch statement of Java is another selection statement that defines a multiple path of the execution of a program. It provides a better alternative than a large series of if-else if statements. Now I just import java.util and here I just write scanner and then go to the body and here I just write public static void main and then string and the arguments. Now I just write integer age and scanner which is input and input is device which is equal to new scanner and system dot in. Now I write system dot out dot print line and the print line here is please enter age and then I just write age which is equal to input device and it's the input device dot next and next is a integer here. Now I just define the switch statement and the switch is the age of and then here I just define the case. So case is 18-year-old age. So you can always close your age with a colon. Sorry, case with a colon. So I just write system dot out dot print line and here I just write age which is 18 and then we just go to the another statement but here I just break this statement. So after every statement you can break your statement first. Now I just copy this one and paste it one time, two time, three time, four time. So age is 19 here and then 19. My age is 20 and it's 20 here. 21 and 21 and at the last 22 and 22. Now these are the ages. But after that ages, if these ages are not matched, then we just go to the default age. So default value and then here it will print system dot out dot print line and here I just write not matched and then just break this statement here. Now I just check the output for this code. So please enter your age. So I am not 18, 19, 20, 21, and 22. I just enter 25. So it will give me answer was not matched. Then I just write 12. So not a 12, it's 18. So my age is 18. And then 21. So my age is 21. So these are the statement and the control statement in the Java and switch statement. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to discuss about the strings class. Strings, which are widely used in Java programming language, are the sequence of characters. In Java programming language, strings are treated such as objects. The Java platform provides the string class to create the manipulate string. Here we see how to create the string. Now here I just write a string and greeting, which is equal to hello world. So this is a syntax of the string. So here is our string class. This is the name of the string and this is the value of the string. Whatever it encounter a string literal in your code. The compiler create a string object with its value in case hello world. Here you can see the value is hello world. As with any other object, you can create a string object by using the new keyword and a constructor. The string class has 11 constructors that allow you to provide the initial value of the string using different sources, such as an array of the characters. Now we just see the example of this string. So I just remove this. Now here I write public, and public is a static void main. And here I write arguments. Then I write character and it's hello array. We learn about the array in our next upcoming tutorials. So here I just use an array which is a character of hello world, hello array, and then the value of the array is h e l, and then I just write l and o. Now here I just write a dot, and then I just write dot here, and as I just write, I just close this code here. Now a string which is hello string. So this is the name of the string which is a hello string and which is new string. And then here I just pass the parameters which is hello array. So this is the character name here, hello array. Now I just print my this code here. So yes, now so I just write system dot out dot print line, and the print line is hello string. Now we just see the output. So run. So you can see it will print all the hello string array, which is HELLO and dot sign. Now we just see the example and the example of the length string and see what is the length string. Method used to obtain the information about an object are known as accessor method. One accessor method that you can use with the string is the length method, which returns the number of characters contained in the string object. Now we just see the example of this string length. Here I write public, and public is a static void main. And then I write string and arguments. Then I write string, and string is pend rom. Okay, so it's a pend rom, so which is equal to don't dot sa I was taught. Okay, and here I just write length, integer length, and which is equal to plan rom and dot length of it and close it. Now I just write system dot out dot print line, and which is a string length is. Okay, now here is a concatenate length, and now just check the output. So I just copy this and paste it here. So now let's check the output. So our string length is 17. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 here. So this is our string length. So now we just see the concatenating string here. The concatenating class includes a method of concatenating two strings. First one is, here is a string1 dot concat, and then here I just write a string 2. Okay, so this is the number one method. This return a new string that is string number 1 with the string number 2 added to it. At the end, you can also use the concat method to string lateral. As in, you can see here I just write my name is and plus dot concat, and here I just write Fayaz. So my name is Fayaz here. So first one is I just give it the two string number 1 and concatenate the string number 2. And the another method is concatenate and my name. Now we just see the result or example of this code. So here I just write public static void main, and then I just write string, and the string is arguments here, and then a string and the string number 1, which is equal to sa I was, and then I just write system dot out out dot print line, and which is dot, and then I just concatenate my string here. So plus string number 1. So here I just write plus, and then I just write string number 1, and then I just write plus, and plus is thought. Okay, and then close this code. Now you just see the output for this code. So you can see dot and then saw I was and then concatenation of dot. So you can see the concatenating string and the example of the concatenating string. So these are the strings and the types of string in Java programming language. Thanks for watching. See you in next lecture. Welcome to this lecture. In this lecture, we are going to discuss about the modifier and its type. Modifiers are the keywords that you add to those definitions to change their meanings. Java language has a wide range of modifiers, including Java access modifier and non-access modifier. To use a modifier, you include its keyword in the definition of a class, method, or variable. The modifier precedes the rest of the statement. Now you just simply see the example of the modifier. So here you can see public and class and the class name. Then leave it this class body. We just come to the private, and then here I just write boolean and write my flag. Now after this I just write static and the final keyword and double. So doubles are weeks. So week is equal to, I just write 9.5. Then I just go to the protected class. Now I just write here protected. So protected is static and the final keyword, and then I just write int, and int here is box width, which is equal to 45. Now here I just write public, and it's public static void main, and then I just write string and arguments, and then the body of the method here. So what is the work of the private class here? Private number is only accessible within the same class as it is declared. A member with no access modifier is only accessible within the classes in the same package. A protected member is accessible within all classes in the same package and within the subclasses in other packages. Now we just see the protected class. So the protected class is a member, method, or variable. It's just like a package private. Default visibility expect that it also can be accessed from subclass. Since there is no such a concept as subpackages or a package inheritance in the Java. We learn about inheritance in next upcoming tutorials. So declaring a class protected or a package private would be the same thing. So now we just go to the access modifiers. So Java provide a number of access modifiers to set the access level of classes, variable methods, and constructors. Here, four access levels are visible to the package. The default no access, no modifier are needed. Visible to the classes only, which is the private here. Visible to the world, which is public. So public is accessible in all the classes or all the package. So public is visible to all the world. So now visible to the package and all the subclasses are protected. So here we have no modifier, then private, public, and the protected. Now we just see, now we see what is default access modifier. We also call it non keyword. Default access modifier means we do not explicitly declare an access modifier for a class, field, and method abstraction. A variable or method declared without any access control modifier is available to any other class. In the same package, the field in an interface are implicitly public, static, final, and the method in an interface are by default public. Now here the example of non-keyword default access modifier. So I just remove this one, and here I just write, or I just remove this all. So here I just write a string, and string is a version which is equal to 1.5.1, and then I just write boolean and then process order. Okay, and then it's return the value which is true. So this is called non-keyword access modifier, which is a default modifier. Now we just go to the private access modifier. So it's a private modifier. So methods, variables, and constructors that are declared private can only be accessed within the declare class itself. Private access modifier is the most restrictive access level. Class and interface cannot be private. Variables that are declared private can be accessed outside the class. If public gather method are present in the class. Using the private modifier is a main way that an object encapsulates itself and hide data from the outside world. So here we use the private access modifier. Now we just see the example of this private access modifier, and here here I just write private and then string and format. Okay, and then public string, and we just get that format. So format. So this is a format here. And now I just write return, and return is a this keyword and then format. Now we just go to the public class. So public void, and here I just set the format. So now I just write string, and string is the format here. Now this keyword and then format, which is equal to format. Okay, here the format variable of the access modifier class is a private, so there is no way for other classes to retrieve or set its value directly. So to make this variable available to the outside world, we define two public methods, which is getFormat, which return the value of format, and then the setFormat, which is a string and which set its value here. So now we just go to the public access modifier. A class method constructor interface structure declare a public can be accessed from any other class. Therefore, fields, methods, blocks declared inside a public class can be accessed from any class belong to the Java universe. However, if the public class we are trying to access is in a different package, then the public class still need to be imported because of class inheritance. All public methods are variables of a class and inherited by its subclass. We learn about the inheritance in next upcoming tutorials, but here you just need to understand that what is the access modifiers public, class, public, private, and protected. So here I just remove this one, and then how to set the public class. So public we just already used in our alt lectures and the examples, and here public static void and then main and string. The string here, and then you can write the arguments. So these are the public class. So the main method of an application has to public, otherwise it could not be called by the Java interpreter such as Java to return the class. Means you can always write the main method for an application when you declare the public class. Now we just go to the protected class. Variables, methods, and the constructor, which are declared protected in a subclass, sorry, a superclass, can be accessed only by the subclasses in other packages or any class within the package of protected member class. The protected access modifier cannot be applied to class and interface methods. Field can be declared protected. However, methods and fields in an interface cannot be declared protected. Protected access give subclass a chance to use the helper method or variable while preventing a non-rated class from trying to use it. Now we just see the example of protected class. So here is an access modifier. So I'm just giving an example here for a audio player. So I just remove this one, and here I just write after this. So these are the implementation details area. No, sorry, it's was not implementation details area. So here after this I just write protected and boolean. Then I just write open speaker, and then here I just write speaker sp, the short form of speaker. So here this is the implementations detail area. So I just leave this one and then go to the class. So here I just write class, creating a new class here, so which is streaming audio player. Okay, so this is a class name, and then I just write boolean and open speaker, and here I just write speaker sp. Okay, and then I just write this. Then this is the implementations details area. So let's see what I did here. Here, if we define open speaker, you can see open speaker. So the open speaker method is a private, then it would not be accessible from any other class. Then our this means the class name which is access modifier. So if we define it as a public, then it would become accessible to all the outside world. But other intention is to expose with method to it subclasses only. That's why we have use protected modifier. Now we see the non-access modifiers. Java provide a number of non-access modifiers to achieve many other functionalities. The static modifier for creating the class methods and the variables. The final modifier for finalizing the implementation of classes, methods, and the variables. And the third number, the abstract modifier for creating the abstract classes and the methods. And at the last, we have the synchronized and volatile, volatile modifiers, which are used for threads. Now we see the static modifier. So the static keyword used to create the methods that will exist independently of any instance created for the class. Static method do not use any instance variable of any object of the class. They are defined in static methods. Take all the data from parameters and compute something to those parameters with no reference to variable. Class variable and the methods can be accessed using the class name followed by a dot and the name of the variable or a method. Now we see the example of this static modifier. So here I just write public class instance counter. Okay. Now here I just write private, and I just remove this one. So private is static void, and it's a p is a small p here, and a private static void static integer, and then number instance which is equal to 0. then protected, static, and the int. So here I just write get count, and then and here I just write return and num instance. Okay, now here I just write public, sorry, it's private here, and private static void, and here I just write add instance. So add instance, and then it's add instance here. Okay, now I just write num instance plus plus. Okay, and then instance counter and instance counter here, which is dot add instance. Okay, now public static void main and string arguments. Okay, and here I write system dot out dot print line, which is starting with, sorry, it's with, and then I just concatenate instance counter dot get count, and then plus instance. Okay, now I just use for loop here. So we learn about the loops in our next upcoming tutorials. So here I just write for int and I, which is less than 500, and then I just write I plus plus. So now new and instance counter, and then close this code here, and then go to the system dot out dot print line and created plus instance counter dot get count. So here I start plus and then instance. Okay, so this is example of this static modifier. Now we just go to the final variable. A final variable can be explicitly initialized only once. A reference variable declared final can never be reassigned to refer to a different object. However, the data within the object can be changed. So the state of the object can be changed but not the reference. With variables, the final modifier often is used with static to make the constant a class variable. Now I just remove this example and then go to the final variable. So final is a keyword. So final int and value, and the value which is equal to 10. Then public static and final int and any name like nd, which is equal to 6. Then static final, and it's final and string and then title. Okay, so title which is equal to, I just write developer. Okay, and then here I just write public void change, and the change value is, here I just write value, and then I just write value which is equal to 12. So here this value will give error. Here we all declare, in this section we just all declare the constructs, means, sorry, not a construct, it's a declaring all the constants values. So this is a process to declare the final variable. Now you can also be declare final as a method. So a final method cannot be overridden by any subclasses. As I told you, the final modifier prevents a method from being modified in a subclass. So you can also declare a final as a method. So you can see public, and here I just write public final, and I just remove this one, and you can see final void, and here I just write change name. Okay, so this is to declare the method final. So you can see the public final and then void and change name, so method name here. You can also declare final as a class, like the main purpose of using a class being declared as a final is to prevent the class from being subclassed. If a class is marked as a final, then no class can inherit any feature from the final class. So you can see like public and final class, which is test, and this is a body of the class. Okay, now we just turn to the access modifier. So here, yes, I just remove this. So an abstract class never be initiated. If a class is declared as abstract, then the sole purpose is for the class to be extended. A class cannot be both abstract and final, since a final class cannot be extended. If a class contains abstract method, then the class should be declared abstract. Otherwise, a compiler error will be thrown. An abstract class may contain both abstract method as well normal method. Now you just see the example of this abstract class. So in abstract class, we have, sorry, in abstract modifier, we have abstract class, abstract modifier. We have the two types here. So here you can see how to declare the abstract class. So abstract, and then the class. So class name I just write Fayaz. Okay, so this is the abstract class, and then you can write private and double price. So this is a method of declaring the abstract class. Now we just see how to declare the abstract methods. An abstract method is a method declared without any implementation. The method body implementation is provided by the subclass. Abstract method can never be final or strict. Any class that extends an abstract class must implement all the abstract method of the superclass, unless the super subclass is also an abstract class. Now you see the example of how to declare the abstract method. So this is our abstract class. So I just remove this, and now you can see here I just write public abstract class, and I just gave it the name which is super class. Okay, Then I write abstract void m. So this is the method what I declared, which is abstract method. So abstract void and the name. Then here I just go to the class, subclass, and then extends, which is super class. So I just write class and here is a super class. Okay. Now I just implement the abstract method here. So void m and then the body. So this is the method of how to declare the abstract method. Now we just go to the synchronize modifier. The synchronized keyword used to indicate that a method can be accessed by only one thread at a time. The synchronize modifier can be applied with any of four access level modifiers. So we have here transient modifier and the volatile modifier. But we just here see how to declare a synchronized modifier. So I just remove this all and here I just write public and synchronized and then void. So synchronized void and then show details and then the body of the public synchronized modifier. So these are some types of modifier in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the loop controls in Java programming language. There may be a situation when you need to execute a block of code several number of times. Internal statements are executed sequentially. The first statement in a function that execute first, followed by the second, and so on. Programming languages provide the various control structures that allow for more complicated execution path. A statement follows us to execute a statement or a group of statements multiple times, and following is the general form of a loop statement in the most of the programming languages. So we have the different types of loop in Java programming language. Fourth one is a for loop, and then for each loop, while loop, and the do while loop. So now we see what is for loop. So for loop, a for loop is a repetitions control structure that allow you to efficiently write a loop to execute a specific number of times. A loop is a useful when you know how many times a task is to be repeated. Now we see the syntax of the for loop. So here it's a for and then here you can initialize, then you can give it the boolean expressions and then you can do the updates and then your statement will be right here. So the initializing step is executed first and only once. This step allows you to declare a control variable and these steps end with a semicolon you can see here. So this step end with semicolon. Remember that. Next, the Boolean expressions is evaluated if it is true. The body of the loop is executed. If the loop will not be executed and controls jump to the next statement, pause the for loop. After the body of the for loop gets executed, the control jumps back up to the update statement. It allows you to update any loop control variable. This statement can be left blank with a semicolon. Now we see the Boolean expressions. The Boolean expressions is now evaluated again. If it is true, the loop execute and process repeat body of the loop and then update step and then the boolean expressions. After the boolean expression is false, the for loop is terminated. Now we see the example of this for loop. So here I just write my class's name is for loop and then I just write public static and void main, then a string, and a string is arguments, and then here I just declare for and for integer I which is equal to 0 110. So this is a step of initializing. Now here I just give it the boolean, so I is greater than 1. So here this loop check the statement is true or statement is false, and then I write I minus minus. So this is a decrement operator, and now system dot out dot print, and here I just write print line, and then the value of I is, and then I just close this string here and plus I, so concatenate I here. Now just see the output of it. So proceed, and then you can see the value of I is 10 because I is greater than 1. So I is greater than 1, so I value is 10 here. So the loop, so the value of I is 10, 9, 8, 7, 6, 5, 4, 3, 2. So 1, 2, 3, 4, 5, and 6, 7, 8, 9. So it will be executed 9 times because it start with the value 2. So now I just gave it the example of infinite for loop. So infinite means it will be execute the unlimited number of time. So here I just simply make a change like I, and I is equal to 1 here, and I is greater than 1. So this is the increment operator here. So system dot print line and the value of I is and concatenations. Now I just run this code. So and uh, and here I just write I is greater than or equal to 1. So you can see when I just run this code, and the value of I is, so it will be run infinite number. So this is an infinite loop, as a condition would never return false. It will always true. So the initializing step is set up the value of the variable I is to 1. Since we are incrementing the value of I, it would always be the greater than 1. And the Boolean expressions here is I is greater than 1. So it would never return false. This would evenly lead to the infinite loop conditions. Thus, it is important to see the coordination between, the coordination between Boolean expression and increment and the decrement operators to determine whether the loop would terminate at some point of the time or not. So this is the example of the for loop. So I just finished this. So now we just see the example of the for loop iterate an array. So here I just remove this, and now after this int array, and then which is equal to 2, and here I just write 12 and 45 and 9. So we learn about the array in our next upcoming lectures. So I just write 4 and 4 integer here, and I which is equal to 0, and then I is less than array dot length, and then I plus plus. So here I just write system dot out dot print, and the print line here, and array which is I. So here I start with 0, as an array index start with 0 2. So now we just see the example of iterate, and you can see 2, 12, 45, and 9. So this is the output of iterate in array. Now we just turn to for each loop in Java. For each is another array traversing technique like for loop, which is introduced in Java 5. It starts with the keyword for, like a normal in for loop. Instead of declaring or initializing a loop counter variable, you declare a variable that is the same type as a base type of the array, followed by a colon, which is then followed by the array name. In the loop body, you can use the loop variable you created rather than using an index array element. It's commonly used to iterate over an array or a collection class. So here is a syntax of the for loop, which is for, and then you can type a variable and then array. Okay, and then you can write this statement using var means a variable. So now here we just see the example of for loop. Now here I just write public static and void main, which is a string and then arguments. Then here I just write int and the size of array and marks, which is equal to 120, 130, 140, and 150 and 95, and at the last I just write 100. Okay, so close this code here, and then here I just write int and highest underscore marks, and highest marks which is equal to maximum, and here I just write marks. Okay, so now, so here it's a maximum. Okay, so now I just write system dot out dot print line, and then the print line is, so here I just click on the print line, and the print line here is the highest score is. Okay, and then I just write plus highest underscore marks. Okay, and here I just close this code, and then I just write public and static integer, and then maximum, and here I just write int and then numbers. Okay, so now I just open my statement, and then I just write integer, which is max so far. Okay, which is equal to number, and the number here is 0. Now, so it is equal to, so I just write which is equal to number. Okay, so these are the numbers, not a number here, it's a numbers. Now I just write for each loop here. So for and int num, which are numbers here. Okay, and then here I just write if statement. So if number is greater than max so far, and the max so far are max so far, which is equal to num, and then here I just write return value. So return value here is max so far. Okay, and a bracket here. So I just remove this bracket. So its value is return max so far. Okay, now we just check the output for this. So we have 120, 130, 140, 150, 95, and 100. So it will pick only a highest score. So you can see proceed, and the highest score here is 150. So this is a example of a for each loop. Now we just turn to the while loop. A while loop statement in Java programming language rapidly execute a target statement as long as given condition is true. So now we just check the while loop, and this is a program of while loop. Yes. So what is the syntax of the while loop? So here you simply write while boolean expression, okay, and then your statement, okay. Here, a statement may be a single statement or a block of statements. The condition may be any expressions, and the true is any non-zero value. When executing, if the boolean expression result is true, then action inside the loop will be executed. This will continue as long as expression result is true. When the conditions become false, program control pass to the line immediately follow the loop. So how this while loop run? So first of all, it will just check the statement, which is the boolean statement or and the method you declare are in your code, and then it's come to the code, means what you write the conditional code here. Then it check the condition, and then if the condition is true, then so it will go to the block code and then go to the conditions and then execute. If the condition is false here, so it's directly go to the ending point. Here key point of the while loop is that the while loop may not ever run when the expression is tested and the result is false. The loop body will be skipped and the first statement after the loop will be executed. Now we see the example of while loop. So here I just write public static void main and then string and arguments. Then I just write integer I which is equal to 10, and here I just write while and I is greater than 1, and then I just write system dot out dot print, and the print line here is I just pass the parameter I, and at the last I plus plus. So I save this code and execute it. So you can see it's run an infinite number of times. So this is infinite while loop. Now I just write here minus minus. So I stop this and then you can see 10, 9, 8, 7, 6, 5, 3, 2, and it start from 1. So this is an example of while loop. So now we just turn to the do while loop. A do while loop is similar to a while loop. Expect that a do while loop is generated to execute at least one time. Means the do while loop, if a condition is true or a condition is false, it will be executed one time. So the syntax of this do while loop is, so here I just write the syntax. So you can write do and then the statement here, and then you can write while loop and boolean expressions here. Notice that the boolean expressions appears at the end of the loop. So the statement in the loop execute once before the boolean is tested. If the boolean expression is true, The control jump back to, to do this statement, and the statement in the loop execute again. This process repeat until the boolean expression is false. Means when the boolean expression is false, the process will stop work. Now we just see the example of this do while loop. I just remove this, and here I just write public static void main and then string and arguments. Now here I write integer I which is equal to 10, and then I write do. So do system dot out dot println, which is I here, and then I write I minus minus, and then I write while. So while here the boolean expression, so I is greater than 1. So now just see the result. So you can see 10, 9, 8, 7, 6, 5, 4, 3, 2. So now here I just write the increment operator here for the infinite number of time. So you can see it will be executed when this statement is false. So it will be stop work. So these are the loops in Java, which are the for loop, for each loop, while loop, and do while loop. Thanks for watching this lecture. See you in next lecture. Thank you. Welcome to this lecture. In this lecture, we are going to be learn about the arrays in Java. Java provide a data structure, the array which store a fixed size sequential collection of elements of the same type. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of the same type. Instead of declaring an individual variable such as number 0, number 1 and up to so on, you declare one array variable such as number and use number 0 to number 1 and up to so on to present the individual variable. So this lecture introduced how to declare array variable, create array and process array using the index variable. The advantage of the array is first of all a code optimization. It makes the code optimize. We can retrieve or sort the data easily. Then the random access. We can get any data located at any index position. What are the disadvantages of the arrays? First, only the one disadvantage, which is size limit. We can store only the fixed size of element in the array. It does not grow its size at the runtime. To solve the problem, collection framework is used in Java. If you want to solve this problem, so you can use the collection framework in is used in Java. So the types of array in Java are, there are two types of array. One is a single dimension array and another one is a multi-dimensional array, which is also called 2D array. So the example of the single dimension array. Let's see the simple example of Java array where we are going to declare and initiate and initialize and traverse in array. So here is a class of single dimension array, and now I just write public, and the public is a static void main, and main here is a string and arguments. Then I just write int a, and int a here is the array which is equal to new integer, and the array size here is 5. So this is a single dimensional array. So I just declare here and initialize an array here. Now I just initialize array, so index number 0, so which is a value of 10, then a, and index number 1, so I just keep the value 20, then a, index number 3, and the value is 30. Then A, the index number 4, and the value here is 50. And then A and the index number 5, and the value here is 100. So these are our 5 index what we create here, new int and the 5 index array. Okay, so we are initialize this array here. So now I just printing array. So I just use the for loop here. So for int I which is equal to 0, and then I is less than a dot length. Okay, and then I plus plus. So the length is property of an array. So that's why I just gave it the length. So system dot out dot print line, and then a and I. Okay, so our single dimension array is completed here. So I just run this code. So it's static, and I just close this. And now, so this is not give me the output, correct output. I think there is an error in the compiler, but this is a process of declaring a single dimension array. Now we just turn to the multi-dimensional array in Java. So let's see how the multi-dimensional array works. Here I just write static, and sorry, it's public static void main, and then a string and arguments. Now I just write int and int here, so a which is equal to, and then I just write 1 2 3, and I just close with the curly brackets, and then 4 5 6. Okay, and then here I just write 7. Okay, so this is our multi-dimensional array, which is 1 2 3 4 5 6, and at the last 7. And here I just write 8. Okay, now here I just write system dot out dot print, and the print line here. So here I just write length, and length of row 1, and here is a plus and 0. So we have the 0 indexed here. So I just write length, and then I just copy this. So system dot out print line and row number 2, and at the last row number 3, index number 1 and index number 2 here. Now I just run this program. So run, so you can see the length of row 1 is 3. We have the 3 index in this length, and then the length of row 2 is 4. We have 4 index here, and at the last the length of 3 is 1, because we have 3 index here. Now we just see the example of one dimensional array, because our last example was not working properly. So I just decide to do one another example. So here I just write integer and I array, and then which is equal to new integer. Okay, and it's a 3 here. And now I just write I array and then 0, and which is equal to 1. So this is the index number 1. Now I array, and the index number 2 here is 2, and then I array, and the index number 3 here is 3. And then now here I just initialize an array here, and here I just declare of allocation memory of to an array. Now I just display the array elements. So system dot out dot print line. So here is system dot out dot print line, and then I write I array, and the index size is 0 here. Okay, so I just close this, and this is not a comment, so I just remove this quotation here, and this is array. Okay, and it's in index 0. Now I just copy this, paste 1 and 2 time because we have the 3 index here, so index number 1 and index number 2. So index number 2. Now I just use the for loop to display the animal and elements. So here I just write int I, which is equal to 0, and then I just write I, which is length, and length of I array. Okay, and I is I array, and here I just write dot length. Okay, and I is equal to I plus 1. Then here I just write system dot out dot print line, and the print line here is I array, and the array here is I, and then system dot out dot print line, and here is an empty string. And I forget to add the public and public static void main, and then a string here and arguments. So now, and here is the error of array, and it's I array, array, and array. Now I just run this code. So you can see the example of means 1, 2, 3, and then 1, 2, and 3, which is the index of the array, which is index 1, 2, 3, and then 1 space 2 space 3. You can see the string, empty string here. So these are the single dimensional array and the multi-dimensional array in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture, we are going to be discussed about the methods in Java. A Java method is a collection of statements that are grouped together to perform operation. You can call the system.out.println is a method. For example, the system actually execute the several statement in order to display a message to a console. Now you will learn how to create your own method with or without return value. Invoke a method with or without parameters and apply method abstractions in the program design. Now we just see uh, how to create the method. So now I just write here public static int and then main. So I just write its main and function. So you can also call a function to a method. So here int n1 and then int n2. So this is a method and the method name and then the parameters. Now I just start with this method. Here I just write integer main. So I just take this main here, and then I just write if and the if statement n1 is greater than n2. So main, which is equal to n2, and then I write else. So else is main here, and then I write main, which is equal to n1, and at the last return main. So this is the return value of main. So here in this code, the above defined method, which is called main. This method take two parameter, which is n1 and n2, and return the maximum value between these two. Now we just check what is the method calling. For using a method, it should be called. There are two ways in which a method is called. For example, method return a value or returning nothing. So no, if it's not returning nothing, so it have no return value. The process of method calling is simple. So now we just see here, and I just remove this, and here I just write public static void main, and then I just write a string and arguments, and then I just write the integer a, and integer a which is equal to 11, int b which is equal to 6, int c which is equal to main and function. So function here, okay. Now we have the two parameters, which is a and b, and then I just write system dot out dot, and the system dot out, and then print line. So here I just write print line, and then I just write here minimum and value, okay. And here I just write minimum value which is equal to, and then concatenate c, okay. Now I just go to the return in the maximum of two numbers here. So I just write public and static void, sorry, not the static here, it's static int, and then here I just write main, and then return value from our function. So return function and integer n1, and then integer n2 here, okay. And now here I just write int main, and then if same code what I write, and greater than n2, and then main which is equal to n2, and then the else statement, and the else statement here is main which is equal to n1, and then return which is main, okay. So now I just check the output for this code. So here the maximum value between these two is 6. Sorry, the minimum value between two is 6. So this is the method calling in our Java. First we create the method here, and then we just call the method, okay. Now we see passing parameters by values in functions. While working under calling process, arguments is to be passed. These should be in the same order as their respective parameters in the method specification. Parameters can be passed by value or by reference. Passing parameter by value means calling a method with a parameters. Through this, the argument's value is passed to parameter. Now we just see the example of method uh, passing parameters by value. Here I just write public static void main, and then string. After the string arguments, and then integer a which is equal to 30, integer b which is equal to 45, and system dot out dot print line, and the print line here I just write before swapping. So I'm just creating the swapping program here, and then a which is equal to, sorry, and here I just write a which is equal to, and then I just write plus a plus, and then and b which is equal to, okay. Then I just write plus b plus, and then I just invoke the swap method. So here I just write swap and swap. So swap is a function, and here's the two parameters which is a plus and b, and then system dot out dot print line, and here I just write slash n for the single line break, and then I just write now before and after swapping, okay. And now we just go to the system dot out dot print line, and then after swapping a which is equal to, and then plus a and b is, so here I just concatenate b, okay. Now I just write public static void and swap function, okay. And the parameters here is and a and b, okay. And now I just write system dot out dot print line, and the print line here is before swapping and inside, okay. And then I just write a which is equal to and plus a, and b which is equal to and plus b, okay. Now I just swap n1 with n2. So now here I just swap n1 with n2, so int c which is equal to a, and a which is equal to b, and then b which is equal to c. So system dot out dot print line, and the print line here is after, and the print line here is after swapping inside, okay. And then a which is equal to, and here a plus a plus, and then b and plus b. So our program is ready to execute. So here I just create an integer which is a is equal to 30 and b is equal to 45. Then system dot out dot print line, which is before swapping the a value. So here I just concatenate a and the value of b. Then I just create a function name and the parameters. So we are just passing value by the parameter. So we have the parameter a and the parameter b. So at the last, here I just swap the value which is c is equal to a, and then b is equal to a. So a takes b value and then b takes c value. So here c which is equal to a. Now just check the output. So here, yes. So now before and after swapping the value, a is equal to 30 and b is equal to 45. Now before and after swapping the value, and here, yes, before swapping the value 30 and b is equal to 45, before swapping the inside value which is a is equal to 30 and b is equal to 45, after the swapping value inside which is a is equal to 45 and b is equal to 30. So a takes b value and b takes a value. So this is the program for passing parameters by value in method. So these are the methods and the types of method. What we create the method first, and then we just call the method and then pass parameters by its value. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to discuss about the date and the time functionality and the date and time library in Java. Here, Java provides the date class available in java.util package. This class encapsulates the current date and time. So the date class supports two constructors such as date and then date long millisecond. So the date here and the long millisecond. So date, this constructor initialize the object with the current date and time, and date long millisecond. So this constructor accept an arguments that's equal to the number of milliseconds that have in elapsed since midnight, like here I just write January 1st and 2017. So now how to get the date and time using our code. Now here I just import a library, import java.util, and then here I just write date. So this is our library for importing the date, and then public static void main, and then here I just write string and the arguments. Now instantiate a date object. Here date, and then I just write date where is equal to new date. So we just create a date object here, and then we just display the time and date using toString. So system dot out dot print, and the print is line here, and then here I just display the date and time. So date dot to string, and then I just close this code. Now we just check the output for this. So okay, and you can see Wednesday January 17, and this is my time and it's PKT 2018. Now we just see the date formatting using simple date format. So the simple date format is a concrete class of formatting and pausing the date in a local sensitive manner. Simple date format allows you to start to choosing any user defined pattern for date and time formatting. Here in this code, we just import two libraries. One is our java.util and another one is java.text. So here I just import java.util, and then I just import java.text. Okay. Now I just use public static void main and then string arguments. Now here I just write date. So this is the object here, and then now, which is equal to new date. And then I just write simple date format, and which is ft, which is equal to new sample date format, and then it's e, and I just write year here, and then month and date, and here I just write at, and then here hours and minutes, and seconds, and then z. Okay, and here after this I just write system dot out dot print line, and here I just display the date and time. So here I just write current date and plus ft dot format. The format here is d now. Okay, date now. Now we just check the output for this code. So we have the current date, which is Wednesday 2018 and 27 and 17. Okay, and this is my time, and it's 8:27, and this is the second here, and this is my time zone. So this is zone here, and this is my time location. So these are the date and time functionality in Java. Thanks for watching this lecture. See you in next lecture.
Welcome to this lecture. In this lecture, we are going to be discussed about the regular expressions in Java. Java provides the java.util.regex means regular expressions package for pattern matching with regular expressions. Java regular expressions are very similar to the Perl programming language and very easy to learn. A regular expression is a special sequence of characters that help you to match or find other strings or set of strings using a specialized syntax held in the pattern. They can be used to search, edit, or manipulate text and the data. The java.util.regex package consists of three classes, which are pattern class, matcher class, pattern syntax exception. So the pattern class, a pattern object is a compiled representation of a regular expression. The pattern class provides no public constructor. To create a pattern, you must invoke one of its public static compile method, which will then run a pattern object. These methods accept a regular exception as the first arguments. Now we just see the matcher class. A matcher object is engine that interprets the pattern and perform match operation against an input string. Like the pattern class matcher define no public constructors. You obtain a matcher object invoking the matcher method on the pattern object. And then pattern syntax exceptions. A pattern syntax exception object is an unchecked exception that indicates a syntax error in the regular expressions patterns. Now we just see the example of this regular expression exceptions and three types of java.util regular exception package. So here I support java.util, and util here is regular, and I just write match char. Okay, and now I just import java.util.regex.pattern. So these are the two classes library what I import here. Now I write public static void main. Okay, and then here I just write string arguments. Now here I just write string line, and which is equal to this order was placed for, I just write any number like SK900, and here I just write OK. So the string, this string is to be
skin and it will be find a pattern. So now I just place one another string, so which is for pattern, and the pattern here is I just write the pattern and dot and the static here, dot and static, and then I just write double backslash d plus and then dot static. Okay, and close this code here. Now I just create the object to my pattern. So pattern or which is equal to pattern dot compile method. Okay, and then here I just pass an object which is parameter which is pattern. So now I just create an object for matcher, and here is a p and p is a capital here. So now matcher m which is equal to r dot matcher, and here's the input is line. Okay, if a statement and if m dot find, so system dot out dot print line which is found value. Okay, and then I just write plus m dot group, and here's the group value is 0. So our code for this regular expressions is completed here. I'll just run this code and you can see found value which is this string, and this is order was placed for sk900 and okay. So this is example of regular expressions in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about file input and output in Java. In Java, file.input-output library, or we can say input-output package, consist consists nearly every class you might ever need to perform input and output in Java. All these streams represent an input source and an input destination. The stream in the Java input-output package supports many data such as parameter, object, localized, character, and etc. Now, what is a stream? A stream can be defined as a sequence of data. There are two kinds of stream in Java, input and output. First one is input stream and another one is output stream. The input stream is used to read the data from a source, and the output stream is used for writing data to a destination. Like here, the input is used for reading the data. So here you have source and then we have program and then destination. Okay, so input read data from here and then it's go to the program, and then this data used by output stream for writing the destination. So Java provides a strong flexibility support for input output related to the files and the networks. But this lecture cover very basic functionality related to the stream and input output. So we will see the most common example used in this input and output stream, which is byte stream. Java byte stream are used to perform input and output of 8-bit byte. Through there are many classes related to byte streams, but the most frequently used class are file input stream and the file output stream. Now we see these file input and file output stream in our example. Now here, first of all, I just import a library for input and output. So here java.input out. Okay, and here I just write public static void main and then string, and sorry, it's a string and arguments here, and then here I just write throw exceptions. Okay, I will tell you about throw exception in my next tutorials. So exception here, and then after this I just write file input streams stream. Okay, in which is equal to null. So this throw exception is not in bracket. So here there is null, and then I just write file output stream, and here I just write out which is equal to null. Now I just write try. So here I just write int which is equal to new and file input. I will tell you about the throw, catch, and try, and finally keyword in my next coming tutorials. So I will tell you about this in my exception handling topic. So just make a concept here. So I just write stream, and then here I just write input and input dot text. Okay, and then I just write out which is equal to new and file output stream. Okay, here I just write out put dot text. Okay, now I just create an integer which is c, and then while which is c is equal to in dot read, and I just remove this one, and here is a two brackets, so I just make it one. Okay, now after this I just write yes it's true. Okay, now after this I just write not, and then which is equal to minus 1, and close this bracket here, and then I just start my while code. So here I just write out dot write, and right here is c, so c is a parameter. Then we just go to the finally keyword. So here I just write finally, and if I in not equal to null, so in dot closed, and then I just write the if condition again. So if our output which is not null, then we just say out dot closed. Okay, so here I just import these two text file with the input and output, and then I just run this code. So here the code is working properly, and I have no text in these files, so that's why it's not coming here. So this is the file input and output in Java. Thanks for watching this lecture. See you in next lecture. Thank you.
Welcome to this lecture. In this lecture, we are going to be discussed about the exceptions in Java. An exception or exceptional event is a problem that arises during the execution of the program. When an exception occurs, the normal flow of the program is disturbed and the program applications terminated abnormally.
which is not recommended. Therefore, these exceptions are to be handled. An exception can occur for many different reasons. A user has entered a invalid data, so that's why a exception is occur. Or a file that need to be opened cannot be found, and a network connection has been lost in the middle of communication, or the JVM means Java Virtual Machine has run out of memory. Some of these exceptions are causes by user error, other by programmer's error, and others by physical resource that have failed in some manner. Based on these, we have three categories of exceptions. You need to understand them, to know them, how exceptions handled work in Java. First one, the checked exception. A checked exception is an exception that occurs at the compiler time. These are also called a compiler time exceptions. These exceptions cannot simply be ignored at time of compilation. The programmer should take care of handle these exceptions. For example, if you are use file reader class in your program to read the data from a file, if the file is specified in its constructor, it does not exist, then a file not found in exceptions means file not found exceptions occur, and the compiler promotes the programmer to handle the exception. Now we just see the example of this exception. So here I just import a library which is for java.input output, and here the input output is file. Okay, and then I just write, and here is a input output file. Okay, now I just import the library which is java.input output, and java.input output dot file, and here's a file reader. Okay, and this is a capital file here. Now I just write public and static void main, and then string arguments, and then here I just write file and file which is equal to new file, and then here I just write the file name which is in E, and it's a double backslash which is I just name the file here. So the file name here is file dot text, and then I just write file and file reader. Okay, and then fr which is equal to new file reader. Okay, and here I just pass the parameter which is file. So now here file and file, sorry, it's a file reader. Okay, so here it will shown an error exception. So we just run this and proceed. So you can see unhandled exception type, which is file non-found exception here. So this is an error here. So now we just go to the throw exceptions to clear this problem. So what is throw exception? Throw is also a keyword. If a method does not handle a checked exception, the method must declare it using the throw keyword. The throws keyword appeared at the end of the method signature. You can throw an exception, either a newly initiated one or an exception that you just catch, by using the throw keyword. Try to understand the difference between throws and throw keyword. Throws used to postpone the handling of a checked exception, and throw is used to invoke an exception explicitly. So now here we just see the example of this throw exception. So I just create a class which is a name of throw exception.java. So here I just import a library which is java.input output, and then I just go to the coding area, and here I just write public void deposit, and then here I just write double amount. So our deposit is double in amount. Okay, and here I just write throw exception. So throw here is remote exception, and then I just declare the method of implementation of throw exception. So here throw, which is new remote exception. Okay, and then I just write here. So this is a method to throw an exception. Now we just see the another method to throw an exception. So here I just write insufficient funds exception example. So I just leave it this code here, which is throw remote exception. But here I just make one another example, and here I just write comma, and then I just write insufficient funds exception. Okay, and then run my code here. So it is insufficient fund exception. So this is a also example of the fund insufficient exception. So a method can declare that it throws more than one exception. Means if you want to declare throw more than one time exception. So in this case, the exception are declared in the list separate by the comma. Like I want to show this exception and this exception in one program. So you can separate by this comma. Okay. Now we just go to the finally block. The finally block follows a try block or a catch block. A finally block of code always execute irrespectively, irrespective of occurs of an exception. Using a finally block allow you to run any cleanup type statements that you want to execute, no matter what happened in the protected code. So now we just see the example of the finally block. So here's class and new, and here's just write finally, and then it's a Java. Okay, so the syntax of this finally is, first of all, you can define try. So these are the protected code, and then I just catch the exception. So here you can write the exception and its type. Then you can make the object of the exception, which is E1. Then you can catch this block and then go to the catch another exception here. So catch and exception, which is a type, and exception 2. Okay, then you can catch this block and then go to the finally keyword. Okay, so then finally, so this finally block will always execute. If this is not execute, means this block of code, this protected code is not execute, it will go to the another exception, then it will go to the another exception, but finally will always execute, remember that. So here I just clean this code, and now I just use this integer a, then which is equal to new and int 2. Okay, now I just use try. So try here is system.out.print and print line and access. This is system and dot out dot print and then access element 3. Okay, and then here I just write plus a and concatenate plus a 3. Okay, let's close this code. Here after this code I just catch this exception. So catch, and here I just write array size and array index out, and it's an array index and out of and bounds, which is exception. Okay, and the exception object is e. Now I just write system dot out dot print line, and the print line here is, and this is the print line exception thrown. Okay, and here I just concatenate plus e, and now I just go to the finally block. So it's a finally keyword, and here I just write a, which is 0, and then which is equal to 6, and then system dot out dot print line, and which is first element value. Okay, and here I just write plus a and 0, system dot out dot print line, and the finally statement is executed. Okay, so I just close the double quotation here. So here is an error which is a capital F, and this is bound. So this is bound. Now just check the output, and okay, so we have unhandled exception error. So here the finally, and here I forget to add my method, which is public static void main and string and arguments, and this is string and arguments here, and then I just execute this code. Okay, and now yes, now I just checked. So you can see the exception thrown, which is java dot language dot array index out of bounds exception, which is the 3. Okay, and the first element of the value here is 6. You can see here the first element of the value, which is 6, and the finally statement is executed. So you can see this is the final statement which is executed, and this is also the final statement, and this is the exception catch bound. Okay, so thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture, we are going to be start our object-oriented programming concept section in Java. Before starting the Java object-oriented programming, we just need to know why we choose the object-oriented programming. Suppose that you want to assemble your PC. You go to the hardware store and pick up a motherboard, a processor, some RAM and hard drive, and a cache power supply, and put them together. You turn on your PC and the PC works. You need no worry whether the CPU is a 1 core or 6 core. motherboard have 4 layers or 6 layers, and the hard drive have 4 plates or 6 plates. And you don't worry about the RAM is made in Japan or made in Korea, and so on. You just simply put the hardware components together and expect the machine is to run. Of course, you have to make sure that you have the correct interface. Example, you need to pick a IDE hard drive rather than SSD hard drive. If your motherboard support only IDE, you have to select the RAM with the correct speed rating, and so on. It is not difficult to set up a machine from a hardware component. Similarly, a car is assembled from a parts and a component such as they have the doors, they have the engines, wheel, brake, and transmission. The components are reusable. Example, a wheel can be used in many cars of the same specification. Hardware such as the computers and the cars are assembled from the parts which are reusable hardware components. How about the software? You can assemble a software application by picking a routine here, a routine there, and expect the program to run. The answer is obviously no. Unlike hardware, it is very difficult to assemble an application from the software components. Since the advent of the computer 70 years ago, we have written tons and tons of programs and routines. However, for each new application, we have to reinvent the wheels and write the program from scratch. Why reinvent the wheels? Why rewrite the codes? You can write the better code, then use the code written by expert. So here we use the object-oriented programming concept because they have the reusability concepts. We can use code rather than one time, two times, three times, and four times. What is the traditional procedure of object-oriented programming languages? Traditional procedure of object-oriented programming language such as C, Fortran, COBOL, and the Pascal suffers some notable drawback in creating the reusable software components. The procedural object-oriented programmings are made up of functions. Functions are less reusable. It is very difficult to copy a function from one program and reuse in another program because the function is likely likely to reference the global variable and other functions in the global world. Functions are not well encapsulated as a self-contained reusable unit. The procedural languages are not suitable of high-level abstraction for solving the real-life problem. For example, the C program uses constructs such as if-else, for loops, array, methods, and the pointers, which are low-level and hard to abstract the real program problems such as a customer relationship means CRM system or a computer scorer game. The traditional procedural language separate the data structure, variables and algorithms functions. Now we just see the object-oriented programming languages. The object-oriented programming languages are designed to overcome these problems. The basic unit of object-oriented programming is a class, which encapsulates both the static properties and dynamic operations within a box, and specify the public interface for using these boxes. Since classes are well encapsulated, it is easier to reuse these classes in the other words. OOPS combines the data structure and algorithm of a software entity inside the same box. OOP language permit high level of abstractions for solving the real life problems. The traditional or procedural languages such as C or Pascal force you to think in the term of a structure of the computer. Example, memory in bytes and the array, decision, and the loops, rather than thinking in the term of the problems you are trying to solve. The OOP language such as Java, C++, and C Sharp let you think in the problem space and use software object to represent and abstract the entities of the problem space to solve the problem. As an example, suppose you wish to write a computer scorer game, which I consider as a complex application. It is quite difficult to model the game in the procedural object language. But using OOP language, you can easily model the program accordingly to the real things appear in the scorer game. Player attributes including the name, numbers, location in the field, and etc. Operations including run, jump, kick the ball, and etc. And we have the ball, reference, field, audience, and the weather. Most importantly, some of these classes, such as a ball and an audience, can be reused in another application. For example, computer basketball game with little or no modification. So now what are the benefits of the object-oriented programming languages? The procedural object-oriented programming languages focus on procedures. With functions as a basic unit, you need to first configure all or out all the functions and then think about how to represent the data. The object-oriented languages focus on the components that the user receives with objects as the basic unit. You figure out all the objects by putting all the data and operations that describe the user interaction with the data. The object-oriented technology has many benefits is in the software design, and you should think in the problem space rather than the machine bytes and the bits. You are dealing with high level concept and abstractions. Is in the design leads to more productive software development. Is in the software maintenance. Object oriented software are easier to understand, therefore easier to test, debug, and maintain. Reusable software, you don't need to keep reinventing the wheel and rewrite the same function for different situations. The first and the safest way of developing a new application is to reuse existing code, full tested and proven codes. If we are talking about the object in oriented programming language, so let's see what is the object here. So the object here is a car, pen, table, keyboard, bike, etc. So the proper example of the object is any entity that has a state and the behavior is known as an object. It can be physical or logical. Now we just see the example of an object. How to initialize an object. Here I just write a public class object. So it's better to create one another class with the name of class, and dog is an object here. So dog.java. So there is a class which is dog, and now I just declare the class here and then instance variable. I just creating the instance variable, so a string, so dog name, then a string breed, then integer. So we just always take the age in the integer and then string. What is the dog color? Okay. Now we just declare the constructor of the class. So public and dog, and then here I just write a string which is name, and then a string which is breed, integer. sorry, it's comma and integer which is age, and string which is color. Okay, and then here I just write this dot game, sorry, this dot name which is equal to name. Then this dot breed which is equal to breed. Then this dot age which is equal to age, and at the last this dot color which is equal to color. Okay, so these are the constructor declaration of the class. Now we just see the methods. So method number one, public is string. Here I just create a method which is the get dog name. So I just write get name here, and then what is the return? So it will return us which is name. Okay, then method number two. So method number two here is public is string and get breed. Okay, so here I just write return and which is breed. So it's get breed here. Okay, now after that I just go to the method number three. So public, so here is a public string and it will get the age here. Okay, so this is the method number three and the method number four. So it will return age. Okay, then afterwards I just write public string, and here I just write, so this is not the string here because it's age, so it is integer, public int and then age. So string, and string is a color here. So this is method number four, and it will return color. Okay, now so this is the method name which is get color. Okay, and here the method. So afterwards I just go to the override function. So string and two is string. Okay, and then I just write a return, and return here is hi, my name is, and plus here, and here is write this dot get name, and then here is write plus, and then sorry, it's plus, and then I just write slash n for the single line break, and my breed and age and color are. Okay, and I just write plus this dot get breed and plus comma here, and then plus this dot get age plus comma here, and then plus this dot get color. Okay, and then close this code here. Now after that, this I just write public static void main, and then string and arguments. Then here I just write dog, and dog is Tuffy here, which is equal to new and dog. Okay, and then here is write Tuffy, and then the dog name is Tuffy here, and then the breed is Papillon, and it's a papillon, and then it have the age of 5, and the color here is white. Okay, and I just close this code, and I just print my this function to print screen dot print line, and then Tuffy dot to string. Okay, and I just close this code here. Now I just execute this code. So okay, and we have the error here, which is line number 28, and which is get breed. So here it's a B is a capital here. So now I just check. So you can see, hi, my name is Tuffy. My breed, age, and color are papillon, pipe, and white. So as I declare the variable like type name here, so this notify the compiler that we will use the name to the refer to data those type in type with a parameter variable. This declaration also reverse the proper amount of memory of a variable. So for reference variable, type must be strictly a concrete class name. In the journal, we cannot create an object of a abstract class or an a reference interface. The object dog Tuffy, if we declare the reference variable Tuffy, like in our this example, its value will be undetermined, means it's a null value until an object is actually created and assigned to it. Simply, declaration or reference variable does not create an object. So this is a example of initialization of an object in Java. Thanks for watching this lecture. See you in next lecture.
Welcome to this lecture. In this lecture, we are going to be learn about the concept of the classes in object-oriented programming. In last lecture, we just studied the object. So, what is an object? An instance is an executable copy of a class. Another name of instance is object. There can be any number of objects to a given class in memory at any one time. So what is an class? A class is a structure that defines the data and the method to work on that data. When you write the programs in the Java language, all program data is wrapped in a class, whether it is a class you write or class you use from the Java platform API libraries. So class is a blueprint or a template from which objects are created. Class is a group of similar objects, and the class is a logical entity. Class is declared using the class keyword. Example, here you can see public, class, and Java classes. So this is a class name here. Class does not allocate memory when it is created. There is only one way to define class in Java is using a class keyword. What you see here, which is public, class, and Java classes. So this is a keyword here, and this is a class name here. So let's suppose we use a bicycle class as an example. So the bicycle class. So with racing bikes, mountain bikes, and tandem bikes are a subclass of this bicycle class. Now we see the example of these Java classes. So here our this is a modifier, keyword class, and the Java class's name. So now we just write private string and name. So I just close this code with a semicolon. So here we have the modifier, which is a private, and this is a type, which is a string, and then it's a name.
So now we just go to the void. So here I just write public void and set name, and this is string, and string is a value of n. So here we have the modifier, then the return type which is void, and then the method name which is set name, and then the optional parameters which are string n, and then the exception list. Now here I just pass a name which is equal to n. So I just set the passed parameter as a name which is equal to n. Now here I just write public and then a string, and here I just write get, and the get is name here. So this is the modifier here, this is a return type, and then the name here. Now here I just return the set name. So here I just write return, and then return here is name. So I just return the set name here. Now I just go to the main method. So here after that I just write public static void and main, and then here I just write string arguments. Now here I just write Java class, and I just write here Java classes, and here Java classes 1 which is equal to new Java classes. Okay, so here we have the syntax of Java object creation. So here first of all I just write the class name here, then I just write the object name which is Java classes 1, and then which is equal to new and the class constructor. Now I just set the name of the member of this object. So here Java classes 1 dot set name, and which is here I just write visitor. Okay, and then I just print the name. So here I just write system dot out dot print, and the print here is hello, and then the constructor which is Java classes 1 dot get name function here. So now we just see the output for this code. So I just remove this bracket, and this is the print line, and now we just see the output. So here we have the output which is hello visitor. So this is a concept of classes in object oriented programming. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture we are going to discuss about Java constructor. As you all know that all objects that are created must be given initial values, which can be done in two ways. The first way of doing this is to use the dot operator to access the instance variable and then assigning value to them individually. This can be a traditional approach to initialize all the variable of the object in the manner. The second approach takes the help of the methods like getData or initialize abstraction. To initialize each object individually, use a statement like here. I just write val1 dot get data, and then 12 and 15. So parameters are here. Here in this lecture, you will be dealing with constructor of the Java and learn about how they are used within a Java program as how they are useful object oriented programming concept. So here what are the constructors? Constructor are special members functions those task is to initialize the object of its class. It is treated as a special member function because its name is the same as the class name. Java constructors are invoked when their objects are created. It is named such object, its constructor, the value example provide the data for the object. Example, they are used to initialize an objects. Every class has a constructor. When we don't explicitly declare a constructor for any Java class, the compiler creates a default constructor for the class, which does not have any return type. The constructor in Java cannot be abstract, static, final, or synchronized, and these modifiers are not allowed for the constructor. What are the key points means the rules for writing the constructors. Constructor of a class must has the same name as a class name in which it resides. A constructor in Java cannot be abstract, final, static, and synchronized. Access modifier can be used in constructor declaration to control its access. Example, which other class can call the constructor. Now, we just see the characteristics of the Java constructor. An interface cannot have the constructor. Constructor cannot be private. A constructor cannot be abstract. I just told you that cannot be abstract, static, final, native, strict, or synchronized. A constructor can be overloaded. Remember that. Constructor cannot return a value. Constructor do not have a return type, not even void. And construct an abstract class can have the constructor, and the constructor name must be similar to that of the class name inside which it resides. And at the last, constructor are automatically called when an object is created. Instance variables and the methods of the class as known as a member of the class. Remember that. Constructor are not members for the reason constructor cannot be inherited but can be accessed by a subclass. Actually, Java constructor do not get inherited. Only their members like the variables or the methods get inherited. So, declaring a constructor as a final is useless and has no meaning as a constructor cannot be or hidden. Again, Java constructors should not be synchronized as it locks the object when created and hence as long as the object is not created any other object can be initiated. Now we have the two types of constructor. First one is the default constructor which have the no argument constructors and the second one is parameterized constructor. Now we just see what is a default constructor. So the default constructor which have the no arguments is declare like here I just remove this one and then here I just write public and the public here is constructor. Okay, and then here I just write system dot out dot print line and here I just write print line and then so this is a default constructor. Okay, so here is a quotation. So this is a default constructor. So this is the syntax of this no argument constructor. Now I just remove this, and here I just write another example of no arguments constructor. So I just import java.input output, and then we have the class name, which is the constructor here, and then I just write int, and int is num here. Then I just write a string and the name. So now here I just write constructor, and it's a constructor. So this would be invoke while object of the class is created. Now I just write system dot out dot print line, and the print line here is constructor called. Okay, and then we just go to the another class, which is any class name. I just write gfg, and then I just write public static void main, and then it's an string, and so public static void main, and then string and arguments. Okay, so here I just write constructor, and I just copy this one and paste it here. So constructor is cons, which is equal to new constructor. Okay, so that this would invoke the default constructor here. Now I just write system dot out dot print line, and the print line here is cons dot name, and then system dot out dot print line, which is cons dot name. Okay, so this is a value of the default constructor, which is provided by the default value of the object, like 0 or null. Now, so now we just go to the another example of this constructor. So here I just remove this, and now we have the library, which is java.input output, and then we have the public class instructor. Now here I just write public, and then I just write constructor. Okay, so this is the constructor, and then here I just write system dot out dot print line, and the print line here is I am inside of default constructor. Okay, and now I just write public static void, and void the main here, and then I just write a string and the arguments. Okay, and now I just create an object. So constructor, which is cons is equal to new constructor. Okay, so this is our default constructor, and the value of the default constructor is here. When you just run this code, you can see I am inside of the default constructor. Now we just see Java parameterize constructor. A constructor that has parameters is known as parameterized constructor. If we want to initialize the field of the class with your own values, then use parameterized constructors. Here is an example of parameterized constructor. So we have the class name which is parameterized and I just write cons. Now here I just write parameter and then I just make a default constructor here. Now system dot out dot print line and the print line here I just write default constructor. Okay. Now here I just copy this name and then paste it here. So this is our class name as a default constructor. So now here I just parameterize constructor with two integer arguments. So here I just write parameterize and then I just write here int I as a parameter and int j as a parameter. Now here I just write system.out.println and here I just write constructor with two parameters. Okay, and then here I just create the parameterized constructor which is a class and then I just write three integer as arguments. So I, int j and at last int k. So it is a integer k. Now here I just write system.out.println and the print line here is constructor with three parameters. Okay, now here I just write the parameterized constructor with two arguments. One is an integer and one is a string. So parameterized const which is integer I and string name. So here's the bracket and then I just open the program body. So system.out.println and the print line here is constructor with int and string parameters. Okay, so here quotations. Now I just write public and static void main and then string and arguments. Now I just invoke the default constructor. So parameter obj which is equal to new parameter construct. Okay, so object and I just create an object to the default constructor. Now I just write parameterize object number 2 which is equal to new parameterized constructor. So this will invoke the constructor with two int parameters like this one. So I just called an object here for integer I and integer j. Parameterized constructor object 3 which is equal to new parameterized constructor. So I just create an object for this one. So this is the object for three integer parameters. And at the last, which is the important one, object number 4 which is equal to new and then the parameterized constructor. So I just pass the value here which is 1 and then here I just write Java. Okay, so I just run this code so you can see first one is a default constructor then the default constructor, then the default constructor, and at last we have the constructor with integer and the string parameters. Why we take three default and constructor here? Because we just not add our parameters in the object, like we cannot pass our parameters in the object. So the default constructor is because this is an empty parameters. So now here I just write 12 and 12. This is the value to our object number 2. So I just save this and run. So you can see constructor with two parameters. You can see here. Then I just write 13, 15, 14. Okay. So you can see it will tell us the constructor with three parameters. And this is our default constructor because we didn't pass any of the value in this constructor. So here we see another example of pre-parameterized constructor. So this is example of a weird compilation error. While we discussing a default constructor, we have seen that when we do not create a default constructor, Java compiler insert the default constructor into the code on our behalf. However, this is not always true. Now we see this example, and I just create a new class here, and the class name is parameterize constructor number 2 and .java. Here I just copy this class name and use as a default constructor. So parameterize, pass the parameters 1 int j. So int I and j here, and then I just write system.out.println and then parameterize constructor, and I just forget to close this code. Yes, and then I start parameterize constructor and passing the parameters, three parameters, I, int j, int k. And then here I just write system.out.println, and the print line here is parameterized constructor, and here I just write public static void main. Okay, and then string arguments, and here I just write parameterize constructor 2, which is the object is equal to new parameterized constructor. Okay, so it will be give us the compiler runtime error. So you can see exception in thread main java.lang error unresolved compiler compilation program. Sorry, the problem. The constructor parameters is undefined. So the program throw the except compilation error because the statement example like statement parameterize constructor 2 and the object which is equal to new parameterized cons 2 is trying to invoke the no argument constructor, which we don't have in our program. You don't get the error if you remove the parameterized constructor from this code. This is because if you do not have any constructor in your class, Java compiler insert default constructor into your code on your behalf. However, if you implement any constructor, then you no longer receive a default constructor. Like here you can see I just add the construct parameter 2 because this is 1, and then here I just passed 12, 18, and 19. So I will receive no longer error. You can see construct parameterized constructor 2. And if we have these two parameters, so we have parameter construct. So these are the constructors and the types of constructor in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we will see the constructor overloading with the help of example in Java. Before we proceed further, let's understand what is the constructor overloading and why we do it. Constructor overloading is a concept of having more than one constructor with different parameter list. So, overloaded constructors are differentiated on the basis of their types of parameters or numbers of parameters. Constructor overloading is not much different than method overloading. In case of method overloading, you have multiple methods with same name but different in signature. Whereas in constructor overloading, you have multiple constructor with a different signatures. But only difference is that constructor does not have the return type in Java. So why we do constructor overloading? Constructor overloading is done to construct the object in different ways. Now we see the example of this constructor overloading in Java. So here I just define the class which is a public class and the constructor overloading. Here I just write integer which is the ID. So I am just taking the example of a student. So the student ID and then the name and then the student age. Then I just write after this I just copy this name and then the constructor overloading, and here I just write the integer. I just take one value with the integer and another one with a string, and the values are I and n. Now here I just write ID which is equal to I, and then I just write name which is equal to n. Now constructor overloading, and then here I just write integer I, string n, and integer a. So integer I for ID, integer n for name, and integer a for age here. So here I just write ID which is equal to I, then the name which is equal to n, and then here I just write age which is equal to a. Now, now I just copy this and paste it here, and here I just write void display, and the display here is system.out.println, and the print line is id, which is a concatenation of name, and it's an empty string here, and then I just write plus name and plus, and then the string here, and at last age. So after that I just write public static void main, and then the string and the arguments, and then I just copy this class name and make the object for it. So constructor overloading and object number one which is equal to new, and the constructor overloading, and here I just pass the parameters. So the ID of the student is 11 and the name is Fayaz, and then the constructor overloading and the object number two which is equal to new constructor overloading, and I just pass the value which is 12 as a integer ID, then Khan as a string, and then The age is 25. Now, object number one dot display. So I just display this func object, and object number two dot display. Okay. So this is the name of the object. So here I just run this program. So you can see at the first you can see Fayaz ID, and then the ID is 11, and then the name is Fayaz, and the 0 is the age. I didn't take the any parameter for it. And then 12 Khan and the 25. Now we see the another example of this constructor overloading. So here I just create a new class which is constructor overloading number 2 dot java. Okay, so this is a class name. I just copy this class name, and here I just write private and int roll number. Okay, now I just write overloading constructor overloading. So this is a class name here, and then I just write roll number, which is equal to 100. Then I just write constructor overloading 2, which is integer roll number, and then I just use this keyword and this. So this is used for calling the default constructor from the parameterized constructor. It should always be the first statement inside the constructor body. So now roll number, which is equal to roll number plus roll number. Okay, and then I just write public integer get roll number, and then return roll number. Okay, and then here is write public void set roll number, and which is the integer roll number. So here I write this dot roll number, which is equal to roll number. Okay, and then public static void main and the string arguments, and here I just write constructor overloading and create an object for it, which is equal to new constructor overloading 2, and then I just pass the value, which is 12, and here's the value, which is 12, and then the system dot out dot print line, and which is object dot get roll number. Okay, so I just check the output for this code. So this is the output for this code, which is the value of 112. And as you see in this example, that we call the parameterized constructor during the object is creation. Since we have this keyword placed in the parameterized constructor, the default constructor got invoked from it and initialized the variable roll number. So this is an example of understanding the role of this constructor in constructor overloading. So this is also the example of chaining the constructor in Java. Chaining the constructor is a phenomena of calling one constructor from another constructor of the same class, since the constructor can only be called from another constructor in Java. Constructor chaining is used for this purpose. So here is a question, which is, does constructors return any value? So you can say yes, constructors return the current instance of a class, but yet constructor's signature cannot have any return type. So this is the constructor overloading example in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about the inheritance in Java. So inheritance in Java is a mechanism in which one object acquires all the properties and the behaviors of the parent objects. The idea behind inheritance in Java is that you can create a new classes that are built upon existing classes. When you inherit from an existing class, you can reuse the method and fields of parent class, and you can add new method to the field also. On the other words, the inheritance is the process by which one class acquires the properties, means the data members, and the functionalities, means the methods, of another class, is called inheritance. I told you that the aim of the inheritance is provide the reusability of the code. So that's a class has to write only the unique features, and rest of the common properties and the functionalities can be extended from the another class. So in inheritance we have the child and the parent class concept. The class that extend the features of another class is known as child class or a subclass, or we can also call it the derived class. The class those properties and the functionalities are used or inherited by another class is known as a private class, superclass, or a base class. So the question here is why we use inheritance. For inheritance, we used for method overriding, means runtime polymorphism can be achieved. So in method overriding, uh, the runtime polymorphism can be achieved. So the polymorphism, we just learned about the polymorphism in our next upcoming lectures. And the another benefits why we use the inheritance in Java is for code reusability. So how to create an inheritance in our Java? So here I just go to the default package and new. Here I just click on the package source and the package. So here in the package I just write inheritance, okay, and then finish. So you can see we have a new package here. So now here I just write the class name, and the class name here is a dot java. So what is the syntax of the inheritance? So inheritance syntax is class, subclass, name, and extends. So extend is a keyword which is used for inherit, and the super class name means the parent class name here, and the methods and the field. The extends keyword indicates that you are making a new class that's derived from an existing class. The meaning of the extend is to increase the functionality. In the terminology of Java, a class which is inherit is called parent or a superclass, and the new class is called the child class or a subclass. Here, I just create a package which is the name of inherit, and then I just create a class which is A. So A is a parent class here, and I just add a new child class which is B dot Java. We have the two classes here which is A and the B. So in the A class, I just remove this one and I just write a float. and salary. So the salary of employee here is 40,000. Okay, and it is a float value. So this is a parent class. Now here I just go to the child class. So this A class will be, so this B class will be inherited from A class and it will get the value of the float salary. Now I just go to the B class and here I just write class and then here I just write B and I just choose the extend keywords. So class B extend from class A and here and I just remove this one like this one and here I just write class B and it is extend from class number A. So I just make A class which is parent and the B class which is child. Here I just write int and bonus which is equal to 10,000. So give it the bonus to the 10,000 which is salary. Okay. Here I just write public and it's public static void main and then strings and the arguments. Now here I just write class B and here I just write salary for S and new B. Okay, and then I just write system. So B is a capital here. System dot out dot print line and the print line here is and the print line here is salary after salary with, so only salary I just write here and then I just write plus s dot salary. Okay, so I just concatenate the salary here and then system dot out dot print line which is salary after bonus. Okay, and then here I just write plus s dot bonus. Okay, so this is the bonus here. So now I just check the output for this code so you can see. I just click on the execute and then you can see salary is 40,000 and it is a float value here and salary after bonus is 10,000 which is the bonus here. Now we see what is the logic behind it. Here we have two classes. One is the class A and one is the class B. So the A here is a parent class and the B here is the child class. Okay, now we have the one float value which is a salary in the A class. So B inherit the value from which is the salary from A class and then add with the bonus which is a integer and the value of the bonus is 10,000 and the salary is the 40,000 here. So B inherit from A. So A is a parent class here and the B is the child class here. Now we see the another example of inheritance. I just take the package name which is inheritance 2 and then here I just create a two classes name. So one is the teacher dot java here and the another class name which is teacher is computer teacher here. Okay, so and yes, so in the teacher class, I just write a string and designation. Okay, so designation is teacher, and then I just take one another string which is college name, and the college name here is spread tax. Then I just take void and does. Okay, and then system.out.println, which is teaching. Now I just create a parent class with the name of a string which is designation and the string which is the college name. Now I just go to the child class here. So here I just write public class and the class name, and here I just write extends, and extend is the teacher. Okay, so now I just write a string, and here I just define the subjects. So the main subject which is equal to computer science. Okay, and then I just write public static void main, and then strings, string and the arguments. And then here I just write computer teacher. So I just copy this name and paste it here, and I just create the object to it which is equal to new computer teacher, and then I just call the object dot println, and then obj dot college name, and then system dot out dot println, which is object dot designation, and then system dot out dot println, which is object dot main subject, and here is a object dot college name. Okay, and here I just call this method which is does. Okay, void does. So I just create an object to it, so object dot does. So I just check this code, so you can see we have the college name which is spread text, then the designation is the teacher here, and the subject is the computer science, and the object does what I just called, which is the name of teaching. You can see here is a teaching. So in this example, we have the base class or a parent class which is teacher, and a subclass which is the computer teacher. Since a computer teacher extend uh, computer teacher extend the designation and the college properties and the work method from the parent class, we need not to declare these properties and the methods in the subclass. You can see we just not need to declare these properties in the subclass. Here we have the college name, designation, and the work method which are common to all the teachers, as we have declared them in the base class. This this why the child classes like computer teacher or a music teacher or a Java teacher or a Python teacher do not need to write the code and can be used directly from the base class. So the based on this example, we can say that the computer teacher, uh, ISA teacher, that's mean that a child class has a relationship with the parent class. This is inheritance is known as the relationship between the child and the parent class. Remember that the derived class inherits all the members and the methods that are declared as a public or a protected. If the members are or methods of the superclass are declared as a private, then derived class cannot use them directly. The private members can be accessed only in its own class. Such private member can only be accessed using the public or a protected gather and shatter the methods of the superclass as shown in this example. Now we see the types of inheritance in Java. On the basis of class, there can be three types of inheritance in Java. One is a single, another one is a multi-level, and the hierarchical. In Java programming language, the multiple and a hybrid inheritance is supported through the interface only. We will learn about the interface later in our this course. So note that the multiple inheritance is not supported in Java through the classes. So first of all, I just discuss the single inheritance in Java. Single inheritance refers to a child and the parent class relationship where a class extends the another class like B class extend A class. The multi-level inheritance refers to the child class and the parent class relationship where a class extends the child class. For example, class C extend class B and B extend class A. Like this will extend class B and the class B extend class A. So class A is a parent class to the class B and class B is a parent class to the class C. Now we see the hierarchical inheritance. Hierarchical inheritance refers to a child and the parent class relationship where more than one classes extend the same class. For example, class B and C is extend the same class A. Means this is a parent class to the class C and class B also. So the multiple level inheritance refers to the concept of one class extending more than one classes, which mean that a child class has two parents class. Means this child class has two parent class, which is the class A and the class B. For example, class C extend both classes A and B, but Java does not support multi-level inheritance. Now we just see hybrid inheritance. Combination of more than one types of inheritance in a single program. For example, class A and B extend class C and another class D extend class A. So class A, then this is a hybrid inheritance example because it is a combination of a single and hierarchical inheritance. Means all these are the parent and the child classes to each other. So now we just see the example of single level inheritance. Single level inheritance is very easy to understand. When a class extend another class, only then we call it the single class like this one. This class A extend, sorry, the class B extend class A. So this is a single level inheritance. Now we just see another example of the single level inheritance to the package and single inheritance. Okay. And here I just create a class, which is a class A dot Java, and then I just write B dot Java. Here we have the package name, which is a single inheritance, and then here I just write public void method a. Okay, so I just create a method here and then system dot out dot print line, and the print line here is base class method. Okay, and now we just go to the B class. So here I just simply create the method which is a class A, and here I just write class B and use extends keyword, and it is extend the class A. Here I just write public void method B. Okay, and then I just write here system dot out dot print line, and the print line here is child class method, and then public static void main, and then string and the arguments. Now here I just create an object to it. So B class B and object which is equal to new B, and then so this is a static. So here I just write object dot method A. So I just create an object to the method A, and this is object to the method A, and it is calling here a super class, means it is calling our parent class here, and then the method 2 calling the local method, creating the object to the local method. So the method B here. Okay, so this is method B. Now we just check the output. So you can see our base class method and the child class method. You can see the base class method, it is inherit from the base class and then the child class here. Now we see the example of the multiple inheritance. Sorry, the example of the multi-level inheritance. So here I just create a package which is so not here, and in the source package and multi-level inheritance and its inheritance. Okay, here I just create a class which is the name of car.java, and then here I just create the method. So public, and the public here is car, and then system.out.println which is class of the car. Then I just define the void, so it will return nothing. So here is another class which is a vehicle, and the method here which is a vehicle, and then system.out.println, and here I write vehicle type which is car. Okay, then here I just go to the another class, and here I just create a class which is bmw.java. So here we have another class, and here I just write extends car. So class bmw extend our parent class which is car, and the public bmw is a method here, and then system.out.println which is class bmw, and here I write public void and brand here is system dot out dot and system dot out dot println, and the brand is BMW. Okay, now here I just write public void and speed method. Now system dot out dot println, and the println here is maximum 120 kilometer per hour. Okay, and after that I just go to the another class. So here I just write class, and class here is BMW 15. Okay, and then here I just write BMW 15 extends BMW. So the car is a parent class to the BMW, and BMW is a parent class to the BMW 15. Now here I just write public BMW 15 method, and then I just write system dot out dot println, and the println here is BMW and model is 2015. And then I just create one another method which is public and void is speed of it, and the speed here is system dot out dot println, and then it's maximum up to 180 kilometer per hour. Okay, and then here I write public static void and the main method, and then a string arguments, and then here I just write BMW 15, and then create an object to it which is equal to new and BMW 15. Then I just call, and this is BMW 15. Okay, and now object dot vehicle type, and then object dot brand, and then object dot speed. Okay, so I just check the output. So you can see the class BMW, the model is 2015, vehicle type is car, brand is BMW, and maximum speed of it is 150 kilometer per hour. So in this example we have the three classes, which is car, BMW, and the BMW 15. We have done a setup class which is BMW extend the car, and the class BMW 15 extend the BMW. With the help of the multi-level inheritance setup, our BMW 15 class is able to use the method of both the classes like BMW and the car classes. So this is the example of the multi-level inheritance in Java. Now we see the hierarchical inheritance. So I just create one another package which is hierarchical, and hierarchical is inheritance. Okay, now I just create the class, and here I just create the class which is animal.java. So here I just write the class name which is animal, and void animal is eating, and then this is a method here which is the eat method, and then system dot out dot println, and println is eating. Then we just go to the class. So here I just create the class which is cat.java, and here I just write extend animal. So cat extend the class which is animal, and void I just write milk. So not an eat here, so I just write drink. Okay, and here's the milk. Then here I just write system.out.println, and then I just write meow. Okay, and then we just go to the another class. So here is a class which is first I just inherit this class. So it's a meow here, and then I just write the class which is dog dot java. So dog inherit from animal, and then I just write here void and bark, and then so it's an animal class. So okay, and then here I just write bark, and this is cat. Yes, okay, and here I just write bark, and then system dot out dot println, which is barking. Now we just go to the hierarchical inheritance class. So now here I just create the class which is the name of hierarchical dot java, and then here I just write public static void main, and then string arguments, and this is string arguments, and then here I just write cat c, which is equal to new cat, and then c dot milk. Okay, and then c dot drink. Okay, so you can also call it the dog functions too. So here I just check the output, so you can see I just call the two object which is milk, and the milk function is meow here, and then the animal which is drink, and the eating. So this is the hierarchical inheritance example in Java. So now we just see the multiple inheritance. Why Java not support the multiple inheritance? To reduce the complexity and simplicity, the language multiple inheritance is not supported in Java. Consider a scenario A, B, and C are the three classes. The class C inherit class A and the class A inherit class B. If a A class and the B class have the same method and you call it from the child class object, there will be ambiguity to call the method of a A or a B class, since the compiler time error are better than the runtime error. Java renders compiler time error if you inherit two classes. So whether you have the same method or a different method, there will be compile time error in your multiple inheritance. So these are the types of inheritance and the inheritance in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the abstraction in Java. Abstraction is the process of hiding the implementation's detail and showing only the functionality to the user. Another way, it shows only important things to the user and hide the internal details, for example, sending SMS. You just type the text and send the message. You don't know the internal processing about the message delivery. Abstractions let you focus on what the object does instead of how it does it. There are two ways to achieve the abstraction. One is the abstraction class, means you can write the abstract class, which is the abstraction level of 0 to 100%. And the another way you can achieve the abstraction, which is the interface, a class that is declared using the abstract keyword is known as abstract class. Remember that. It can have the abstract method as well as a concrete method. A normal class means a non-abstract class cannot have the abstract method. Remember that. So why we need abstract class? Let's say we have a class A, like this one. You can see the class A that has a method which is, or I just simply write it's a class animal, okay? And the method of it this class is sound, and the subclass of this class is dog, lion, horse, cat, or any of the animal. Since the animals sound different from one animal to the another animal, there is no point to implementation this method in the parent class. This is because every child class must override the method to give its own implementation detail. Like lion class say roar, in this method dog class will say woof. So we can know that all the animal child classes will and should override this method. Then there is no point to implement this method in the parent class. Thus, making this method abstract would be the good choice, as by making the method abstract, we forced all the subclasses to implement this method. Otherwise, you will get the compilation error. Also, we need not to give any implementation to this method in the parent class. Since the animal class has an abstract method, you must need to declare this class abstract. Now each animal must have a sound. By making this method abstract, we made it compulsory to the child class to give implementations detail to the method. This way we ensure that every animal has a sound. Now we see the example of the abstract class. So I just make this example, I just delete this, and here I just create one another class with the name of animal. Okay, so animal dot java here. Now here I just create the class name which is abstract. So here I just write abstract. So abstract is a keyword, and this is the class name which is abstract and animal. So I just remove the public and then make the parent class with the abstract class. Now I just declare the abstract method. So public abstract, and then abstract is void sound. Now here I just declare, not here, I just create one another class with the name of dog, because dog is a category of animal. So I just write java dog dot java. So here public class, and I just inherited and use extend and animal. Okay, this is a super class which is animal and public void and sound. So here I just write system dot out dot print line, and the print line here is, and the print line is wolf. Okay, and then here I just write the main method, which is public static void main and string, and the arguments. So it's string and arguments. Okay, and then here I just write, I just create the object to it. So animal, and the object which is equal to new, and dog. So dog here, and then create the object to sound. So now we just check the output, and you can see it is classes inherit from the animal class, and which is the object of sound, which is wolf. Hence, for such kind of example, we generally declare the class as an abstract and later is a concrete class. Extend these classes and override the method accordingly and can have their own method as well. So here now we just understand the real scenario of an abstract class. So now here I just create another example for the abstract class. So here I just write abstract shunt2, and then here, sorry, it's I just not create a class, I just want to create the package here. So the package is abstraction 2 dot, so 2. Okay, and here I just create a class which is a name of shape dot java. Okay, now here I just change this shape name with the abstract, and abstract class which is shape, and in the abstract class I just create one another class which is abstract void and draw. Okay, so not a, this is not a class, this is a method. So draw here, and then after that I just go to the real scenario of implementations in abstraction. So here I just create one another class which is the name of rectangle, and then here I just write the class name which is rectangle, and it is extend with shape. So this is our shape class which is super class. Then here I just write void, and void which is draw. Okay, and then here I just write system dot out dot print line which is drawing rectangle. Okay, and close with the double quotation. Now here I just create one another class, and then here I just write circle. It's circle dot java. Now here public class which is circle and extends shape. So this is our shape is a parent class, and circle is inherit from the shape class. Now here void and draw, and then system dot out dot print line, and the print line here is drawing circle. Okay, now we just go to the real scenario of the programmer or the users. So these classes I just create for the user view. So here I just make a method there to the void, and then I just create one another class with the name of test abstraction dot java. So this is a programmer oriented classes, and here I just write public static void main. So this is the main method, and then a string arguments, and then here I just write shape, which is s is equal to new, and circle, and then I just create the scenario for the object providing through the method, like example get shape method here, and s dot draw. Now let's check the output. So you can see draw the circle, because I just called an object which is the circle. So in this example, shape is an abstract class, and here shape is abstract class. You can see here a little small a. So shape is an abstract class here. Its implementations is provided by the rectangular and the circle class. Mostly we don't know about the implementation class. Example, hidden to the end user. An object of the implementation class is provided by the factory method. So the factory, what is a factory method? A factory method is a method that return the instance of the class. We will learn about the factory method in later in our tutorials or lectures. So this is the example of the real scenario of the abstract class. Like we just make three classes for the user oriented, and then one for the abstract level for the programmer oriented or the users. So this is example of abstracts in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the interface in Java. Interface is a pure abstract class. They are scientifically similar to the class, but you cannot create the instance of an interface, and their methods are declared without any body. Interface is used to achieve the complete abstraction in the Java. When you create an interface, it defines what a class can do without saying anything about how the class will do it. So now we just see why we use Java interface. There are mainly three reasons to use the interfaces in Java. It is used to achieve the abstraction. This is the one step. By interface, we can support the functionality to the multiple inheritance. This is the second point why we use the Java interface. And the third one is it can be used to achieve losing the coupling. So there are some rules of using the interfaces. First one is methods inside interface must not be static, final, native. All variables declared inside the interface are implicitly public, static, final, and the variable which are constant. All methods declared inside Java interfaces are implicitly public and the abstract. Even if you don't use the abstract or abstract keyword, interface can extend one or more other interface. Interface cannot implement a class, and at the last, interface can be nested inside another interface. Now we see the example of the interface and see how we implement the interface. Here I just create a class which is printable. So in this example, interface printable has only one method. Its implementation is provided in the another class which are I just create one another class which is a.java. Okay, here in the printable class I just write void and print. Okay, this is the method, and now we just go to the another class which is a. Here I just write the public class a, and remember that here I just declare interface with the public, and I just replace class with interface, and then we just go to the public and the class a, and here I just use a keyword which is implement, and here I just write printable which is our super class. Now I just go to the public void print method, and then system dot out dot, and here it's a capital P, so I just write system dot out dot print line, and the print line here is a string and the arguments. Now sorry, here I just write hello and then close this code, and then I just create a main, and which is public static void main and string arguments. So this is a main method here, and then here I just write a and then object which is equal to new and a. So this is our class name, and then object dot print. So this is our print method. So I just call it the print method. Now I just check the output for this code, and the output is hello. You can see it will print this method here. Now we just go to the another example of this interface, and the example for the bank. So here I just create a new package which is interface, and interface is the one. Okay, now here I just create a class which is the name of bank. So this is a class name, and here I just write public and interface. So interface is a bank, and then it's float. Float is a rate of interest. So this is a method here. Now I just create one another class with the name of the bank. So the bank is ANZ. So ANZ.java. Here I just write class and the class name, and then implementation. So implements, so it's implements, and then the bank name, which is a super class. Now here I just write public and float and the rate of interest. Okay, and then I just write return, and return is 9.5 f. Okay, now we just go to the another class which is the bank name NIB, dot java, and then here I just write implements and the superclass name, which is bank, and the bank is a superclass name here. And then I just write public float rate of interest, and then here I just write return 9.7f. Okay, and we just go to the another class, which is the main class here. So I just write the name of this class, which is test interface 2, and here I just define the main method, which is public static void main, and then strings and the arguments. So here bank b, which is equal to new, and anz, and then here I just write system dot out dot print line, which is the rate of interest here is, and plus b dot rate of interest. Now I just check the output. So you can see the rate of interest on ANZ Bank is 9.15. So this is an example of the interface in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about what are the difference between the abstract class and the interface. Abstract class and the interface both are used to achieve abstraction, where we can declare the abstract methods. Abstract class and interface both cannot be initiated. An abstract class can extend only one class or one abstract class at a time. An abstract class can extend another concrete, regular, or abstract class. And the third number, an abstract class can have both abstract and the concrete methods. So we just see the interface. So the interface can extend any numbers of interfaces at a time. An interface can only extend another interface. An interface can have only abstract method, and an interface can have only public abstract method. Here we just see a simple example of where we are using the interface and abstract class both together. So here I just make a package which is the name of abstract versus interface, and just create the two classes, which is abstract1 and interface.java. So here in the interface class, I just write the interface public class interface, and here I just remove this interface, and here I just write interface. So public class interface, and the class name here is interface. Then I just write void and a. So void a for by default the public and abstract method. Here we just create the for math and means creating interface that have the for method. Like this is our interface, and I just create a first method here, and then here I just write abstract void b, then void c, and at the last a method which is void d. Now we just go to the abstract class. So here I just give it the name which is abstract, and abstract is the class name of abstract one. And then here I just write implements, and here it's implements interface. Okay. and this is with the capital one because it's a class name, which is interface, and this is abstract. Now here I just write public void, and I just call my C method, and then here I just write system dot out dot print, and then it's a print line here. So the print line here is I am C. Okay, so I just create an abstract class that's provide the implementation of one method from our this class name, which is interface. So here I just close this code, and I just remove this, and then here I just write class, and it's a capital S of the system. Now we just go to the creating a subclass of the abstract class, and here I just go to create a new, which is a class, and here I just give it the name to the class, which is subclass dot java. Okay, so here we just need to provide the implementation of rest of the method here. So here with a class, and class name is subclass, and here I just extend our class, which is the name of abstract one, and then here I just write public void, and I just write the method a, which is system dot out dot print line, and the print line here is I am method a, and then I just copy this code, and here I just only declare the methods which are public void and method b, and remove this, and here I just write public void and the method d, because we just already implement our method, which is the name of c. Now we just create one test class, or I just say this is an object class to create, not create, to call the object of a interface class. So here I just create new and class, and here I just write object one dot java, because I am just creating the object here. So the class name, which is object one, and it's a main method here, and then a string, and the arguments here, and here I just write our class name, which is interface. So I is a capital here, and the interface here, and then I just write a, which is equal to new, and then our subclass name, and then here I just write a dot a method, and a dot b method, and a dot c method, and a dot d method. So I just call my methods here, and now I just check the output for this code. So you can see I just call the method number one with an interface. So here is a I am a, then I am c, and I am a. So this is a simple example of interface and abstract class in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the polymorphism in Java programming language. The word polymorphism literally means a state of having many shapes, or the capacity to take on different forms. When applied to the object-oriented programming language like Java, it describes a language ability to process the objects of the various type of classes through a single uniform interface. Polymorphism in Java has a two types. One is a compile time polymorphism, what we call it the static binding, and the runtime polymorphism is dynamic binding. Method overloading is an example of a static polymorphism, while method overriding is an example of dynamic polymorphism. Here I just gave you a little knowledge about ISA relationship. In OOP, ISA relationship is completely inheritance. That means that the child class is a type of the parent class. Like A has A relationship is dynamic runtime binding, while inheritance is a static compile time binding if you just want to reuse the code and you know that the two are not of the same kind. Use this composition like IS and A relationship. So now we just come to our on topic which is the polymorphism. An important example of polymorphism is how a parent class refer to a child class object. In fact, any objects that satisfy more than one ISA relationship is polymorphic in nature. For instance, let's consider a class animal. Here I just write animal. We have the class which is the name of class animal. And we have the class means the subclass which is cat. So cat is the also animal and it is a subclass of animal. Okay. So any cat means I as animal. Here cat satisfy the I as a relationship for its own type as well as its superclass name is the animal here. The good reason for why polymorphism is needed in Java because the concept is extensively used in implementing inheritance. It plays an important role in allowing objects having different interval structures to share the same external interface. Polymorphism is started clear by itself and one which mapped for many. On the other hand, we have the another definition of the polymorphism, which is the polymorphism is a capability of a method to do different things based on the object that it is acting upon. In other words, polymorphism allows you to define one interface and have the multiple implementations. Now, here we just see the example of the static polymorphism. So in Java, static polymorphism is achieved through method overloading. Method overloading means there are several methods present in a class having the same name but different types like order numbers of parameters. At compile time, Java knows which method to invoke by checking the method signature. So that is called compile time polymorphism or a static binding. The concept will be clear from the this example. Now we just create here like the polymorphism and I just create the class which is static polymorphism. Okay, dot Java. Here in this class I just write public integer add and we have the parameter which is int x and int y. Now here I just write return x plus y. So it will give us the return which is x plus y. So this is our method number one. Now here I just write public integer add, then int x, int y, and the integer z. This is our method number 2, and here I just need return, and the return is integer x plus y. Now here I just go to the method number 3. Sorry, it's not an integer x plus y here, so x plus y plus z here. Now here we have the method number 3, which is an integer add, and then int, and here I just define double, so double x and then integer y. So our method number 3 is return, and the return here is integer, and which is x plus y. Okay, now we just go to the method number 4, public integer add, and then integer x, and here I just take the double as a y, and now here I just write return x plus and then integer which is y. Okay, now I just make a class which is the name of test.java, and here I just define the main method which is public static void main, and then string which is the arguments here, and then here I just write system dot out dot print line, and the print line is here I just write the name of the class, and the name of the class here is, so not here I just create static polymorphism, and then here I just write the class name which is static and new polymorphism. Okay, and now here I just write, so I just give it the static one. Okay, now here I just write static one dot add, and here I just give it the value to the parameter which is 2 and 3. So I just call the method number 1 here. Now I just copy this for the method number 2, 3, and 4. So in print, and here I just give it the value which is 5, and then here I just write 3.4, and then 2.6 here. So I just call 4 methods here. So this is for our method number 3, because I just write it the double x here, so this is for our method number 3. Okay, so here I just run this code, and okay, so you can see we have the addition of our first method, this one, 3 plus 2 is equal to 5, and then 2 plus 3 plus 5 which is equal to 10, and then 2 plus 3.4, because it's a float value, so it just take the 5 here, and then 2.6, and then 3, and it's take 5 as a value. So now we just see the example of dynamic polymorphism. Suppose a subclass overrides a particular method of a superclass. Let's say in this program we create an object of a subclass and assign it to the superclass reference. Now if we call the overridden method to the superclass reference, then the subclass version of a method will be card. So now here I just create a package which is poly here, and then in this I just define the class which is dynamic.java. So we have the dynamic polymorphism, or I just remove this, delete this class, and here I just create the example for vehicle.java. We have the package name which is poly and the class name which is vehicle. Here I just write public void and move. Then here I just write system.out.println, and then vehicles can move. Okay. Now here I just create a new class which is car.java. Here I just extend this vehicle here, and it's a vehicle. And now here I just take it the output which is system.out.println, and it's system.out.print, and the print is the line here. And then we have, I just write car can move and accelerate too. Okay. And here it's a string, and then here I just create a class which is a name of test.java. So I just copy this, and here I just write system dot out dot print, and the print is a line here. And yes, okay, it will give us the error because I just not declare a function. I just forget to declare the function here, or or a method. So now it's work good, and now just turn to the test class, and this is a colon here. And now in the test class I just define the main method. So public is static and the void main, and then string arguments. And now here I just write the class name, means the super class name which is vehicle, and here vh which is equal to new car. And now here I just write vh dot move. So this will print the car can move and accelerate too. And then vh object dot new vehicle. So I just call this object, and then vh dot move method. So it will print the vehicle can move. Okay. And here I just use is equal to sign because I just make a little mistake with the point. So I just run this code, and now you can see can car can move and accelerate too. So I just call this object which is method which is move, and then it will print vehicle can move. So here the simple examples for dynamic and the static polymorphism in Java. Thanks for watching this lecture. See you in next lecture.
Welcome to this lecture. And in this lecture, we are going to be discussed about method overloading in Java. Method overloading is a feature that allows a class to have more than one method having the same name. If their arguments list are different, there is similar to the constructor overloading in Java. That allows a class to have more than one constructor having different argument lists. Here is a question: why we do method overloading in Java? In such cases, we can create the methods with the same name and the signature as in the parent class. This way, the new method masks the parent method and would get invoked by default. Overloading in Java is the ability to create multiple methods of the same name, but with the different parameters. Overloading occurs two or more methods in one class have the same method name, but different in parameters. Remember that. Here we have three steps to create the method overloading in Java. Number one, number of parameters. Here you can see I just write add and integer. These are numbers of parameters. We have the two numbers of parameters here. This is a valid case of overloading. Or you can write add int and integer of 3 times. Okay, so this is a valid case of the overloading. Our second process or method to overload in Java, so which is data type of the parameters. So you can see add integer and integer, then add integer and float. Okay, so these are the data types of the parameters. Number third, sequence of data types of the parameters. Like here you can see add integer and float, then add float and the integer. So what are the invalid case of the method overloading in Java? When I say argument list, I'm not talking about the return types of the method. For example, if two methods have the same name, same parameters, and have the different return types, then this is not the valid method overloading. This will throw exception error, like here you can see integer add and it have the parameters like the data types, which is also int, and then float add and it have integer data types. So this is an invalid case because they have the different return types here. So for our these three methods, when I say argument list, it means that the parameters that are a method that has a method. For example, the argument list of the method add integer a and the integer b, which have the two parameters, is a different from the argument list of the method add, like add integer. Here I write integer a and the integer b, and then here is example integer a, integer b, and integer c. These are having the three parameters here. So now we just go to the method overloading example. So I just told you in the last lecture the method overloading is an example of the static polymorphism. So here's the some point which are static polymorphism is also known as compile time binding or early binding. I just told you in my last lecture. And the static binding happens at the compile time method. Overloading is an example of static binding where the binding of the method called to the definitions happen at the compile time. So now we just go to the example of this method overloading. As I discussed in the beginning, method overloading is done by declaring the same method with the different parameters. The parameters must be different in their numbers, sequence, or types of parameters or arguments. Now let's see the example of this method overloading. And here I just create a class which is method.java. So in the method overloading class, I just create a method which is display, and then here I write system.out.println, and the print line here is I just write this is print line, and then here I write method overloading. Okay, and then we just go to the second function. So void is a display here. Void mean it will not return nothing, and the parameters of this is x. Then system.out.println, and the print line here is integer value. Okay, then we just go to the third method, which is for display, and it will give us the float value, which is x, and the float value here is system.out.println, and the print line here is character. So float values, and here I just write float value. Okay, now we just define one another method, which is the name of display, and the parameters here are character x, and then I just write system.out.println, and the print line here is character value. Okay, now after that I just go to the void function and pass the two parameters here, which are the return types of integers: display integer x and the integer y here. Okay, and here I write system dot out dot print line, and the print line here is integer and the integer. And after this I just concatenate x and concatenate y. Okay, now here, sorry, it's plus y. Now I just write void and display, which is two return types, which is data type, which is float and integer. And here I just write system.out.println, and the print line here is float and then the integers. So plus x and then plus y. Now here I just write one another function, which is this is integer and float. For display, and the display here is I just write float for the first data type, and the second one is the integer, and then system.out.println, and the print line here is float and the integer, and then plus x and empty string for the comma, and plus concatenate y. Now I just create the main class to call the object of this, to create or call the object of this function. So this is the main class here,
and then I just create the main method, which is static void main, and then string arguments. And the string arguments here is I just write the class name, which is method, and I just create the object with the method, which is equal to new method. Okay, and now I just call the method here. So first one is display, then object dot display integer, and the integer value here is I just write 525, and then object dot display object dot display, which is for float, and the float x value here is I just write float, and the float value here is for 6.23. Then object dot display, and display for the characters. So the character here is z. Okay, and now I just create another object dot display for our two integer values. So yes, integer x and integer y. So here the integer value is 45 and the value of y is 63. And then object dot display for the integer and the float value. So our integer value here is 963, and the float value here is I just write float, and then here I just write 202.35369. Okay, or here I just write 69. Now I just write object dot display, and display for the float and the integer. So our float value here is 523.89, and then the integer value here is 20. Now I just check the output for this code. So we have the first display method, which is the float value and the character values method overloading. You can see the display method, and then here we have the integer value, then we have the float value, and then we have the character values here, and it will give us the two integer return types, which is 45 and 63, and then integer and float values here, and then float and the integer values. So this is a method overloading example in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about method overriding in Java. If subclass like child class has the same method as declared in the parent class, it is known as a method overloading in Java. In other words, if subclass provide the specific implementation of the method that has been provided by one of its parent class, it's known as method overriding. So what is meant by method overloading in Java? The benefit of overloading is ability to define a behaviors that is specific to the subclass type, which mean a subclass can implement a parent class method based on its requirement. In object-oriented terms, overriding means to override the functionality of an existing method. Why we use overriding in Java? The ability of a subclass to override a methods allow a class to inherit from a superclass. Those behavior is close enough, and then to modify behavior as needed. overriding is a feature that is available when using the inheritance. Here, one another definitions of overriding in Java. So, declaring method in a subclass which is already present in the parent class. It's known as method overriding. I just told you overriding is done so that is a child class can give its own implementation to the method, which is already provided by the parent class. In this case, the method in the parent class is called overridden method, and the method in a child class is called overriding method. In this lecture, we will see what is the method overriding in Java and why we use it. So here, let's take a simple example to understand this. So here, I just create a class which is human.java. Okay, we have the methods to the human which are eat. So here we will take two classes. In this method overriding, we are taking two classes. First one is a human, and then I just take one another class which is boy, and it's boy.java. Okay, so a child class boy and a parent class human. The boy class extend the human class. Both classes have the common method which are eat. The boy class is giving its own implementation to the eat class, eat method, or it's or in other words, it is overriding the eat method. The purpose of method overriding is clear here. The child class want to give its own implementation to that's when it calls the method. It's print the boy is eating instead of human is eating. Here we just go to the example and see the method overriding. So here it's a public void and eat. So the human is eating. So this is the overridden method. And then you can see, just remove this and see system.out.println here. And the print line here, which is the name of human, and human is eating here. Now we just go to the boy class. So class boy extends human. Okay, remember that. And it's human. Okay, and it's a capital human. So yes. So here I just write public void and eat method. So now here, which is the eat method, which is overriding method here. So I am just using the overriding method here. But here I just use the overridden method. Okay. So I just go to the boy class and here I just write system.out.println, and the print line here is boy is eating. Okay. And then the main method, which is public static void main and then string arguments. Okay, here, and then I just create the object to the boy class and boy object which is equal to new boy. Okay, and now here I will call the child class version of eat. So here I just write object and eat. So I just call the eat. So you can see Here, boy is eating. So you can see here the boy extend the human class, which have the same method, which are the void eat. You can see the boy have the same method of eat and the human have the same method of eat. The boy class giving its own implementation to the eat class, sorry, the eat method, or in other words, we can say it overriding the eaten method here. Now we see what are the advantages of the method overriding. The main advantages of the method overriding is that the class can give its own specific implementation to the inherited method without even modify the parent code, class code. This will helpful when a class has several child classes. So if a child classes need to use the parent class method, it can use it, and the other classes that want to give the different implementation can use overriding features to make changes without touching the parent class code. Here we have one another example of this overriding, and now I just see just make uh, another example. So here I just said method overriding one, and now here I just create a class which is method dot java. And here, first of all, I just create a method which is the name of display. And then here I just write system.out.println, and the print line here is class method. Okay. Now I just go to the another class and the quotation here, and I just go to the another class, which is a subclass of the method class. Now here I just extend method. Okay. And then here I just write the same method name, which is display. And then here I just use the super keyword. So I just tell you about the super keyword in my upcoming lectures. So just make a concept here. So the super and then display, and then I just write system dot out dot println, and the print line here is class and the sub class. Okay. Now I just go to the main class where I just create the object to these classes. So here I just declare the main method, which is public static void main, and then string and the arguments. And here sub class object, which is equal to new sub class. Then object dot, and then object dot display. Okay, now we just check the output. So here we have the two methods are calling, which have the same method as display. So first one is a class method. We have the same method for this class, which is the method, and then the subclass. You can see I just call the super method here. So use the super keyword and then call the display method and get the value from this method, which is a class and the subclass. So these are the concept of method overriding in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be learn about the super keyword in Java. Super keyword in Java is a reference variable that is used to refer the parent class object. Super is an implicit keyword created by Java Virtual Machine and supply each and every Java program for performing important role in three places, like at variable level, at method level, and at constructor level. The question is why we need the super keyword. Whenever the derived class is inherits the base class features, there is a probability that base class features are similar to the derived class features. And Java Virtual Machine gets an ambiguity in order to differentiate between base class features and derived class features must be preceded by the super keyword. The syntax of the super keyword I just used in my last example, which is main.java. Yes, here subclass.java. You can see here you can write the super keyword and then the super display name or any the function name. When add the super at the variable time, so whenever the derived class inherit base class members, there is a probability that base class data members are similar to the derived class data member, and the JVM gets ambiguity. In order to differentiate between the data members of the base class and the derived class in the correct of the derived class, sorry, the context of the derived class, the base class data members must be preceded by the super keyword. Now we can see the actual syntax of the super keyword. So super, and then you can write the base class, and then the data member and the data member of the name, like super, the base class name, then data member integer or float, and then the name of this. If we are not writing the super keyword before the base class data member name, then it will be referred as a current class member name, and base class data members are hidden in the context of the derived class. Here we are going to be create a program without a super keyword, and here is example of Java employee, and then the class employee, and here I just write float salary, which is equal to 1 lakh. Now I just create one class with the name of HR department. So HR and the Java. So here float. Okay. Now in the HR class, I just extend employee. Okay. And then here I just take the salary as a float, and which is equal to 2 lakhs. Now here I just use a function or a method which is display, and then here I just write system dot out dot println, and here's a println is salary, which is a concatenation of salary. So it will print the class which is salary. Okay. Now I just go to the super variable, and here I just create a class which is super variable dot java. Here I just define the main method, and which is strings and the arguments, and here the hr, which is the object is equal to new hr, and here I just create the object which is display. So I just display only the object of this HR. Here I just run this code, and so it will give us the salary, which is 2 lakhs. So in this example, in employee and the HR class, like this one, employee and the HR class is common properties of the both class. The instance of cur- current of or a derived class is referred by instance by default. But here we want to refer the base instance variable. That is why we use super keyword to distinguish between parent or base class instance variable and current or a derived class instance variable. So here is a program where we use super as a keyword in method label. So here I just write the source, and this is a package, and then here I just write super keyword 1. Okay, and now I just create a class, and the class is the person here, and in the person class I just write void message. So this is a function of my person class, and then print line, and this is person class. Now I just create another class which is a subclass. So here I just write the name, which is student. So again I just write the method, and then system dot out dot print line, and the print line here is this is student class. Now note that display method is only the student class method. So here I just write void display, and then I just invoke the method which is display here. So message, and then I just use super dot message keyword. Okay, sorry, the super keyword and the message here. So this will invoke the parent class method. Now I just go to the another class, and then I just write test.java. So here the public static void and the main method, and then string arguments, and then student s, which is equal to new student, and then I just call the display of the student, so s dot display. Okay, and here super and the message. Okay, now here I just extend the person here. Okay, and I just run this code. So there is an error. So main method is not found in the class of super keyword dot person as a main as a static. Yes, here in the test class. So display, and so I just run it again, and this is the student class and this is a person class. You can see it will retrieve the data from both the classes with the help of super keyword which have the same method name. Here I just point out some important rules for the super class. So whenever we are using either super or a super means like this one, super keyword or the super keyword with any something. So in the derived class constructor, the super always must be at the first executable statement in the body of the derived class constructor. Otherwise, we will get the compile time error. So the rule number one is whenever the derived class constructor want to call the default constructor of the base class in the context of the derived class constructor, we write super, which is optional to write because every base class constructor contains the single form of the default constructor. And whenever the derived class constructor want to call the parameters constructor, so this is a parameter constructor to constructor of the base class in the context of the derived class constructor, we must write the super like this super when we use the constructor as a parameters, so which is mandatory to write because a base class may contain multiple forms of the parameters constructor. So these are some examples and the super keyword in Java. Thanks for watching this lecture. See you in. Welcome to this lecture, and in this lecture we are going to be discussed about this keyword in Java. This is a keyword in Java. It can be used inside the method or a constructor of a class. It this work as a reference to the current object those methods are or constructor is being invoked. This keyword can be used to refer to any numbers of current object from within an instance method or a constructor. On the other hand, this is a reference variable that refers to the current object, and simply it is a keyword in the Java language represent the current class object only. The usage of this keyword is it can be used to refer the current class instance variable. This can be used to invoke the current class constructor. It can be used to invoke the current class method implicitly. It can be passed as an argument in the method call. It can be passed as an argument in the constructor call. And it can also be used to return the current class instance. The question here is why we use this keyword in Java. The main purpose of using this keyword is to differentiate the formal parameters and data members of a class. Whenever the formal parameters and data members of the class are similar than Java virtual machine, it will get ambiguity. No clarity between the formal parameters and the members of the class. The differentiate between formal parameters and data members of the class, the data member of the class must be preceded by this keyword. So this keyword can be used in two ways. One is, and here I just give the example, one is this dot. So this is the name of this dot. And another one is this keyword. So this is called this of. So like this one, this. So let's take a look on this dot. So this dot, which can be used to differentiate variable of the class and formal parameters of the method or the constructor. This keyword are used for two purposes. They are it will always points the current class object, and the another one is whenever the formal parameters and data members of the class are similar and the Java virtual machine gets an ambiguity, means no clarity between the formal parameters and the data members of the class. To differentiate between the formal parameters and the data member of the class, the data member of the class must be preceded by this. So here is a syntax of this keyword. So this and the data, and then member of the current class. Okay. Note that if any variable is preceded by this, Java virtual machine treated that variable as a class variable. Now we just see the example of this keyword. So before starting this example, we just need to know the this keyword with the field instance variable. This keyword can be very useful in handling of the variable hiding. We cannot create two instances or a local variable with the same name. However, it is legal to create one instance variable and one local variable or a method parameters with the same name. So here we just see the example of the this keyword with the variable hiding. Here we have the class name, which is this one. Then I just create a data type, which is the integer, and integer is variable, and variable which is equal to 5. Then I just use the main method, which is public static void main, and the string arguments. And here I just create this one and the object which is equal to new this one. So I just create object to my this class, and here I just write obj dot method, and which is 20, and then obj dot method, which is nothing, and I just close this code here. Now here I just define these methods where void and method. So method here is the data type of int variable, and I just copy and paste this name here, and then I just write variable which is equal to 10. Now I just write system dot out dot print line, and the print line here is value of variable, and then I just concatenate the variable here. Now I just write void and method. So integer variable which is equal to 40, and then system dot out dot print line, and the print line here is value of variable, and then I just concatenate variable here. Now I just check the output for this code. So I think I have an error in this package. I just create one another new package which is this, and here I just create a class which is the name of this one, and I just copy this code and paste it here. I just remove this class and one curly brackets. Now I just run this code. So you can see value of the variable is 10 and the value of variable is 20, because this method which have the parameters is the value of 10, and then I just call one another method with the name of the method which is the value of variable which is 40. Now we see the example of this keyword with the constructor. This keyword can be used inside the constructor to call another overloaded constructor in the same class. This is called explicit constructor annotation. This occurs if a class has two overloaded constructors, one without arguments and one with arguments. Then this keyword can be used to call constructor with an arguments from the constructor without arguments. This is required as a constructor cannot be called explicitly. Here I just create a new class, and the class name here I just write this and one, and then here I just use this keyword and then write this one and close this code here, and then I just write system dot out dot print line and this one, and the print line here is inside constructor without parameters. Okay, and then I just create the method for this one. So this is the name of the method, and now here I just write this one and then string str, and show me the error because I just not create the variable method which is this one. So constructor call must be first statement in the constructor. I just remove this word with my this function. So here the str. So this is the method of the string, and then I just write system dot out dot println, and the println here is inside constructor with string parameters as I just write quotation and then plus string. So I just concatenate my this string here. So as you can see, this can be used to invoke an overloaded constructor in the same class here. You can see here, this can be used to invoke an overloaded constructor in the same class. Now we just go to the main method here. So public static void main and then string arguments, and then this one object which is equal to new this one. Okay, and then I just close this code. Now I just check the output for this code. So you can see the inside constructor with the string parameter at this one and inside the constructor without the parameters. You can see here like this can be used to invoke an overloaded constructor in the same class. So here note that this keyword can only be the first statement in the constructor. Our constructor can have either this or super keyword, but not the both. Now here I just use one another example with the this keyword with method. So I just give it the name of method here. So class name which is this method, and now public static void main. It's a main method here, and then arguments. And then this method object which is equal to new this method, and then object dot method 2. Okay, so now here I just write method void and method 1 and method 1, and then system dot out dot println, and println is inside method 1, and then void method 2, and then system dot out dot println, and the println here is inside method 2, and here I just write this dot method 1. So I just call the method number 1 same as a calling of method number 1. So now I just check the output for this. So you can see inside the method number 2, because I just use the object of method number 2 here, and then inside the method number 1. So I just create the method 2. This one is here in the method number 2. So this is example of the this keyword with the method. So these all the examples of these keywords in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learn about the encapsulation in Java. Encapsulation simply means binding object states, field, and behavior methods together. If you are creating the class, you are doing encapsulation. In this lecture, we will see how to encapsulate in Java program. The question here is, what is encapsulation? The whole idea behind encapsulation is to hide the implementation's details from the user. If a data member is private, it means it can only be accessed within the same class. No outside class can access private data member variable of other class. However, if we set up the public gather and setter method to update, for example, here I just write void and set ssn and then int ssn and read like int get ssn here. The private data field, then the outside class can access these private data field via public methods. This way, data can only be accessed by public methods, thus making the private field and their implementations hidden for outside classes. This is why encapsulation is known as data hiding. Let's see the example of the encapsulations to understand the better concept of the encapsulation. So here I just create a class with the name of encapsulation. You can see here I just write the private int ssn. So this data member is private here. So now I just write private string and employee name. Now this is also private, this detail hidden from the user, and int emp employee age. Okay, now we just gather the setter method here, public string and get emp ssn. This is the method, and it will return us SSN. Now here I just write public string and then get emp name. Okay, so this is a method here for the employee name, and it will return emp name. Okay, and this is return ssn here. So it's not a string, it's an integer here. That's why it's giving an error. Now public static, sorry, it's not public integer, and get emp age. This is a method for age, and return employee age here. Now here I just write public void and set emp age, which is integer, so which is the integer of new value. So these are the parameters to my set emp age method. And now here I just write emp age, which is equal to new value. And then here I just write public void set emp name and then string new value. Then emp name here, which is equal to new value. Okay. And then it's public void set emp ssn and then integer, which is the new value here. So integer, which is the new value here. Okay. And now I just write ssn, which is equal to new value. Now here I just create a new class with a name of incaps test dot java, and here I just write public static void main. So this is the main method here, and then here I just write string arguments, and then encapsulations mean I just create an object to this class. So encapsulation object, which is equal to new encapsulation. Now object dot set, and it's an static here. So object dot set employee name here, and then values here are Fayaz, and then object dot set age, and the age is 25. Then object dot set ssn, which is the ssn number is 12223. Now here I just write the print statement. So print line and then employee name, and then I concatenate the object here, which is obj dot employee name, then system dot out dot print line, and the print line here is employee ssn, and then I just concatenate object dot set ssn number, and there is no value. So now here I just write system dot out dot print line, and the print line here is employee age, and then just concatenate object dot get employee name. Sorry, not get employee name, it's employee age. And here I just write object dot get employee SSN number. So here I just make the instance variable private. You can see, so that they cannot be accessed directly from outside the class. I just access with the help of object, and then I just print the statement and concatenate these um, variables. You can only set and get the values from these variables through the methods of the class. You can see I just create the many methods of the class for get employee SSN, then get employee name, and get employee age. So here you can see I just take the data types, which is a value of which is a value of new value. So, and then you have the getter and the setter method in the class to set and the get the value from the field. You can see I just set the gather and the setter method here. You can see public static uh, public int get employee ssn. So these are the getters and the setters methods here. So what is a gather and the setter method? Gather and the setter methods are used in encapsulations the field of class by making them accessible only through this public method and keep the value themselves private. This is considered as a good object-oriented principle. It's not correct rather, and the setter methods are used to get and set the values of any of the integer or any of the value, which is the way to achieve the encapsulation. So now we just see the advantages of the encapsulation in Java. It is important, it means encapsulations improves the maintainability and flexibility and reusability. For example, in this code, the implementations code of the void get employee name means here where yes employee get employee name and string employee name, and here the string employee name. So it can be changed at any point of the time. Since the implementation is purely hidden for outside the class, they would still be accessing the private field employee name using the same method like set employee name string name, and get employee name. Hence, the code can be maintained at any point of the time without breaking the classes that use the code. This improves the reusability of the underlying class. Another advantages is that the fields can be made read only. If we do not define the setter method in the class, or write only if we do not define the gather method in the class. For example, if we have field or a variable that we do not want to change, so we simply define the variable as a private. And instead of the set and get, both we just need to define the get method for the variables. Since the set method is not present, there is no way an outside the class can modify the value of that field. The third advantages of encapsulation is user would not be knowing what is going on behind the scenes. They would only be working with the update a field called method and the read a field called method. But they these set and get methods are doing is purely hidden from the user. So the main um, advantages of the encapsulation is data hiding from the user. So encapsulation is also known as the data hiding. So here I just tell you what is different between the abstractions and the encapsulation, because we also do the data hiding in this abstraction. So abstractions are in Java, abstractions solve the problem in the design level, and in encapsulation the encapsulation solve the problem of the implementations level. Means abstraction solve the problems on the design level, but the abstraction solve the problem in the design level, and the encapsulation solve the problem at implementation level. Abstraction is used for hiding the unwanted data and gives the relevant data only. But the encapsulations mean hiding the code and the data into a single unit of the protect and data from outside world. Abstractions let you focus on what the object does instead of how it does it. But encapsulations mean hiding the internal details or machines of how an object does something. And the abstraction is an outer layout used in the term of design. For example, outer look of a mobile phone or any of the website, like it has a keypad buttons to dial numbers or a display screen. But the encapsulation is an inner layout used in a term of implementations. For example, inner implementations details of a mobile phone, how display screen and the keyboard are connect with each other using circuits. So here is a real world example to differentiate between the abstractions and the encapsulations. Like you have a mobile phone, okay, and you can dial a number using keypad buttons. Even you don't know how these working internally. This is achieved in Java abstraction. But how the mobile phone internally works and how keypads buttons are connected with internal circuits, this is achieved using encapsulation. So this is the example of the encapsulations and some methods and some rules and some advantages of the encapsulation in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture, we are going to be discussed about the packages in Java. Packages are used in Java in order to prevent the naming conflicts to control the access, to make searching location and usage of classes interface enumerations and annotations easier. A package can be defined as a grouping of related types, which are classes, interface, and enumerations and annotations, providing access protections and namespace management. The purpose of the package is the concept is to provide the common classes and interfaces of any program separately. In other words, we want to develop any class or interface which is common for most of the Java programs. Then such common classes and interfaces must be placed in a package. Like here you can see I just create a package name. So this is our package, which is an abstraction. So here I just create a class which is circle, or I just write here we have the two same classes with the name A and A. So that's why we just use the package here. Here we have a diagram of the package. So you can see a simple example like our package name is a Java. Then we have the sub packages of the Java, like the library for the scanner, lang, and the GUI, like AWT. You can see we have the map class with util, then language class with the system class and the string class, and then the GUI, which is the button classes. So that's why I just create the package of the Java, then sub packages, and then different categories of GUI, scanner class, and lang class. Package in Java are the way to organize the files. When a project has many modules, some like we organized our file in computer. For example, we store all the movies in one folder and song in another folders. Here also we store same name of the file in the particular package of the particular package. For example, in AWT package have all classes and interface for design GUI components. You can see we have util and lang, then SQL AWT package here in Java, and then computer we have the movies, songs, ebooks, software, which are the folders. What are the advantages of the package? Package is used to create the classes in an interface so that they can be used easily and maintained. Application development time is less. You can see application development time is less because reuse of code. We just use many time of codes here in these packages. You can see now application execute time is less. If I just create a many classes in one package, you can see so we have the execution time is much higher than these two classes. Redundancy or repetition of code is minimized here. Application's performance is enhanced, improve. Package provide access protections and the package removes naming collision. There are two types of packages which are packages are predefined or built-in package and user-defined package. So what are the predefined or built-in packages? These packages are which are already designed by Sun microsystem and apply as a part of Java API. Every predefined package is collection of predefined class interface and sub packages. What are the user defined packages? The user defined packages are if any package is designed by the user is known as user design package. User defined design package are those which are developed by Java programmers and apply as a part of their project to deal with the common requirements. So these all are the user defined package and this is a default package which is a built-in. So here's the some rule to create the user defined packages. Package statement should be the first statement of any package program. Choose an appropriate class name or an interface name and those modifiers must be public. Any package program can contains only one public class or only one public interface, but it can contain any numbers of normal classes. Package program should not contain many classes. That means it should not contain any main method. Modifier of a constructor of the class which is present in the package must be public. Means this is not applicable in the case of interface because interface have no constructors. The modifier of the method of a class or interface which is present in package must be public. Means this rule is optional in case of interface because interface method by default public. Every package program should be saved either the with public class name or a public interface name. Like here we have some.java program class and save the package program with public class name. Then package my package name, which is the first statement of the Java program, is package. Then public class sum and class modifier must be public here. Then public sum and constructor modifier must be public in these case too. Then system.out.println, which is some class constructor. And then when we use the void method, so modifier must be public. And then system.out.println. The compile package programs. So for compilation of the package program, first we solve the program with public class name.java, and then it will compile this syntax like Java C minus D class name and then Java, or a syntax of the path like Java C and then path class name dot Java. So in this syntax, minus D is a specific tool which is to tell the Java compiler create a separate folder for the given package in the given path. When we give a specific path, then it create a new folder at that location, and when we use dot, then it create a folder that current work directory. Note that any package program can be compiled but cannot be executed or run. These programs can be executed through user-defined programs, which are importing the packages program. Here, I just create example of this package, and then in the source, I just create a package which is the name of my package. Okay, here I just create a class which is the name of a.java. Here you can see my package and my package. Then the public class A, and here I just create a method which is public void and show, and then system.out.println, and the println here is some method, and then I just create a new class with the name of hello, and then I just write public and class hello. So in the public class hello, I just write public static void main and then string arguments, and here I just write a which is equal to a and object of a which is equal to new and a, then a dot show, and at the last system dot out dot println, and here I just write show, and show is class a. So here remember that here I just import a library which is my package dot a. You can see here, and then I just run this code. So some method and then show and the class show. So in this example, the first we create the package program which is saved with a.java and compiled by java c minus d dot a dot java. And then again we import the class A in the hello using the import my package.a statement. So here I just add some more information about the package. So different between the package and inheritance are inheritance concept always used to reuse the feature within the program between the class to class and interface to interface and interface to class, but not accessing the feature across the program. The package concept is to reuse the feature both within the program and across the program between class to class and interface to class. And different between the package keyword and the import keyword. So package keyword is always used to creating the undefined package and placing common classes and interface. And import is a keyword which is used for referring or using the class and interface of a specific package. So this is some information about the packages in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about the access modifier in Java. Access modifiers are those which are applied before data members and the methods of a class. There are used to where to access and where not to access the data member or methods in Java programming. These are classified into four types. First one is private, then default which have the no keyword, then protected and public. Note that default is not a keyword like public private, protected, or keyword. If we are not using private, protected, and public keywords, then Java Virtual Machine is by default taking as a default access modifier. Access modifiers are always used for how to reuse the features within the package and access the package between class to class, interface to interface, and interface to class. Access modifier provide features accessing and controlling mechanism amongst the class and the interface. Here you can see the class B and the class A and class C. We have the two packages where in class A we have the private, public, protected, and default. In private, the accessible of class A is no one, means we cannot access class B and class C. But in public we have access to the both class, which are class C and class B. Protected have the only access of one class, which is class B, but it cannot have the access of class C. In default, the same like the protected, it have the access of class B, but it have no access of class C. Note that protected member of the class are accessible within the same class and another class of the same package and also accessible in inherited class of another package. Here we have some rules for access modifier. So first one is our private. So we can access within the same class, but within other class of same packages we not access the private modifier. Within derived class of another package we cannot access the private modifier. And within the external of other package we cannot access the private modifier. In default we can access the same class, we can access it in within the other class of the same package, but we cannot access the derived class of the other package and external class of the other package. Now the same case like protected, within the class we can access it, with other class of the same package we can access protected modifier, and within the derived class of other package we can access this private protected modifier, and within the external class of the other package we cannot access protected modifier. And the public modifier is a universal modifier. We can access it in any level or any stage or any of the package or the class in our Java. Private members of a class is not accessible anywhere in the program. These are only accessible within the class. Private are also called class level modifier. Here I have an example of private modifier, which is the class private one, and then I just use a modifier which is int private int a, which is equal to 20, and then private void, which is show. Then system dot out dot print line, and the print line here is hello private modifier, and this is private. Okay, and now we just go to the another class, which is private 2.java. Here I just define the main method, so which is public static void main and string arguments. And then here I just write private one and the object to my private one class and new private one. Okay, and then system dot out dot print line, and the print line here is object dot and the object to my a private modifier. Now I just check this private and this is a. Okay, so at the compiler time error, you cannot access private data, and then object dot show. So here the compile time error, you cannot access the private method here, means you cannot access the private data and you cannot access the private method. So that's why they are giving the error here. Now we just see the public member of any class are accessible anywhere in the program, in the same class and outside of the class, within the same package and outside of the package. Public are also called universal access modifier. Now we just change these two classes with the public. So here we have in 20 and then the method is show, and here I just write it's a public modifier, and I just go to the public class 2, sorry, the private class 2, and here the main method, and same like private 1 and object and then string. So I just simply change this private with public and public. You can see the error is automatically cleared here. When I just run this code, so the output for this code is 20 and hello public modifier. Now we just see the example of the protected modifiers. Now, protected member of the class are accessible within the same class and another class of the same package, and also accessible in inherited class of another package. Protected are also called derived level access modifier. Now here I just remove this example and then I just create a class which is pack1.java, and then create another class with pack2. So now here in this class I just write public class A. So it's a public class package, and our package name is access modifier. So here I just write protected void show. So this is a method here, and then I just write system dot out dot println, and the println here is hello I am protected. So now just go to the, I just remove this class, and in the access modifier I just create a package with access modifier 1. So here I just create a class which is pack2, and then I just import which is access modifier, and I just not to import here, I just transfer this file in the same package, and here I just write import access modifier and dot static, and dot here I just write pack1. Okay, here I just use a keyword which is extend, and extends package number 1. Now here I just write public static void main strings, string and the argument. So package number 2 and create an object to it which is equal to new pack2, and then object dot show. Now I just run this code so you can see hello, I am protected. So in this example we have created the two package which is pack1 and pack2. In pack1 class pack1, so here I just create a package which is access modifier and the two classes which is pack1 and pack2. So in class pack1 is a public, so we can access this class outside the package, but method shows is declared as a protected, so it is only accessible outside of the package. Number one, sorry, access modifier in the package access modifier only through the inheritance. So now we just go to the default access modifier. So default member of a class are accessible only within the same class and another class of the same package. The default are also called package level access modifier. So here I just create a package which is default access and then create a class with the name of class a.java. Here I just write void show. It's a method here and then system.out.println, and the print line here is hello default. Okay, now we just go to the another class which is b. So we have the class b, and here in the default package, so and I just write import, and import is default access, so it's default access and dot a. Okay, and then public static void main and strings arguments, and here I just create an object, so a object which is equal to new and a, and then object dot show. Okay, so here a compile time error is not occurring, so you can see hello, it's a default. So private access modifier is also known as native access modifier. Default access modifier is also known as the package access modifier, and the protected access modifier is also known as an inherited access modifier. And I just told you public access modifier is also known as a universal access modifier in Java. So thanks for watching this lecture. See you in next.
Welcome to this lecture, and in this lecture we are going to be discussed about the multi-threading concept in Java. Before we asking about the multi-threading, let's discuss the thread. A thread is a lightweight, smallest part of a process that can run concurrently with the other threads of the same process. Threads are independent because they all have the separate path of execution. That's the reason of an exception occur in one thread. It doesn't affect the execution of other threads. All threads of a process share the common memory. The process of executing multiple threads simultaneously is known as multi-threading. Here we have some points to summarize this discussion, which are: the main purpose of multi-threading is to provide the simultaneous execution of two or more parts of a program to maximize utilize the CPU time. A multi-threaded
program contains two or more parts that can run concurrently. Each part of a program is called thread. Threads are lightweight subprocesses. They share the common memory spaces in multi-threaded environment. Programs that are benefited from multi-threading utilize the maximum CPU time so that the IDE time can be kept in the maximum or the minimum. A thread can be in one or the more following states, which are new, runnable, blocked, waiting, time waiting, and terminated. So what is the new here? A new thread that has no yet started in this state. It's called new thread. Runnable thread is a thread that executing in the Java virtual machine is in this state. And the block thread is that is blocked waiting for a monitoring log is in this state. The waiting thread is a thread that is waiting identify for another thread to perform a particular action in this state. And the time waiting thread is a thread that is waiting for another thread to perform an action for up to a specified waiting time in this state. And the terminated thread is a thread that has exited in this state. A thread can only one state at the given point in this time. Here we take a look on thread lifecycle in Java. The start method creates the system resource necessary to run the thread, schedules the threads to run, and call the threads run method. Here you can see a new runnable and then non-runnable and the block thread and runnable and the terminated. So a threads become non-runnable when one of these events occur, like if sleep method is invoked, the threads call waiting method, and the thread is blocking in input and output. So a thread dies naturally when the run method is exit. So here you can see a new thread then runnable if the thread becomes non-runnable. So if the reason of that is the thread is has a sleeping method, the threads call the waiting method, and this thread is blocking on input and output. So you can see when the sleeping is done, so it's just go to the runnable and then running, and then at the last terminated like run method exists. So if the running is not working here, so it's just go to the sleep block on input and output waiting for the log and suspend the wait, and then it's go in non-relevant condition, and then it is resume, and then it's start work here. So now we just see what is thread scheduling. Execution of multiple thread on a single CPU in some order is called scheduling. In the journal, the runnable thread with the highest priority is active running. Java is a priority primitive language. If a high priority thread wakes up and the low priority thread is running, then the high priority thread gets to run immediately, allows on demand processing and efficient use of CPU. Let's suppose these are the six threads here, and the runnable have the high priority than others. So the it will be execute fast instead of these all. So what are the types of scheduling in the threads? First one is the waiting and notifying, then wait, notify all, running and yielding, and then sleeping and wake up. So waiting and notifying. Waiting is a wait and modifying is a modify, and modify all provides means of communication between the threads that synchronize on the same object. Wait When wait method is invoked on the object, the thread executing that code's given up its lock on the object immediately and move the thread to the wait state. Notify means this wake up threads that call wait on the same object and move the threads to its ready state. Now notify all is this wake up all the threads that call wait on the same object. And the running and yielding is yield is used to give the other threads of the same priority a chance to execute. For example, the causes current running threads to move to running state. Now you just see sleeping and waking up scheduling of the thread. So n sleeping is used to pause a thread for a specified priority of the time. Move the current running thread to sleep state for a specified moment of a time. Before moving it to runnable state, thread.sleep means no of millisecond. So threads always work on the priority base. Now we just see the what is multitasking versus multi-threading and multiprocessing versus parallel processing. So if you are new to the Java, you may get confused amongst these terms and they are used quite frequently when we discuss multi-threading. So let's talk about multitasking. What is multitasking? So ability to execute more than one task at the same time is known as multitasking. And the multi-threading is we already discussed about it. It is a process of executing multiple threads simultaneously. Multi-threading is also known as multi-based tasking. Multiprocessing, it is same as multitasking. However, in multiprocessing, more than one CPU are involved. On the other hand, one CPU is involved in multitasking. Now we just see the parallel processing. It's referred to utilization of multiple CPU in single computer time. How to create the thread in Java. The two ways to create the thread in Java. One is extending thread class and another one is by implementing runnable interface. Before we being with the program's code of creating the thread, let's take a look on these methods of the thread classes. We have used few of these methods in our Java like get name, priority. Get priority is alive, join, run, sleep, and start. So get name is used for obtaining the thread name. Get priority is used for obtain a thread priority, and is alive is determined if a thread is still running. Join is for waiting for a thread to terminate. Run is the entry point of the thread, and the sleep is suspend a thread for a priority of the time, and the start is a thread by calling its running method. Now we just see the example of the thread creation by extending the thread class. So I just create a class with the name of multi-threading. So and here I just extend the class which is thread. Now here I just write public void and the run method, and then system.out.println, and the println here is my thread is running state. So I just define a method which is run, and then the print line which is my thread is in running state. Then here I just write the main method public static void and main and strings and the arguments. Now I just copy this class name and create the object to it which is equal to obj and new multi-threading. And here when I just create an object, so I just choose the start. So you can see start void is thread. So I just save this code and then I just execute. So my thread is in running state. Now we just go to the another example of the thread, and here I just create a class which is the name of count, and it's count here. Now I just extend this class with thread, and here I just use count as a method and then use super keyword, and here I just write my extending thread, and then system dot out dot println, and then println is my thread created, and then just concatenate this keyword, and then start. So this is a super keyword, so start with small s and start our thread here. Now I just create a method which is for run, and then use for statement, and for integer which is I is equal to 0, I is less than 10, and I plus plus. So this is a for loop here, and then I write system dot out dot println, and the println here is printing the count and plus I. Now here I just use thread dot sleep and thread dot sleep. So our thread is sleep here, means it will off for a 1 second. So I just write 1000 for my this thread, and this is a column here, and not a column, and I is less than, okay, and the thread is sleep for 1 second. Now so I just write thread dot sleep, sleep for 1000, okay. Now here I just define the catch exception, and then interpreter, and interrupted thread is interrupted for exception e. So here I just write the class which is interrupted exception e. So this exception is thrown when a thread is writing sleeping, or otherwise it's occupied and the thread is interrupted either before or during the activity. So a method may wish to test whatever the current thread has been interrupted, and if so, immediately thrown this exception. So you can write this code like interrupted exception, okay. So I just define an exception which is interrupted, and the interrupted here is exception e. Now system dot out dot println, and the println here is my thread, and thread is interrupted, okay. And then I just go to the another line of code, and which is system dot out dot print line, and the print line here is my thread run is over here. So I just go to the another class now, and before we just go to the another statement, so I just define one try statement here. So try and the catch, and now I just go to the another class which is extending example, and here I write the main method. So public static void main, and then here I just write a string and the arguments. Now here count and object which is equal to count, new count, and then try statement exception. So while cnt dot is alive. So is alive is java dot lang thread is alive method test. If this thread is alive, a thread is alive if has starting and has no yet died. So this method is used for a thread is alive if it has been started and has not yet died. And then I just start system.out.println, and the println here is main thread will be alive till the child thread is live. Okay, and now here I just write the code which is thread dot sleep and sleep for 1.5 second, so it's 1500. And then I just use catch, and catch is interrupted exception which is e, and system dot out dot print line, and the print line here is main thread interrupted. And after that I just write system dot out dot print line, and the print line here is main thread is run over. Okay, now we just check the output, and now you can see here my thread is created, and then my exception thread is 5 main, and the main thread will be alive, and it's and the child thread is live. So it will print after one, you can see here 1 second, 2, 3, and then 1.5 second, you can see here. So its thread is executing after 1.5 second. So this is example, or this is also example of thread creation by extending thread class. Now we just see the second method to create by implementing the runnable interface of the thread. So here I just write source package thread and create the class which is multi threading, and here I just implement because I am just using thread with the interface, so I just use implements here and runnable. So now I just write public void and run, and then system dot out dot println, and the println here is my thread is in running state. Now main method, main public static void main, and then string and the arguments here. Now this class name, because I am making the object here, so multi-threading obj, which is equal to new, and multi-threading. So I just call the thread here, which is obj thread obj, which is equal to new thread. So I just make the object to the thread here, and I just change the name of this object, which is object number 1, and I just call my this object here in the thread. So object 1 dot start here. So now I just run this code, and here you can see my thread is in running state because I just create an object to my multi-threading class here, and then I just call this object in my thread, and the answer of this is my thread is in running state. So we see in this lecture we made thread by creating the thread class, and we just made a thread with implements like the interface. But what are the advantages of multi-threading in Java? So it does not block the user because threads are independent and you can perform multiple operations at same time. You can perform many operations together, so it saves our time. And then threads are independent, so it does not affect other threads. If exceptions occur in a single thread, so it will handle it. So this is the multi-threading concept in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about the enumerations in Java data structure. Before the version of JDK5, there lacked one feature that many programmers felt was needed. This is the enumeration. It is a list of name constants. It is supported by the most other programming language through the Java offers the similar types of the features that provide somewhat similar functionality as such as the final variable. Still, programmers are in a eager need of the concept of enumerations. In this lecture, we are going to be learn about what is enumerations and how it is used within Java programming language to do the different tasks. Before proceeding this lecture, we just need to know what is enumeration. Enumeration is a list of name constants, and these Java enumerations define a class type by making enumerations into the class. The concept of enumeration is greatly expanded in Java. The simplest form, Java enumerations, appear similar to the enumerations in the other language like C++ and the Ruby. Expected that the class play a major role in this concept, like here, the enum and the month. So, the enum month is a user-defined data type here, and when just write January, February, March, and April. So these are the user values of the user defined data types. And you can see the enum here. So this is a keyword for this language. So enumeration is used using the keyword which is enum, as you can see here. So the enumerations interface defines the method by which you can enumerate the elements in collection of the objects. The legacy interface has been superseded by iterator, although not deprecated enumeration is considered. obsolete of the new code. However, it is used by several methods defined by the latency classes, such as vector and the property, is used by several other API classes, and it's currently in wide separate use in application code. Here, the two different methods to declare the enumeration by summarized. So here you can see boolean and has more. This is has more elements. So when implemented, it must return the value while there are still more elements to extract, and false when all the elements have been enumerated. And the another method is object next element. So this return the next object in the enumeration as a generic object reference. So here we just go to the simple example of the enumerations. So here I just write enum and pl types, and means pl types mean the programming language types, and high level, so these are the values of the user defined data types, and then machine level, assembly, and middle level. So enumerations of a varieties of the programming language you can see here. So here the identifiers means level language, machine level language, etc. are called enumeration constants. There are no semicolon with it. So each of them is implicitly declared as a public static final member of the programming language types, means PL types. Here you can see this one, enumerations. Hence, the language of the Java, these constants are referred to as self types, where self refers to enclosing the enumerations. Once the enumeration is defined, programmers can create a variables of its types. However, even through enumerations define a class types, programmers do not initiate an enumeration using the new. Instead, they declare and use the enumeration variables like that of the primitive data types as used before. Like here I just write programming language types and then lang, and then lang which is equal to pl types dot assembly, means we have the pl types which are languages, and then languages which is equal to pl types, and the language name is assembly here. So this declare the language as a variables of enum types, pl types like this here, and you can see. Now I just write if, and then lang which is equal to pl types dot machine level, and close this code here. So these are the two enumeration constant can be compared for checking the equality by the use of is equal to relational operator. For example, this compares the value of the lang as a value machine level. So after that, here I just write switch and switch here, and then lang, and case assembly, and then case middle level. So here I just use switch to use the enum to control the switch cases. It is to be noted that an enumeration's value can also be used to control a switch statement. It is of course necessary that all of the case statement must be constant from the same enum as that used by the switch statement. So you can see here I mentioned switch case statement is a valid statement in Java. Now we just see the enum with values and values of method. Here you can see I just write public static enum type and then here I just write values. Then public static enum and types, and then values of, and the values of string, which are str. All enumerations automatically contain two predefined methods here, values and the values of. So these are the general forms and the statements of the value and the values of. Now here we just see the example of the enumerations in Java. Here I just take a package which is enumeration, and then in enumerations I just take an enumeration class, which is, here I just write enumeration tester. So this is the enumeration class in Java, which is enumeration tester, and this is our package name. And here I just import the library which is java.util and vector, and util.vector, and another library which is import java.util and then enumeration. Okay, so here our in public enum, which is a keyword, and then the class name, which is public static void main, and then a string arguments. And here I just write enumeration, and which is days. Okay, so this is the value of the user defined data types, and now here I just write vector and day names, which is equal to new vector. I just create the object, and then days, which is name dot add, and the day's name is Sunday, and this is the day's names, second, third, fourth, five, six, and here I just write Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So this is the day name here, and the day name, so yes. Now I just write here, I just call this enumeration, which are days. So days, which is equal to day name dot elements, and this is the names and element. Now here I just write the while loop. So while days dot has more elements, you can see here has more element method in the enumeration. So now I just system dot out dot print line, and I just call this method in days method calling, which is days dot next element. Okay, so here as you can see I just create a enum, which is the name of the user defined data types and the keyword, and this is the user defined data type. And then the value of the user defined data types are the Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. And now, so here you can find an error which is a enum. So I just change the enum with the class right now. And then I just run this code, which is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and the Saturday. As you can see here, we have the variety of the days in our this program. Now we just see one another program with enumerations, and here I just write the class name, which is enum, and I just remove this code, and here I just write public enum, and enum is the enumeration tester. Now here I just write high level, machine level, assembly, and middle level. Okay, so these are the values of the user defined data types of the enumerations. I just remove these libraries, and here I just create a class which is the name of enum, and enum.java. Okay, now here I just define the public static void main and then strings arguments, and then here I just create the enum tester, and then language, and then system dot out dot println, and the println is here are list of constants, and then I just write enumerations tester, and here I just write all types, which are the array which is equal to enumerations dot values, and here I just use the for loop for the enumeration tester, which is a, and the colon of the all types. Okay, and then I just write here system dot out dot println, and the println here is a. So I just want to print the for loop of a, and a which is equal to all types, and then here I just write system dot out dot println, so it's a println, and the println is nothing, means empty, and then I define lang, which is equal to enumerations tester dot values of. So here I just use the two methods, which is the value and the values of, and then I just pass the string as an assembly here, and then system dot out dot println, and the println here is values is, and then I just concatenate this variable which is lang, and I just run this code. So here, and you can see the value is the assembly, and this is the value is method, and then it is a middle level. You can see here it's a middle level, and then value is a assembly here. So now we just go to the another example of the enum in Java. Enumerations serve the purpose of representing a group of named constants in a programming language. For example, the for suits in a deck of playing card, maybe the four enumerators named club, which are diamond, heart, spade, and a club, belonging to an enumerated type's name, which is suit. Here we have another example, which is include natural enumerated types like the plant, days of the week, color, and directions, etc. Enums are used when we know all possible values at the compile time, such as choices on a menu, rounding modes, command line flags, etc. It is not necessary that the set of constant in a enum types stay fixed for all the time. In early since we just see in Java from 1.5 enums are represented using the enum data types. Java enums are more powerful than C or C++ enums. In Java, we can also add variables, methods, and constructor to it. You can see here we just add the variables and many of the methods which are the value of and values method. The main objective of the enum is to define our own data types and enumerate data types. You can see here this is our own data types here, and then we just call these types here. Now we just see one another example on the enum, which is so simple, and then enumeration one, and here I just define the enum, and here I just write enum, which is color. And now we have the public enum key and then the data types, which is color. So we have the color red, green, blue, and it's red, green, and blue. Okay, so these are our three data types. So here I just declare the enum outside the any class, mean I just create a class name which is a color here. Enum keyword instead of the class keyword I just define here, which is class, and then I just create a class which is test. Now driven method, which is public static void main and string arguments, and here color, which is c1, means color one, and I just create an object to it, so color dot, and I just call my data type which is red, and then system dot out dot print line, and the print line here is c1. So here I just write the keyword which is enum instead of class, but here I just write the keyword which is class. Now I just see the output, and here I just call the object only which is red here, and this is the output which is red. Now we just go to the enum and the inheritance. I just told you that we are used enum with inheritance and the constructor also. So all enums implicitly extend java.lang.enum class. As a class can only extend only parent in Java, as an enum cannot extend anything else. ToString method is overriding in java.lang.enum class, which return the enum constant name, and enum can implement many interfaces. Here enums used some of the methods I just use in my last examples, which are the values and the values of, and one another method which is ordinal method. These methods are present inside the java.lang.enum. So the values method can be used to return all values present inside the enum. Order in order is important in enum by using ordinal method. Each enum constant indexed can be found just like array indexed, and the value of the method return the enum constants of the specified string value if this value is exist. Now here we can see the enum example with inheritance. Here I just write package, and the package here is enum, and then inheritance, and where I just create a class, sorry, enum, which is same example color, and we have the red, green, blue color, and it's blue color. Okay, so this program is for demonstrate the working with our values, ordinal and the values of method. So here I just create data types which are red, green, and blue. Now here the test class, and the test class here I just write the driven method or a main method which is public void main, and then strings arguments. Here I just call the value, means here the values. I just use a method which is values. Color, so it's a capital color which is array index is equal to color dot values. So I just call my first method which is the values here. So this is get the values from our this color method class. Now I just use enum with loop color and col which is equal to array, and now I just call the ordinal method to find the index of the color, system.out.println, and the print line here is color plus, and here I just write at indexed plus color dot ordinal method, and just close this code here. Now I just write system.out.println, and the print line here is color dot values, value of method, and here I just pass the value which is red. So here I just use the values of to returns an object of the color with this given constant, and uncommitting second line causes exception, illegal argument exception, and here you can also use like system.out.println which is a color dot values of blue and green. So I just run this code here, and color, and you can see red at the index 0, then green at the index 1. You can see here red at the index 0, so I just getting the indexing values of that, and then blue at the index 2, so 0 1 2, and then I just print my values of color is red, you can see here. So now we just see the another example with enum and the constructor, and the new package and enum constructor. Here I just create enum, which is same example color. So enum can contain constructor and it is executed separately for each enum constant at the time of enum class loading. We cannot create enum object explicitly and hence we cannot invoke enum constructor directly. Remember that enum can constant constructor and it has executed separately for each enum constant at the time of enum class loading in constructor, and we cannot create enum object explicitly and hence we cannot invoke enum constructor directly in constructor. And here I just create this example with enum concrete method only. We have we have not used the abstract method in this example. So enum is a keyword and then the data type is color, red, green, blue. Okay, then here I just create the constructor which is private color, and then system.out.println, and then the print line is constructor card for, and then concatenate this dot to string. So this is enum constructor called separately for each constant, and you can see here I just define the enum which is a keyword instead of class keyword, and this is the enum constructor which is called the separately for each constructor. And then here I just write this dot to string. Now I just create the concrete means not abstract method, and here public void color, and color is a info here, and then system dot out print line, and the print line here is universal color. Okay, so this is only the concrete method, and then we just go to the class. Class is a test here, and then I just write the driven method or main method which is public static void main string arguments, sorry, arguments, color which is c1 is equal to color dot red, and then system dot out dot system dot out dot print line, and the print line is c1, so it is print our this color only. Then c1 dot color info. So now I just run this code, and you can see first of all I just call the constructor for red, then green, then blue, and then this color which is red, and then I just told you that this is the universal color. You can see here it is the main method which is the color info of, and then I just call c1 dot color info, so this is the universal color here. So these are the some example of the enums with constructor, inheritance, and the enum classes. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about the bit set class in Java data structure. The bit set class creates a special type of array that holds the bit values. The bit set array can increase in the size as needed. This makes it similar to the vector of the bits. This is a legacy class, but it has been completely re-engineered in Java 2 and the version of 1.4. The bitset class defined with two constructor. One is the bitset and another one is bit set and int size. So first one is this the constructor create a default object. So this constructor create the default object and then bit. So it's a bit set in int size means this constructor allows you to specify its initial size. For example, the number of the bit that it is can hold. All the bits are initialized by 0. So here I just create an example of the bit set in Java. So here I just import a library which is java.util and then bit set. Here we have the class name which is a bit set and then public static void main. And now I just write bit set which is the bits 1 is equal to new bit set. So the object to my bit set is bit 1. Now I just create one another object bit set and then bits 2 is equal to new bit set and the value of this object is also 16. Now we have the two object which is bits 1 and bits 2. Now I just set some bits here. So for statement for loop and then for I int I is equal to 0, I is less than 16 and I plus plus. So yes. Now here I just write if I percentage sign of and then 2 is equal to 0 and here the bracket. Now I just set the bits 1 and set which is the value of I. Now if I percentage sign 5 which is not equal to 0. So here bits dot set and then I. So it's not equal to yes. So bits 2 dot set here. Now I just write print statement and print line which is initial pattern in bits 1 and then system dot out dot print line and the print line here is bytes 1 system dot out dot print line slash n for the single line break and initial pattern in byte 2. So I just printing the sum of the bits here, so that's why I'm just using these print statement and print dot and then I just write bytes 2. Okay, first I just print my this statement initial pattern in bit 1 and then I just print my this bit means the object to this bit and then bit 2. Now I just print the end bits, and here I just write bytes 2 dot end, and here I just write bit 1, and then system dot out, sorry, it's system dot out dot print line, and the print line here is slash n and bits 2 and bits 1. Now system dot out dot print line, and the print line here is bytes 2. Now I just print the bits with or. So bits 2 dot, I just choose or, and then bit 1. Now system dot out dot print line, and the print line here is slash n and then bytes 2 or bytes 1, and then system dot out dot print line, and the print line here is bits, so it's a bits 2, I just call the bit 2 here. Now bit with XOR operator, so I just use the bit with XOR, so bit 2 dot XOR, and set the bit 1. System dot out dot print line, and the print line here is slash n and bits 2 XOR and bits 1. So now here system dot out dot print line, and the print line here is bit 2. Now we just check the output for all these printed bits. So I just run this code, and then you can see our initial pattern bit 1 is 0 1 2, sorry, 0 2 4 6 8 10 12 and 14. So it's just modulus of 2 here. You can see here it's print only the modulus of 2. Then initial bit of the pattern in bit number 2. So it is a modulus of 5, and then 1, 2, 3, 4, 6, 7, 8, 9, 11, 2, 12, 13, and 14. Then we just print our bits with AND operators. So it's 2, 4, 6, 8, 12, 14, and bit 2 with OR operator of bit 1s, which is 0, 2, 4, 6, 8, 10, 12, and the 14. And we have no XOR bits here with the bits number 2 with XOR operators are empty here. Now we just see one another example with our bits using the constructor. So here new, and then the class, which is the name of bit with constructor. Okay, so now here I just import a library which is java dot util, and then the class name which is beacon. So here I just create a constructors of the bit class. So first I just create public static void main, and then string arguments, and then I just write constructor of the class, which are bit set bs1 object, which is equal to new bit set, and then the no value here, and then bit set, which is bs2, which is equal to new, and then bit set, which is I just write 16 not instead of 6. Yes. Now bs1 dot set 0. So here I just set the bit class method. So now bit1 dot set, which is 1, bs1 dot set, which is 2, bs1 dot set, which is 4. Then now I just assign the values to the bit number 2. So bs2 dot set, which is 4, and then bs2 dot set, which is 6, bs2 dot set, which is 5, bs2 dot set, which is 1, and bs2 dot set, which is 2 here, and at the last bs2 dot set, which is 3. Now I just print these two bits. So system dot out dot print line, and the print line here is bs1, and then I just concatenate bs1. Then system dot out dot print line, and the print line here is bs2, and then concatenate bs2 here. Now I just run this code. So you can see it's not give us the desired output. So I just run it again. We are not getting a right output for that because I'm just use main. So I just missed n with the main, and now I just run this code. So bs1, which is 0 1 2 3 4, so these are the bits value of our bit number 1, and these are the bit values for our bit number 2, which are 1 2 3 4 5 and 6. 1 2 3 4 5 6 in the sequence. So here there are some important points for the bit set. So the size of the array is flexible in the bit set, and it can grow to accommodate additional bit as needed. Then, as it is an array means a bit set is an array, the index is 0 based, means this bit set index is 0 base, and the bit value can be accessed only by non-negative integer as an indexed. Then we just see the default value of the bit set is boolean, means the false, with the representations of 0 means off. The calling the clear method make the bit value set to the false, and then bit uses about 1 bit per boolean value, and to access a specific value in the bit set, the get method is used with an integer argument as an indexed here. So this is examples of the bit set in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture, we are going to be learn about the vector in the data structure. The vector class implements a growable array of an object. Like an array, it's contain components that can be accessed using an integer indexed. However, the size of a vector can grow or shrink as needed to accommodate the additions or removal of the element. Each vector tries to optimize the storage management by maintaining a capacity and a capacity increment. The capacity is always at least as large as the vector size. It is usually larger because components are added to the vector. The vector storage increases in the chunk size of the capacity increment. An application can increase the capacity of the vector before inserting a large number of components. This reduces the amount of incremental relocation. Vector also has a branch of method around the enumerations and the element retrieval, which are different than the list interface and developer. So, especially those who learn Java before 1.2 can trend to use them if they are in the code. All through enumerations are faster, then they do not check if the collection was modified during iterations, which can cause issues and given that the vector might be chosen for its synchronization with the attend access from multiple threads. This makes it a particular preconscious problem. Using of these methods also couples a lot of code to vectors such that it won't be easy to replace it with our different list implementations. Mm, So here we just see the vector is a class which is similar to the traditional Java array. Expect that it can grow as necessary to accommodate the new elements. Like an array, elements of a vector object can be accessed via indexed into the vector. The nice thing about using the vector class is that you don't have to worry about setting it to a specific size upon the creations. It shrinks and grows automatically when necessary. Vector implementations are dynamic array. It is similar to the array list, but with two differences. Because vector is synchronized, vector contains many legacy methods that are not part of the collections framework. Vector provides to be very useful if you don't know the size of the array in the advance, or you just need one that can change the size over the lifetime of the program. Now we just see the program of the vector in our Java data structure, which illustrate the several of the methods supported by this collection. So here I just import a library which is a name of java.util. We have the class name which is a vector demo, and then the main method which is public static void main and string arguments. Now I just initialize the size of the three incremental array. Vector v which is equal to new vector. So here's the size of 3 and then the size of 2. Now system.out.println and the print line here is initial size and then plus v dot size here. Now here I just write system dot out dot print line and the print line here is initial capacity and then the initial capacity is v dot capacity which is used in the vector. Now here I just write v dot add and add the elements. Then here I just write new, and new is integer here, and then it's 1. Now I just copy for 1 time, 2, 3. So it's 2 here, and then 3, and then 4. And now system.out.println, and the print line here is capacity after 4 additions. And then as I just concatenate the capacity. So v dot add, and the add is an element here, and it's new, and then the data type which is double, and the value is 5.45. Now system.out.println, and the print line here is current capacity, which is the concatenation of v dot capacity. Here I just copy this code and paste it 1 time for the double, and then change the value which is 6.06. And here v dot add, and add is element here, which is new and integer, and then the integer is 7 here. Okay, now v dot add, and v dot add element, an element which is equal to new. The data type is float, which is 9.3, and then v dot add element, which is new integer, and then the integer value is 10 here. System dot out dot println, and the print line is current capacity, and then concatenate v dot capacity. Now here v dot add element, and this is add element, and now where new is integer, and integer here is 11. Then v dot add element, and new is integer, and which is 12. System dot out dot println, which is first element, and then concatenate integer, and it's integer, and then v dot first element. So I just print the first element, and then create the and then concatenate the integer which is v dot first element. Then system dot out dot println, and the print line here is last element, and then concatenate integer, which is v dot last element. Now I just used if statement. So if, and v dot contains, so v contains new integer which is, and it's integer which is 3, and then system dot out dot println, and the print line here is vector contains 3, and here I just enumerate the element of the vector. So enumeration, and the enumeration which is v enum, and then which is equal to v dot elements. And now system dot out dot print line, and the print line here is slash n, and element is vector. So while v enum dot has more elements, which is check it's return true or it's return false. So plus, then empty string, and system dot out dot print line, and the print line is null. So it's not a concatenation here, so I just write the while loop here, and then system dot out dot print line, and the print line is v enum dot next element, and then I just concatenate an empty string. Now I just checked the output for this code. So here you can see we have the initial size of this is vector is 0. Then we just define the initial capacity of the vector is 3. You can see here this is the initial capacity of the vector, which is 3. Then capacity after 4 addition is 5. You can see here we have the capacity after the 4 additions is 5. Then we have the current capacity, means after the 4 capacity we have the current capacity is 5. Then after that we have the another capacity which is 7, and then we have the another capacity which is 9 here, and then the first element I just print which is 1. So this is the first element of the integer which is 1, and the last integer value is 12. Then vector contains 3 integers, and then first element of the vector is 1, 2, 3, 4, and then you can see a 1, 2, 3, 4, and then 5.45, and then 6.05. Then we have 7, 9.3, 10, 11, 12. So we have these element of the vectors, which is the print here. So this is a simple example of illustrate a several of the method supported by vectors. I just tell you a simple difference between the array list and the vector. So in synchronization, array list is not synchronized, means which means that multiple threads can work on array list at the same time. For example, if one thread is performing an add operations on the array list, there can be another thread performing remove operations on array list at the same time in a multiple threaded environment. While vector is synchronized, this means if one thread is working on the vector, no other thread can get a hold of it. Unlike array list, only one thread can perform add operations on the vector at a time. So this is the vector in data structure. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about stack in Java data structure. A stack is logically data structure that can be logically through an linear structure and can be represented in the real life as a pile of plates or deck of cards. In this data structure, insertion and deletions of an items take place only at once of the end, which is called the top. Here you can see we have the three index which is 12, 37 and 99. So this is our top index which is on 12. So the basic concept can be illustrated by thinking of your data set as a stack of plates or books. When you can only take the top item of the stack in order to remove the things from it. So the basic implementations of the stack is also called LIFO, means last in and first out. If I add 99 as a first index, so it will be out as a last index in this stack. So it is to demonstrate the way it access like last in and first out. There are basically three operations that can be performed on the stack. First one is inserting an item into the stack, which is called push. So here we have the index 12 and we just push it into the stack. Then the second number operation is deleting an items from the stack, which is pop. So we are just deleting this 12 from our stack. And the third number is displaying the stack contents, which are peak. So this is called peak here. So the stack class implements a last in first out stack of the elements. You can think of a stack literally as a vertical stack of the object. When you add an element, it gets stacked in on the top of the order, top of the others. When you pull an element off the stack, it comes off the top. In other words, the last element you add to the stack is the first one to move, needs to first one to the comeback off. A stack is a subclass of the vector that implements a standard last in first out stack. A stack only defines the default constructor which create an empty stack, and a stack includes all the methods defined by the vector and adds several of its own. Now we just see the example of a stack, and here we have the class which is stack, and here I just import a library which is java.util, and now I just write static void and show push. Okay, and then here I just write stack and st, and here I just write int a. Here I just open the block of code, so st and then push. So push is new and new is integer which is a, and it's not a comma here, so yes, new, and it's st push. Now system dot out dot println, and the println here is push, and then I just write concatenate a, and here I just close this bracket. Now system dot out dot println, and the println here is stack, and then I just concatenate st. So here I just create the operations to show our push. Now static, and it's static void and show pop, and then stack st, and here I just write system dot out dot print, and the print line here is, and it's system out and the print line here is pop, and then I just write integer a which is equal to integer, then st dot pop, and this is st dot pop. Now system dot out dot print line, and the print line here is a, and then I just write system dot out dot print line, and the print line is stack. So this is a string here, and then I just concatenate st. Now I just define the main method, and the main method is strings and the arguments, and then stack st which is equal to new stack, and then system dot out dot print line, and the print line here is stack, and then plus st. Now show push. So here I just pushing the index which is, or a element which is 12. Then I just write show push, and the push here is st which is 50, and then I just write show push which is st and it's 66. Now here show pop means first I just add 12, 50 and 60 as an insertion operator, and then here I just write delete for show pop, and then st and show pop which is st. Okay, now exceptions, so try show pop which is st, and then here I just catch the exception which is empty stack exception which is e, and now system dot out dot print line, and the print line here is empty stack. Okay, and now here, so here I just add a method or create a method to pop and push. Now I just run this code. So here the pop is null and the pop is null. At the initial stage we have the stack which is empty. Then sorry, at the initial state we have add the value which is 42, then we push the value which is 66, and then 99. Afterwards here I just execute the value from the stack, so empty stack is empty, and then the stack is empty. So these are the push, sorry, the pop means we just delete the values from the stack. Now here we just see the another example of dynamic stack in Java. So here I just write private integer stack size, then private integer and stack array. So here I am creating the example that the stack will never comes to the Stack Overflow case because its capacity will keep increased and it's reach to the maximum capacity. So it is very dynamic in capacity here. So integer and then take an integer as a top. So here I just create a constructor to create the stack with size. So public and my, so public and dynamic stack, and then I just write integer and size. Okay, and then here I just write this dot stack size, which is equal to size, and this dot stack array, which is equal to new integer and stack size. So here close with the semicolon and this dot top, which is equal to -1. Now here I just write the method public void and push. So this methods add a new entry to the top, an integer entry. Then I just write if and this dot is stack, which is full, and here and stack dot full, and then I just write system dot out dot print line, and the print line here is stack is full and increasing the capacity. Okay, now this dot increase, which is stack capacity. Now here and here I just write system dot out dot print line, and the print line here is adding and then entry, and it's a concatenation of entry. Now here after that I just write this dot stack array, and which is plus top, and which is equal to entry. Okay, now after that I just create the method, means this method to remove an entry from the top of the stack. So that's case I'm just writing integer, public integer, and then pop for the deletions, and then throws exception, and it's throws. And here I just write if and this dot is stack, which is empty, and then here I just write throw, which is new exception, and here I just write stack is empty, cannot remove element. Now after that I just write int entry, which is equal to this dot and this dot stack, which is array, and the array which is equal to top minus minus. and then system dot out dot print line, and the print line here is remove entry and remove entry. Okay, then concatenate entry here. Now return entry, and after that I just create the method to return the tops of the stack without removing it. And our this method was for math for remove an entry from the top of the stack. But now we are just creating the methods to return the top of the stack without removing it. So public, long, and peak, and then return stack array, which is top. And here I just write private void increase stack capacity, and integer, and then new stack, v is equal to new integer, and this dot stack size. So our stack size is multiplication of 2 here. Now for integer I, v is equal to 0, and I which is less than stack, and then I plus plus. Now new, and new is stack here, and stack is I, and here it's a stack size, and I which is equal to this dot stack array, and array here is I. Now I just write this dot stack array which is equal to new stack, and then this dot stack size which is equal to this dot stack size. So stack size is multiplication of 2. Now here I just create the methods to return the true if a stack is empty. So public and boolean, which is stack, and stack is full, and then return, return is top, which is equal to stack size, which is minus 1, and here I just write public static void main, and then string arguments, and then here the name of the class which is dynamic stack, and here I just write stack which is equal to new dynamic stack, and the value of it is 2. And now I just write for integer I which is equal to 1, integer I which is less than 10, and then I plus plus means the increment operator, and then stack dot push which is the entry of I, and then for loop again for integer I which is equal to 1, and I which is less than 4, and then I plus plus. So now the exceptions, so stack dot pop, and then I just catch this exception, So it exceptions E, which is to generate the catch block automatically. E dot print stack trace. Okay. So here I just create the method to this stack empty, and yes, I have no error in program, and I just run this program. So you can see here at the initial stage we are just adding the value which is 1 and then 2. So I just add 2 indexed, and stack is full, increasing the capacity. Then we are just adding 3 and 4. Then stack is full, increasing the capacity. So you can see here we just write that we are just enter the 2 size stack here. So after that it increasing the capacity, and then 5, 6, 7, and 8. So just double of the size of a stack, means which is 4, 4 integers, yes. Then stack is full and increasing the capacity when, and then we just add the 9. You can see here it's up to 9. Then we just remove our entity which is entry which is 9, 8, and 7, because it is stack. So this is first in, then second number, third, fourth. So first in and last out, and last in, first out. So first of all, I just execute 9, then execute 8, and then 7. So this is an example of the dynamic stack in Java. When we just listen or hear the word of stack, so example in our mind which is the towers of Hanoi. Now we just see the example and see what is the towers of Hanoi. The towers of Hanoi is the mathematical game or a puzzles. It controls it consists of three rods and a number of discs of a different size, which can slide into any rod. The puzzle starts with the disc in a next stack and ascending order of the size on the one rod. The smallest at the top, thus making a conical shape. The objective of the puzzle is to move the entire stack of the another rod, obeying the following rules like: first of all, only one disk must be moved at a time. Each move consists of taking the upper disk from one of the rod and sliding into another rod on the top of the other disk that may already be present on that rod. No disk may be placed on the top of a smaller disk. Mean if a disk is bigger than another disk, so no disk will be top of the smaller disk. Now we just see the diagram of the Tower of Hanoi. As you can see, the rule number first, the one element on the disk must be moved at a time. Then each moves consist of taking the upper disk from one of the rod and sliding into another rod on the top of the other disk that may already be present on the rod. No disk may be placed on the top of a smaller disk. So here you can see we have the three step, means the three step Tower of Hanoi. The first one you can see here, it's moved to the destination. This is our source, this is our destination, and this is auxiliary. So we are moving our this tower from source to destination. So this is the process. So here you can see the smallest element moved to the destination, then auxiliary, and then it's moved to destination, then source, and then destination, and then destinations. So this is the example of the tower of the Hanoi. Now we just see the programming example of the tower of Hanoi, and we solve it by using the stack. I just create a class which is a name of tower of Hanoi. Now here I just write private and then static and write my or dynamic stack, then array, and then write tower. Now public static void and then tower of Hanoi. And the tower of Hanoi is integer, which is a number of n. So the any number here. Now I just create a three stack tower of Hanoi. So I just write tower which is equal to new and this one dynamic stack and then the for. Now for and the integer I which is equal to 0 and I is less than or equal to 3 and then increment operator which is I plus plus. Now tower the array of I which is equal to new and dynamic stack and then element of 4. Now for integer t which is equal to n, so n are the numbers of this integer and d is greater than 0 and d is decrement operator. First I just create the stack of 3 tower of Hanoi and then I just writing the decrement operator and here I just initialize means add disk d to the tower number 1. So here tower is the 1 and then dot push and which is new and integer and d. Okay, now show tower and states which are n 1 2 and 3. So it's move n disk from the tower number 1 to the tower number 2 using 3 as a intermediate tower. Now I just write public static void and show tower states which are int n, int x, int y, and int z. Now if n is greater than 0, so it's 0 and exceptions are try which are show tower states and n minus 1 and then x, y, z. Now here I just move d from tower x. So integer d which is equal to integer which are tower x dot pop and now I just move tower to the top of the tower y. So tower, not move tower but element, yes, y dot push and here the entry is d. Now system dot out dot print line and the print line here is move disk and then concatenate d and plus from tower. and then I just write concatenations of x and to top of tower, which is y. Now show tower, which is states, and then n minus 1 and z, y, and x. Now here I just write catch, and catch is an exception, and its exception, which is ex. And after that, I just write the main method, which is public static void main and string and arguments. Now here I just write system dot out dot println, and the println here is running 3 disk problem. Now here we just run our 3 disk problem and tower of, and here it's tower of Hanoi. Okay, and these are the 3 disk. Now here I just create class which is my dynamic stack. Okay, and here I just write private integer stack and the size, and I I just already write this class, so there is no need of writing this class again. So this is the dynamic class. Okay, so I just run this tower of Hinai now, and you can see first of all it is running the 3 disk problem. So I think this example is mixed with dynamic stack example. So, and here I just write the stack is full and increasing the capacity. It's the same here, and then system dot out. So I just remove this system dot out dot println, and then pop integer means integer pop throw exception, and then throw same like this one. And here I just write I just not write here, so long peak, and it's a return, and the return is the top here, and then the private, and then string and the size here. So now the boolean, and then the boolean size, stack size, and add the last public static void, and now I just run this code. So new stack, so local variables, so the field here, and now just check. And yes, I just removed this one, sorry. Like we just remove entry, means from our first tower, means source to destinations, and then I just remove second one to the source to auxiliary, and then here after that I just move disk 2 from tower 1 to the top of the tower 3, and then after that I just move disk number 1 to the tower of the 2 to the top of the tower 3, and then I just move disk number 3 from the tower number 1 to the top of the tower number 2, and then move disk 1 from the tower number 3 to top of the tower number 1, and move disk 2 from tower number 3 to the top of the tower number 2, and then move disk 1 from tower number 1 to the top of the tower number 2. So this is the example of the Tower of Hanoi with Java. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about queue in Java. A queue is a container of an object, which is a linear collection of the data structure that are insert and remove according to the first in and first out principle. In last lecture, we learned about the stack, which is a concept of first in and the last out. So queue is the opposite to stack. An excellent example of a queue is a line of student in the food court. New additions to the line are made to the back of the queue, while removal or serving happens in the front. In the queue, only two operations are allowed. Number one is enqueue and number two is dequeue. So a queue is a kind of abstract data types or a collection in which the entities in the collections are kept in order, and the only operations on the collections are the addition of the entities to the rear terminal position, which is called enqueue, and removal of entities from the front terminal position is called dequeue. As I told you, queue is a concept of FIFO, means first in and first out. So queue provides the services in computer science, which is a transport and the operations research where various entities such as data, objects, persons, or events are stored and held to be processed later. In this context, the queue performs the function of a buffer. So there are some operations what we do on the queue. First one is in queue. Here you can see we are just seeing watching in queue. So in queue means add an item into the end of the queue, which is tail. When we just add the items from the tail, which is called in queue. Then it's front. So front return the item at the front of the queue. And you can see dequeue. So dequeue remove or delete the items from the front of the queue. Now we see overflow states. So a queue may be implemented to have a bounded capacity. If the queue is full and does not contain enough space to accept an entity to be pursued, the queue is then considered to be an overflow state. And what is queue underflow? The dequeue operations remove an items from the top of queue. A dequeue operations either retrieval previously cancelled items or return in an empty queue. But if the queue is empty, it goes into the underflow state, which means that no items are present in the queue. When no items are present in the queue, it is called underflow. And when queue is a full stage, so it's called overflow. Now we just see a simple example of the queue with arrays. Here you can see I just creating the package here, and then here I write queue array. Now here I just write integer, which is capacity, and the capacity which is equal to 2, and this is the private here. Okay, now I just write the integer for queue, and queue is array here, and then integer which is front, which is equal to 0, and then int rear, which is equal to -1. Now integer, which is current size, which is equal to 0. And then here I just write public and q array. So this is a constructor for our q, means here I just create a default constructor for my q. Now, and yes, now I just write q and array, which is equal to new integer, and this dot capacity. So this is a copy and yes, so it's okay. Now here I just define the method to add the element at the end of the queue. So that case I just write public void and in queue. Okay, so what is the in queue here? So you can see in queue when we just add the element through our tail. So this is called in queue, and dequeue when we just delete the element from it. So it's called dequeue. So in queue, and this is the parameters for our this method, which is item. And now here I just write if is queue full. So system dot out dot print line, and the print line here is queue is full, and increase capacity, and increase capacity, and then I just go to the rear where we just add the value. So it's a plus plus here. So now I just write if rear is greater than or equal to q array dot length, and here I am just using the AND operator, which is the current size, which is not equal to q array dot length, and here I just write rear, which is equal to 0. So the initial value of the rear here is 0. Now q array and then rear, which is equal to item, and then current size increment here, means the current size plus plus. Now system dot out dot print line, and the print line here is adding and then item. Okay, and here I just write q array and rear, which is equal to item. So rear is a array here. So I will I will go to the another method to dequeue the items from our top of the queue, means to remove the element or an items from our queue. So public void dequeue, and if is queue empty. So system dot out dot print line, and the print line here is queue is under flow, means under flow means queue is empty here. So unable to remove element from queue. And here I just go to the else statement. If queue is not empty, then font is plus plus, sorry, the front is plus plus, and then if front is greater than q array dot length. So what will be the output? Length minus 1. And here I just write system dot out dot print line, and the print line here is removed, and then plus q array, which is our object, and here I just write front minus 1, and this is else statement. Now here our front is empty, here means front is 0, and then else system dot out dot print line, and the print line here is removed, and then concatenation of q array and front minus 1. Now current size minus means the decrement operator, and now here I just create the method to check whether q is full or not. So that case I'm just using boolean here, which is q full, and then boolean, which is status of the queue, means the status of the queue is empty or not. So here the status is false. So if current size, which is equal to queue array dot length, queue or array dot length here, and then the status, which is equal to true, and then return status. Okay, and this is true here. So this statement will check if the queue is full or not. So now after that, I am just creating the method to check the queue is empty or not. Means if our queue is empty, so this will check, this method is checked by, so it's a boolean and is queue empty, and then boolean status, which is equal to false, and current size, so it will check the current size here, and then status, which is equal to true, and here I write return status. Now private void and increase capacity, and then in this method I just write, so I just create a new array with the double size as the current one. So an integer new capacity, and capacity, which is equal to this dot q array dot length, which is multiplication of 2, means we just taking the array size double, and then integer, and integer is an array of new array, which is equal to new, and integer is new capacity. Here I just write integer, which is temp front, and which is equal to front. So this element will copy to the new array, means the copy from rear to front. And integer index is also copy the rear from front. So here index is -1, while true. And then here I just write new array, which is concatenation of indexed, and this dot q array. So the array elements are temp front. Okay, and here I just write temp front, which is equal to 0. So temp front. So I just concatenate this front here, and then I just write if conditions for temp and temp front, which is equal to this dot q array dot length. And then here I just write temp front, so it's a tmp, temporary front, and which is equal to 0. And here I just write if condition, so if current size, which is equal to indexed, and index is add one element with it, so break statement here. And after this break statement, I just make a new array in the queue. So this dot q array, which is equal to new array, which is system dot out dot println, and the println here is new array capacity, and then this dot q array dot length. Now I just reset all the values from the front and the rear, means all the value from the tail and the head. So this dot front and this dot rear, which is equal to 0. So not rear equal to 0, it's rear equal to indexed. Okay, now we just come to the main method to define. First of all, I just create an object to it. So this is the q array, and now, sorry, it's here, public static void main, and string arguments, and then q array, and q, which is equal to new array. So I just create an object, so I just call object for in queue, and here I just write the item, which is 4, mean I just add the item which is 4, then q dot in queue, and here in queue is empty. I just not add any item here. So after this in queue, so I just write q dot dq, means I just add this for and execute this for. Now here in the in queue means add 56, then q dot in queue, and here I just add 2, then q dot in queue, and I just add 60, then q dot in queue, and I just write 24. So after this 60, I just write q dot dq, So I just execute one another element again. Means here I just add 4, then I just dequeue this add, so it will go to the this stage, means this index, and then I just add 56, so 4 is here, then I just add 2, 4 is here, then 60, then 4 is here, then I just dequeue, so 4 has come to this stage, and now we just see the 24, and then q dot in q, which is 98. Now q dot dq, q dot dq, and q dot dq. So I just execute 3 index again, and then q dot in q, and I just add one another element, which is 300, and then q dot dq and q dot dq, and execute 2 more elements. Now we just see the output. So here I just write change is q to empty, and then execute it. So here you can see, first of all, I just add 4 in our queue, then 4 removed from this queue. You can see here 4 I just add here from the tail, and then 4 is removed. Then the 4 is removed from the queue. Then we add the 2 elements here, which is 56 and 2. So here you can see I just define the capacity of the 2. So the queue is full here, now increasing the capacity. Now the array size is double here, where you can see this statement like integer new capacity, which is equal to this dot array, sorry, this dot q array dot length multiplication of 2, which is 4 now. Now here you can see that I just add the 4 here first, and then 4 removed from this. Then I just add 56 and 2. So our queue is full. So now it is increasing the capacity. So new array, which is the size of 4. So we have 1, 2, 3, 4. So I just add 60, 56, 24, and 98. Then I just remove 2 from here. You can see I just add here 2, means we have the 2 size of array, this one, and then 4, 1, 2, 3, 4 size. So we have the total elements are 2. Then I just remove 2, and then 60. Then I just remove 24, and then I just add here the value, which is 300, and then I just remove, means dequeue, this 98 from this queue, and then at the last I just remove this 300 from our queue. So this is the example of the dynamic queue implementation using array. So a queue is a kind of abstract data types, or the collections in which the entities in the collections are kept in order to in order, and the only operations on the collections are additions of the entities to the rear terminal position, which is called in queue. Means here the rear is in queue and the front is dq. Front is dq. Now we just see the example, and we just see the double-ended queue, where we can delete or insert both the side of the queue. Let's see. So this is the example of the double-ended queue in Java. You can see here we can delete from this side, means delete from front, and the delete from rear, and we can insert from the rear and insertion from the front. Means here insertion or deletion from the in queue and insertion or deletion from the D queue, means tail or head. So what is the ended double-ended queue, means DQ? A double-ended queue or a DQ is an abstract data type with generalized a queue, for which elements can be added to or removed from either the front or rear. DQ means DQ is differ from the queue abstract data type or first in first out data type, where elements can only be added to one end and removed from other end. This journal class has some possible subtypes, which are an input restricted DQ is one, where deletion can be made from another both the side, but insertion can be made with one end only. Means we can delete both the side, but insertion from one side only. An output restricted DQ is one where insertion can be made at both the end, but deletion can be made from one end. Means in our double-ended queue, we can insert or delete the value in both ends. So you can dequeue a stack by making insertion or deletion at the same side, but you can use dequeue as a queue but making in setting elements at one end or removal element and other end in our queue. Now we just see the example of this dequeue in Java. So here queue and the class dequeue, and here I just write private and list, and then integer, which is dequeue, which is equal to new and array list and integer. So integer here. Okay, so this is an object, so private list and the dequeue, so I just write here dequeue1. Okay, and now here, so first it's not taking the list here, so I just import a library which is tower.util and util.array list. First one, so it will take the array list here, then import java.util and its list here. Okay, and this will take this list. Okay, now I just write public and void insert front and then integer which is item. Now here I just write, so it's the insert front. Okay, now I just add element to beginning of the queue, means we just add element in the beginning of the queue, so print line, and then here I just write adding at front, and then I just concatenate item here. Okay, and here I just write dequeue1 dot add, which is 0 and item, and then here I just write system dot out dot print line, and the print line here is dequeue1. Okay, and this is our dequeue1, or I just change with dequeue. So here I just write array list. Okay, so here I just not add the body, so that's why it's making the error in the program, and then it's a dequeue here. Okay, now Here I just write public void and remove. So remove is a font here. Now if dq dot and dq dot is empty, so system dot out dot println, and the print line here is dq is under flow, unable to remove, means you can not be remove the index or items from this dq. So return here, and then here I just write integer remove, which is equal to dq dot remove, and the value of the remove here is 0. So it's dq. Okay, so this will remove an item from beginning of the queue from here. Now system dot out dot println, and the println here is remove from front. Okay, and then plus remove means this integer, concatenate this in integer, which is rem, and remove, which is dq, and then we just go to the public and void remove rare, and if dq is the empty, so system dot out dot println, and the println here is dq under flow, unable to remove, and return, and here I just write integer, and integer here is rem, which is equal to dq dot remove, and here the item is index dot size, so size is -1 because I am just dequeuing the value from it. So it will remove the items from the beginning of the queue. So system dot output message here is, so the message is removed from front, and then plus rem, and then system dot out dot println, and the println here is dq. Okay, and here after that I just write public integer and peak, which is front. So this is our peak point, which will get the element from the front without removing it. So item, which is equal to dq, and dq is get, and get value is 0. Now system dot out dot println, and the println here is element at first, and then plus item, and now return, so return is the item here. Now public integer and peak for the rare means to add, or so here in this method I just get the element from the rare without removing it, and item, which is equal to dq dot get, and it's dq dot size, and the size here is -1. Now system dot out dot println, and the println here is element at rear and plus item here, and then return. So it will give us the return value, which is item. Now we just come to the main method and create an object and call the object for each enqueue and dequeue. So main and string arguments, and here I just write the name of that, so it's dequeue, and so create an object to my this class. So dequeue, which is deq, is equal to new and dequeue. Now dequeue dot insert front, which is 34, then dequeue dot insert front, which is 50, and dequeue dot delete front means remove dot remove front, and deq dot remove front, and then deq dot remove front. So yes, I just removed 3 front, and now deq dot insert front, value is 21 here, and deq dot insert front, so value is 98, and deq dot insert front, which is the value of 50, and deq dot insert front, which is the value of 43, and deq dot remove front. Now here and here I just write capital I and did one other mistake, which is the colon here. Now I just run this code. So first of all, I just add a value in the front, means value from this one, so which is 34, then add from the front is 50, then remove from the front is 50 and 34, and then it's 34. Now our queue is empty in this stage, and then dq is under flow, means dq is empty here, mean we just come to the this stage. Now I just write adding at the front, which is 21. So adding the front here is 21, then adding at the front, which is 98, and we have the two value which are 98, 21. Then I just add 50 in the front, so 98, 98, 21, and 50 here. Then I just add 43, so the queue is going to 21, 98, 50, and 43. Now I just remove 43, means I just delete this 43 from this side, so it will execute 43, then 50 comes here, 53, so 98, 50, sorry, 98 and 50, so 98 comes here, and then 98 will delete, and then at the last 21 will delete in this queue. So this is the example of DQ, means double-ended queue in Java. Thanks for watching this lecture. See you in next lecture.